Good morning, everyone. My name is Jeff Weiss. I'm with the Pipeline and Hazardous Materials Safety Administration. I'd like to take this opportunity to welcome you. Many of you, I think, are probably from Houston. I hope you'll bear with me for a second as we get going. I'd like to welcome folks on the webcast, too. We're webcasting this. We'll try to figure out how many people might be joining us that way and report back to you by tomorrow. But I can tell you that it's a heck of a lot warmer here than where we came from. So I'm happy to be here in Houston on Fat Tuesday wearing my crawfish and Tabasco tie. So happy Mardi Gras to everyone. Again, I'm here representing PHMSA, the Pipeline and Hazardous Materials Safety Administration. I would bring you greetings from Brigham McCowan, who is our acting administrator, and Stacy Gerard, who is our Pipeline Safety Program leader. She will be delegating her comments, I believe, to Ted Wilkie, who'll be speaking in just a second. But I also wanted to welcome you on behalf of the National Association of Pipeline Safety Representatives. As many of you know, they are one of our key strategic partners, and I'm pleased to see them backing and supporting us on this effort. So I'm coming up just to do a couple of administrative remarks, and I'm going to turn the podium over to Ted Wilkie, who is our deputy. Just a couple of quick things for you, if we can, to set things going. You'll see the safety exits marked all right here, and as far as I know, Juan Carlos, it's down and out in this direction. The restrooms are also right down the hall to my left, your right. And a quick reminder on cell phones, if you would, please put them in vibrate mode. I got to remind everybody, including myself, of that. It's also, if you'll help me, just do an informal survey. It's good for us to understand our audience. So two things. One, who can tell me, did you travel today? Anyone who traveled from outside of Houston to come here? If you just show a hand. Pretty goodly set of number. Okay, good. Thank you very much. Another show of hands, if I can, just so you have a sense on who's here and who we're all talking with today. Anyone who's representing either the federal or state government, if you wouldn't mind, raise your hand. So again, a fair number of people. Hopefully we'll have a chance to talk about people who are directly involved in the pipeline industry, working for pipeline companies. Great, thanks. Obviously one of our key audiences. And then the vendor community. Another key audience. Thank you very much. Appreciate it. And anybody, I have to ask, no one will raise their hand. Is anyone here from the media? Okay. If you find someone from the media, just point to them. Okay. Just really quickly, there's not too many handouts. Bob Smith has provided a handout on the front table, which you can grab if you didn't on the way in. But we will put copies of all these presentations on our website. And you'll be able to download them there. So, if you're interested in something, you don't have to take furious notes. You'll be able to get the presentations later. We make it a point not to provide attendance lists, so I'd like to ask, don't ask. It's, as far as I can see, it's a Privacy Act violation. People sign up for this for one purpose, and I don't intend to provide their names to anyone for another purpose. There will be plenty of time in this session for Q&A. There are a lot of opportunities for just standing up at the mic, but I know not everyone is comfortable with that mode, so we do try to provide 3x5 cards. I believe they're at the registration table. Okay, Juan Carlos has those back there. Feel free to grab them and hand them in at the registration table or to any of us. If you do come to the mic, we'd ask you to state your name and affiliation and keep it simple. This is strictly about a dialogue. It's not here to promote our companies or our agencies in our case, so we'll try to keep that simple as well. So with that, I'd like to turn it over to Ted Wilkie, who is our Deputy Associate Administrator.
Good morning. Welcome to our mechanical damage workshop. I was going to also ask for a hand, which is a Jeff Weiss trick, but I'm going to say that if we're going to assemble this many high-powered people in one place, the problem better be important, and it is. Mechanical damage is still the biggest safety issue we're confronting in the pipeline industry. Before I get started, I want to indicate that PHMSA, the Pipeline and Hazardous Materials Safety Administration, is 1 year old this month, and we've had a busy year. Certainly, we've continued to implement the integrity management program for hazardous liquid and natural gas transmission companies, and we're taking a new look at distribution integrity management, which was recommended by the Office of the Inspector General. We're pursuing a number of other regulatory initiatives, most notably, I think, controller certification, with a major report coming out this year, and gas gathering. As you may know, definition of gas gathering lines has been the longest standing congressional mandate for the Office of Pipeline Safety, running back some 30 years. And I think we finally, cross our fingers, have that initiative off the ground. And as to hurricanes. It seems to me that August and September will forever be linked in my mind with the hurricanes, and doing hurricane duty to see if we couldn't do something to keep gas and aviation fuel flowing to the East Coast. There was a time at which the pipelines, the two major pipelines, were down, and we worked with those companies to bring them generators, electric power, and get them back online, or there would have been a far more serious crisis than there was. Over the last 5 years, we've seen a significant amount of progress in terms of pipeline safety. If you take a look at the last 20 years, there's been a significant decrease in the number of significant accidents, serious accidents involving deaths and injuries. If you look at any 5-year period and over that 20 years, you'll see a different picture, because the variation in deaths and injuries for any given 5-year period is much greater. It's hard to discern the trend, but the trend is certainly downward. Since Bellingham and Carlsbad, we've had significant new emphasis on integrity management. There were many, many new requirements that came out of the Pipeline Safety Improvement Act of 2002, and I think it's fair to say that we've been working strenuously, to say the least, on implementing those requirements. One of the best parts of our program, I think, is the investment in research and development and new technology that has came out of PSIA. We're spending about $9 million a year out of PHMSA, and that's been matched more than dollar for dollar by the industry. We've seen significant improvements in best management practices for reducing the potential for excavation damage. These efforts have been led by the Common Ground Alliance and the efforts that it spawned. But mechanical damage is still the leading cause of pipeline failures. If we look to the future, we are looking forward to the rollout of the 811 nationwide number for one-call systems. We think this is a significant new event that's going to bring real attention to the problem of excavation damage, and hopefully it'll bring other industries into this picture as well. We are focusing intensely on distribution integrity management. One of the reasons is the fact that integrity management has increased public confidence in pipeline safety. And the view is that if it's good enough for the gas transmission and the hazardous liquid pipeline companies, it must be good enough for the distribution companies. The whole promise of integrity management is that we address problems, find defects before they can become failures. As we look to the future, we're also looking at synergies that can occur between advanced technologies, improved materials, new ways of fabricating and constructing pipelines, our emphasis on integrity management, and new knowledge in general. And yes, we still need better technology for mechanical damage. So why are we here? PHMSA has awarded Michael Baker Jr. Incorporated an umbrella study for take a look at the framework for mechanical damage. We asked them to take a look at mechanical damage issues across the board, not only technology, but how it relates to integrity of systems, incident history, the level of risk, the potential for line rupture, detection methods, mitigation methods, repair methods. And together with the Baker study, we hope to develop a benchmark for understanding mechanical damage in terms of how do we define it, how best can we detect it, how do we prevent it, and what can we do to mitigate mechanical damage. There's some real challenges in this problem. First thing is the whole pipeline system is vulnerable to mechanical damage everywhere. One of the questions is, should we focus on particular areas, high consequence areas, or should we be focusing everywhere on the pipeline infrastructure? Can we find damage before a failure occurs? The damage to a system may be latent. It could be there from the time of fabrication or construction. It could be put into the line by human contact the day after you've made a picking run. It's very difficult to detect. There's a seeming randomness of this. Unlike corrosion, where you might be able to determine that something is happening over time because you see similar things happening in other places, the localized nature of mechanical damage makes it very hard to deal with in terms of preventing it or detecting it or being able to do something about it. We also know that development is increasing the problem as people and pipelines grow closer together. Where formerly rural pipelines are now part of the urban environment, we know that there's increasing exposure to mechanical damage, excavation damage around it. We saw this in the TRB report. And yes, the technology is inadequate for mechanical damage. So what is your charge here? Help us define a common understanding how to look at and think about mechanical damage. We need a common frame of reference. We need to recognize that there are variations across the country, variations between segments of our industry, variations across operators, across regions, between small operators and large. Help us to understand the state of technology. Over the last 20 years, as part of this industry, the same terms that we were using 20 years ago are still being used today. It's not clear how much progress. We're able to do some things better, but still we're not able to do some things at all. Help us align our strategic approach and our goals, and help us provide guidance to the Baker Company on their mechanical damage study. With that, I'm going to turn this over to Dave Johnson. He's going to give the industry perspective.
Thank you, Ted. I'm Dave Johnson with Panhandle Energy, and on behalf of the pipeline operators and their service providers, I'd like to add my welcome and encouragement to participate not only in the workshop today, but in the study that this is the kickoff for. I think it's something that's vitally important to our industry. From the industry perspective, what's the problem? What's the big deal? I think we all know this. That I don't have all the numbers and statistics, and people are still working on those, but up to half of the pipeline incidents and accidents are caused by mechanical damage in one form or another. And most of those failures, I think we have seen, occur at the time of damage. That makes these particularly dangerous because there's always somebody there. It's not something that's going to happen in the middle of the night. There's a guy sitting on a backhoe or a tractor that's right there who is immediately at risk. So this is an important deal. In recent years, I think the data suggests very strongly that we have seen very few, if any, previously damaged pipe failures. That number seems to be decreasing. And I think that's something that as we work through this study really needs some investigation. We need to understand why that's happening, because that's an important fact. And who's causing the damage? I think we tend to think of this as third-party damage, and that's somebody on a backhoe. Sometimes they've called one call, sometimes they haven't. Sometimes the line has been properly marked. I'd like to think on very rare occasions it hasn't. But it's also us. The first and second party damage. We hit ourselves. And that's something we need to take a hard look in the mirror, we operators and the people who are out there working for us, at our processes, how we do these things, because that's an area that we ought to be able to improve right away. So how do we do this? I think, and it shouldn't be any big surprise here that this slide is going to look a lot like the topics for the rest of the couple of days here at this meeting. More effective prevention. We need to address both immediate and delayed. We need a better understanding of these things. And I think in terms of prevention, we probably have a different set of needs and processes and procedures to address third-party damage versus first and second party. So we need to look at both of those. And then I think we need a means of assessing existing damage when it's found. This is for safety purposes, certainly, but also for efficiency or resource allocation. I think we're finding a lot of our immediate response conditions as we're out here inspecting the pipelines. A lot of these are due to deformation, mechanical damage with associated metal loss. And you know, that sounds like, okay, somebody has hit the pipe or it's corroding in a dent or something like that. And we're finding a lot of those, but we're not seeing a lot of failures from those. So that kind of tells me that maybe they are being over-categorized a bit, and we need some better tools to assess their seriousness and do a better job of resource allocation so we can better utilize what the time and people we have available to us to make the biggest improvements in safety. So I think these are going to be the topics for the next couple of days. A friend of mine suggested this topic here to me a few weeks ago. And that is, you can think about this as layers of protection around the pipeline. If you start way far away from the pipeline, away from the right-of-way, we do education, provide information about pipelines. We do this with public awareness and public education programs and information about one calls and that sort of thing. Then when you get closer, when you get near or on the right-of-way, you want to keep people and equipment off unless it's done in a controlled fashion, and you want to make sure that one call is used when working near right-of-way, and we want to effectively monitor excavations where necessary. When we're on the pipe, we need to report all damages. I think that's very important, that any damage that goes unreported is a potential safety problem down the road. And we need assessment tools for damaged pipelines. I think that one's very important also. So the technology needs, we need to identify where technology can help us, develop that technology, and effectively implement it. Those technology needs, I think, fall in a few categories. One is prevention methods. That revolves around how do we communicate, how do we locate both pipelines and people who are working around it, and how do we do these things efficiently. Detection and characterization, I think we need to talk to the folks who do the analysis of this, find out what the data needs are, what kind of things do we need to know to adequately analyze the defects that are in pipelines, and then we can develop and enhance our analytical methods and detection methods to do that. Find out what our data needs are, where we're going to get that data. Can we get it from current technology, the ILI, various types of ILI tools available to us? Can we get information from some of the data that we've collected in things like the vintage pipe report, the history of line pipe report, and other work like that that's been done, and identify any other data needs, and then figure out how we're going to get it. So for the next couple of days, I think we're going to hear some folks telling us about where we are now, what our opportunities for improvement are, and most importantly, how we're going to get there. Again, I encourage, I think a lot of you will be contacted and have an opportunity over the next few months as this study progresses to provide some more input to the Baker folks who are doing this. I encourage you to take advantage of that, get your ideas out there, at the end of the day, I think we'll be able to do some good work here. Thank you very much.
If you give me 1 second while we load Keith Meyer's presentation here. Just a quick comment, if I can. Both Ted and Dave touched on this topic. There's been a fairly widespread group who are responsible for pulling together this workshop. I'd be doing them disservice if I didn't stop to thank them. We'll be showing you who all was represented in this, but in a little bit later. But what I would like to say is reiterate the key point that both of them made. The purpose of today's meeting, as well as just discussing the technologies that are out there and making sure that we all understand, is really to create the input to this benchmark study. We've done this before with stress corrosion cracking. I know many of the people in the audience, and you were involved in that meeting too. I'll come back and hit on this point if I can, but I will at some point ask Keith to introduce his team, because I know there's at least 4 people here from Baker right now, and they're going to be really key assets for you. If you have ideas either today or tomorrow or during the course of this study, we'd like you to try to channel those into the Michael Baker study. Thank you. Keith?
Well, thank you very much, Jeff. As a matter of fact, I'd be proud to introduce the team right now. Christine Marinette and Paul Carson here from Michael Baker. And please, you'll see us around the next 2 days. And this is, we're trying to collate all this information, both from these 2 days as well as from the extensive pre-study that we've been doing and the in-depth study we'll be doing over the next few months. So please come and talk to us, either to tell us your ideas in the next 2 days, or we're going to be soliciting your help in the future, and we really appreciate it. But I am Keith Meyer. I'm a Vice President and Chief Pipeline Engineer for Michael Baker, and we do these studies for the Office of PHMSA right now. And our last study was the stress corrosion cracking study, which was a format very much like this. A first phase, a detailed study outline, a smallish group to kind of work the issues, and I think you'll have pass-outs of some of the details and some of the things that we've already uncovered and tried to put together and collate for this study that was given to you at the door. The end of that pre-study, perhaps as you call it, is a workshop like this, in which we bring interested groups from the regulatory as well as from the operators and consulting people to come together and talk about these issues, not so much to actually, if we could solve the issues, but more or less to frame the issues as to what we want to study in depth. Our study really is not to try to figure out any analytical issues of mechanical damage. It is not to do any laboratory studies. It is not to come up with new analytical investigations and equations. It is really to give everybody, both regulatory and industry, an idea of where we are today, and perhaps an idea of where we want to be tomorrow. We did create a website for public comment, and it'll be out there for a while. A little bit of help would be certainly in order here. We had a few people on the website, and if you have brought your laptops with you, it's still up. Why don't you get on it and see what's out there? We have some other studies out there on dense study and pipe wrinkle study, which we have done in the past, and will be subsidiary studies now to this omnibus study on mechanical damage. But we solicit your comments on any of these. We have also created at the bottom of it a little link for your comments. You can just make any comments you like, but we also ask a number of questions in which we're asking some details very relevant to the mechanical damage workshop and to our study in the future. This website will be up for a while, and it's our main link communication with this group and with anybody else interested. We will be talking about our progress through this website and finally putting up the draft copy of the website, which we always put out there for public comment before we finally issue it, just as we did for the SCC study. So again, we're hoping that you take advantage of this workshop, as well as this website, and keep involved with it, especially through this website. The things that we've asked in our survey questionnaire, and we're coming here with completely open mind here. We just have questions. We don't have answers. How do you define mechanical damage? The most basic of all questions. Do you define it in a very code-formulated framework? Is that the way we want to define it for the study? Or do we want to expand it out to include first-party, second-party, third-party damage, construction, almost anything? What are the sources of mechanical damage? Most of the people know what the general sources, but really the idea here is which ones are the focus issues, which one have the most significant impact on on your pipeline system as you define mechanical damage. And maybe even a little bit more importantly, if you could tell us why do you think that is, or why do you know that is? If we know why, perhaps we can focus on some of the issues to uncover how to prevent it in the future. Are there classes of mechanical damage? We've struggled with this quite a bit, and right now we don't have an answer. Once again, we're looking for the characterization people probably to talk to a little bit about dents, gouges, metal loss with these things, which present the greatest integrity to your system, not only from a direct, given it's there, what do you think the failure problem is, but perhaps what is it an integrity threat because I can't see it until it's too late. In your experience, where has mechanical damage been the greatest problem? And what methods for screening a pipeline segment for the likelihood of mechanical damage have proven to be the most effective, have been proven to be the least effective? Where do risk models in your experience come into play when looking at mechanical damage? This is probably the first issue that we're really focused on, and if we answer this a bit, I think we'll have a little bit better idea as to how to draw a cloud around this issue. How is it defined? We're talking both metallic and non-metallic pipe. It's caused by some outside force, and this could be scrapes, scratches, gouges, possibly metal loss. Are dents involved in this? Are there wrinkles a part of mechanical damage? Is it caused by movement of the surrounding soil, landslides, or earthquakes, mechanical damage, subsidence, washouts? And we're probably talking about both onshore and offshore, and if you talk about offshore, you're bringing in other parts of mechanical damage and how that might be caused. This is I'm from Anchorage, Alaska, and so mechanical damage, I'm looking at the bolt hole at the TAPS pipeline and saying, yeah, I guess that's mechanical damage. Most people think of backhoe, but sure, that's in there. In my opinion, and there's probably some other things that you could think of that expands your idea of just a gouge with a backhoe as your typical mechanical damage. Let's expand our minds here and kind of think about the whole universe of what we want to preclude to our pipelines. Some of the things that we'll be looking at in this workshop, and I'm asking perhaps each team leader to look at where we want to go in this study as well, and see if you can help us out in some of these focus issues on this definition, of course, of mechanical damage, the incident history and the subcategories, and some of the causes of those subcategories, and then prevention. Of course, there's a one-call system, and I'm sure that'll come up today. It always does. And there'll probably be some ideas as to how to make it more effective. But we all know one-call systems, and perhaps some of you might have thought it's plateaued. Perhaps there's reason for improvement. But we'd really like to talk about some additional ideas for prevention. Where do risk models play a part in prevention? Are there technological means for prevention and to prevent third-party damage, for example? And where are the technology gaps for prevention? Now, again, this is not for detection. That'll come on. It's just for prevention. Kind of a new issue, because I think that once you think about prevention of mechanical damage, you talk about one call, and everybody says, well, let's move on. We'd really like you to stop in prevention and kind of think a little bit more about some more things we can do there. In detection, what most comes to mind is ILI, and indeed I'm sure that will be talked about quite a bit, and we'll be talking about tool effectiveness and selection. But here we're not trying to talk about old issues. We know mostly what ILI can do. We're trying to talk about where the gaps in detection, perhaps what are the effectiveness of the tools in finding metal loss indents. Some of the technology that has been talked about, let's talk about it here and give us some ideas of where we want to go for detection as well. Characterization, probably being more of a technological person, this is one of my favorite areas, and there has been a lot of recent information about limit state design and its use in mechanical damage and operational issues. I think that's going to come up in characterization, but generally we're talking about what's the criteria for acceptance, which David talked about, needs to be relooked at. What are the gaps? Clearly, if there's a lot of mechanical damage being characterized, but it's not causing any failures, perhaps we should look at some technology gaps there, and some integrity assessment methods. Lastly, and this is not a big issue in this workshop, but if you have some ideas, please bring it up. What are mitigation issues to mechanical damage? Are there effective methods, and perhaps there's some technology gaps there? Basically, we're looking for your input as a prudent operator as to what you do and to ideas as to what you might do to effectively increase your detection, your characterization, and your ability to prevent mechanical damage in the future. So what are the gaps in technology? Interested? What are the priority issues? What are the short and long-term courses of action? Our studies are mimic this workshop. We take each one of these issues and give a chapter to it, usually get a industry panel sometimes out of these workshops to help us with our study and move through this study to give you a draft, and with, as I said before, about 30 days to look at this. Again, we need your help. We're here to listen. Please stop us anytime during these 2 days. Tell us of your interest or your experience. We're here to learn. We have really just an open mind on all of these issues, and we're here to talk. And hopefully this will be an exciting 2 days for all of us. Again, this is our team, and you've seen Christine, myself, and Paul, and we'll be around these 2 days. Love to hear from you. Thank you.
Thank you, Keith. This morning's session, up until we take a break, is really just sort of setting the stage for a series of panels that are going to come and start right after the break this morning. Panels have been organized by Bob Smith, who's here with me right now, making sure that I don't screw up loading the next presentation, and the steering committee that he's worked with. But I would also, I was remiss in suggesting that people who are watching us on the webcast, if you missed it somewhere along the registration process, you have the opportunity to submit questions as well. And I believe that Blaine Keener is sitting in the back of the room dutifully monitoring his email. So he didn't mind me broadcasting his email address out to the entire world, and I did ask him about that. So for those of you who might be watching on the webcast, it's Blaine, B-L-A-I-N-E .Keener, K-E-E-N-E-R, @dot.gov. Feel free to shoot a question in. You might say MD Workshop in the subject line so he can pick it up quickly. So that said, I'm going to continue now, and there'll be a series of presentations now leading up to the break that are just, again, trying to help us set the stage here. I was given part of the task of talking about how big the problem was, and unfortunately, due to the nature of our office, I was only able to focus on it in the past couple of days. Then I quickly saw who was following me on the panel, and I saw John Kiefner was following me, and I was going to do a statistical review. I thought it was probably bad form for me to do a statistical review in advance of John. Out of respect and deference to John, I pretty much purged that part of my presentation. So I know that John is covering that. I welcome him and glad that he came here. But I do have some other comments that I hope you'll find at least interesting. And they resonate to some of the messages we heard earlier today. And we were talking last night over dinner. So as I rearranged my presentation last night after dinner, thinking about what I really wanted to say, it comes from my perspective, and I'm involved heavily in our integrity management program, as well as our research and development program and our damage prevention program, partnerships with groups like the Common Ground Alliance, the National Association of State Fire Marshals, and others. We've worked a lot with the industry in this area. Clearly, we've all made great progress, but it's amazing to me as you listen to people talk, and I think you'll hear this again throughout the day, it seems to me that our focus is blurred, and it's hard for us to make progress together while our focus is blurred. I know that many of you were involved in our stress corrosion cracking study, and I said the same thing to you there. We work in a different environment than many of you. We work in a regulatory environment. And for us to judge the adequacy of what's going on, I think it's important for us to have a common level of understanding. PHMSA's pipeline safety program has sort of taken it upon itself as a blurring between our integrity management program and our research and development program to see what we could do to advance the cause of having a common level of understanding. Really important to progress. If we're all coming at this problem from lots of different angles, we don't even define it the same way, it's going to be very hard for us to make progress. So the Baker study is, first and foremost, an attempt for us to try to develop a consensus and have a common level of understanding. What you'll see a lot in the handouts that Bob has put together with the team and put out there for you is that, you know, this is not meant to be absolutely precise. It's meant to be indicative. We wanted to indicate levels of comfort. You know, how far along on a continuum do you feel we are with the accuracy, you know, of some of the tools that we're running? Try to work out the semantics and definitions. I will say the interesting thing that you'll note in debates, including mine as I put it up here, is that depending on which setting you're in, whether it's a congressional setting and someone wants to make a point, or another one, we talk about frequency a lot, and sometimes to the exclusion of consequence. Many of our programs, including our integrity management program, is very much focused on reducing the consequence. We focus on areas where failure could have the highest consequence. And I know those of you who have been involved in integrity management know that's true. So I think it's important as we move forward, and certainly within the context of this study, for us to be talking to you about both. That said, I would also move on to tell you that I've been heavily involved, and as has Blaine and our community assistance and technical services folks and others, in looking at accident reporting. Roger Little in our office is really the focal point for that activity, and I know that if he were here, he would echo a lot of the comments I'm going to make to you. But it's amazing to me that at this point in time, we still find ourselves with 20-25% of our reports coming in as no data, other, you know, uncategorized at all. We know there are lots of reasons for that. Some of it is our fault, and that's where we need feedback from you. If we're not providing adequate guidance on how to report, we need to hear from you. That said, I think people just honestly misinterpret. We moved, you know, greatly expanded the number of cause categories beginning in 2002. And yet I talk with a lot of operators, and I hear them tell me just point blank they have legal concerns with the way they file their reports. That said, you know, what do we need in order to move forward? You know, in order to focus, in order to make sure that the limited monies that we spend together to try to address a problem is on target, we need to have better reporting. That said, I would also say, and Ted has been very instrumental in this point, is that we've done a lot of data gathering, but we haven't sat down and really clarified the picture through shared analyses. So I'm hoping the Baker study will move us down that path as well. We need to be agreeing on where the problem is and why, and I think the extent that we can share the analyses and all of us own it, the better. From, you know, lessons from the field, I would say, and from integrity management, having been involved for over 5 years now on that subject, I can tell you that frequently we see in the field technology being misapplied or incorrectly interpreted. You know, and it's difficult as I speak to operators. Many of you think only about your individual experiences in your companies and how you're dutifully doing your job, but we see a wide spectrum of operators out there. You know, there's a normal distribution everywhere you go in life. There's curve varies, but there are a lot of operators who either struggle with this or don't do a very rigorous job. You know, the key to doing integrity management is, I don't mean to lecture because most of you know this, is to do proper risk identification. If you're not doing proper risk identification, everything else is going to fall apart from that point forward. So, you know, again, it's just as simple as we've gone into the field to ask people, you know, what are you doing to make your assessments? And they'll tell you the tool that you're running. And you say, why are you running that tool? And they don't have a good basis. You know, running a tool is not what it's about. It's about identifying the risk. If you're misapplying tools, it's not going to help you. So it's going to spend money, and it's not going to really solve the problem. I would say also technology limitations aren't properly factored in. I know Bruce Hansen is here somewhere, and many of you feel free to corner Bruce. Bruce will thank me for that later. Bruce can certainly talk to you about this. We see people constantly not factoring in tool tolerances. I would also say that one thing we've seen, just due to resources, in some cases because an operator is not ready to engage, that the time cycle here for once you identify something, getting reports back to from your vendors, taking prompt remedial action can be drawn out. And clearly we know we need to have qualified personnel and procedures if you're going to generate reliable results. That said, my hat's off to the industry for the whole round. You know, the Inline Inspection Association and the industry have been very involved in moving forward standards to improve the quality of all that. Lastly, and I know Keith touched on this subject, you know, the risk models that people use for some of their risk modeling can be misapplied. And I would say one of the primary goals, if some of you who were involved in IMP for years know, we had 4 primary goals, and one of them was to drive, you know, the use of a more systematic approach to managing the safety of your operations. And a key to that is integrative risk assessment. If you're not taking all the data that you have on your pipeline and using it to sharpen your focus, then you're not probably doing as good a job as you can. All that happens at a time, if I can just really quickly trip through this list, when we really need to sharpen our focus. Ted mentioned the TRB study. For those of you who are unfamiliar with it, PHMSA, its predecessor, started a contract with the National Academy of Sciences to study the problems of encroachment along pipeline rights-of-way. You know, we're lucky enough that Ted has come to us, but he served on that panel, and I think he can speak to you clearly about what they found in there. But I think we all sense that. Urban renewal and upgrades are accelerating. All you got to do is go into any major city now, and this is clearly an issue for the distribution people as well as the transmission people. We see in Washington, D.C., of course, you know, it's a city is a mess to begin with, but the streets are torn up constantly. They're painted constantly. The underground is growing increasingly crowded. We look around the country. We'll be issuing a joint study with a lot of the trades in the not-too-distant future, probably within about a month or so, that talks about this. Demand and supply patterns are shifting in this country. The need to try to connect those two centers together, which is the role of pipelines, is changing. Regional capacity is being strained. There are some studies going on, but not nearly enough to look at problems caused by regional constraints. I know on the natural gas side, they're a little ahead of the curve on the transmission end. Disruptions can create major ripples economically and politically. I don't need to remind anyone what was going on the eastern seaboard after the hurricanes. You know, and again, hurricane season is what, like 3 more months away? I know Ted and others are agonizing over hearing that, because we had a lot of people spending, believe it or not, you know, given that it's not our primary function, they had a lot of people spending around the clock in the Crisis Management Center trying to help people through that. Whether it's natural or man-made, the impacts in one region can clearly impact others. At the same time, funding made available for research and development, technology assessment such as we're doing, standards development, which many of you participate in, is constrained and shrinking. So that said, I said I wasn't going to say much about data, but I will at least show you a little bit here before I defer to John. I only chose this 2002 to 2005 because, again, we started doing a little bit better breakdown on causal data. I'm not really going to go into this much other than to say that the data is now available, I think, for us to begin doing some mining and developing the shared analyses that I mentioned earlier. We clearly know, as Dave mentioned, You know, when things go wrong immediately in excavation damage, it's very spectacular, and oftentimes people are hurt or killed. You know, that said, when things go wrong in a delayed event, and there are a number of delayed events that I know that all sit in our minds prominently, it's caused huge ripples. So whether it's from a financial angle or a personal safety angle, we know this is a problem, and I'll defer to John on that. Just some quick totals for you. Again, when you look at percent of all incidents, you know, it doesn't look like it jumps out and smacks you in the face. That's just on a very short trend, mind you. But when you look at consequences, it's significant and very significant. It's something that really merits our attention. I put this slide up here only because it was provided to me, but it highlights for me how we're still debating what do we mean by mechanical damage. People legitimately will say, well, internal corrosion is mechanical damage, but I'm thinking it doesn't meet many of our criteria when we're talking about mechanical damage. That said, we really shouldn't be debating it. We need to sharpen what we mean by it. But it also tells you just in relation to excavation damage what's there. And here's the summaries. Again, as you'll see, except for in the injuries, and that was probably one particular event, really, while it's a higher percentage in the frequency basis, on a consequence basis, most of the corrosion events are lower than excavation damage. So I'll close mine out really quickly with saying, you know, how do we find solutions? Hopefully this workshop gets us moving down that path. We need to communicate about what we know and, importantly, what we don't know. The folks from our research and development program, Bob Smith and Jim Merritt, are both here. They'll be heavily engaged in this project as well. Ted is leading an effort in our office on what we call a data-driven organization. You'll be hearing more about that as we go forward. But we really know that our resources are constrained just as yours are, and we really need to sharpen our focus. I won't go into that in much more, but I will tell you that we can use the inputs from this workshop also in our research and development program. One point which I haven't made here is to say that part of our desire would be to accelerate technology and knowledge gained from the research and development world and move that into the standards and regulation world. That really kind of moves the ball down the court. That said, many of you may not be aware, we recently developed a new memorandum of agreement with the Standards Development Organizations Coordinating Council, if I get the SDOCC correct, sorry about all that. But the goal there was to try to draw the standards organizations closer into the research and development world so that they're aware of the projects from the very beginning. They're tracking that as it goes along. We all know there's a long lead time on development of standards. Lastly is, you know, I think the same smart guys that were talking to Dave often told me one time, a long time ago, whenever you talk about a problem, you got to talk about three things. You have to talk about your technology for sure, and that's one of the things we're here to talk about. We will talk a little bit, and I'll come back later to talk about a process issue, but we also have to talk about the people. So keeping focused on those three things, I'm sure we'll make good progress. Okay, thank you very much. As promised, John, is it preloaded, Bob? Okay. John will be coming up. Let's see if I can get mine over here. Okay, thank you, John.
Thank you, Jeff. Good morning, everyone. I am going to talk a little bit about data on mechanical damage accidents that happen in the United States, and you'll hear other presentations regarding damage in Canada and Europe, but my focus is entirely on accidents on the U.S. system. What I'm going to talk about mainly came from a study that we did for the Gas Research Institute several years ago. But more than that, we have gathered data in the industry on behalf of AGA originally, the American Gas Association. Later on, the American Petroleum Institute sponsored an effort to get data along these lines. And the ASME B31.4 committee every year mines the data from the liquid incidents and publishes it and that's been going on for many years. So we have a long trend line. Now, as far as what I'm going to say, some of this was put together by some of my associates, in particular Carolyn Kolovich, who is one of the persons who works with the B31-4 committee to mine the data. First, how does mechanical damage affect the pipeline? Well, I think you all know that, but basically there are two kinds of incidents, and we distinguish between these two kinds of incidents for a reason, you'll see. One of them, of course, is when the pipeline is hit, and it fails immediately. It's punctured or ripped, and there's no question you have a failure or immediate release, and so you have to do something about it. Here's an immediate failure, for example. The pipeline was punctured. But there's another type of damage, and that is one where the pipeline is hit, but nothing occurs right away. And several things can result, well, really 4 different things can happen here. First of all, the damage may be discovered when it's done and repaired with no release, and that's good if that happens. Sometimes the damage is discovered, is not discovered rather, but it's not severe enough to fail, so it never causes a problem. And I think a lot of damage exists out there like that, that's in the ground, in pipelines, which will probably never cause a failure because it isn't severe enough. There's another kind of damage, of course, which is not discovered and is discovered later before it has a chance to fail. And the worst thing, of course, is damage that is not discovered but fails at a later time because of some factor in the operations or some deteriorating factor in the environment. Here's a picture of a delayed failure. This one occurred because the pipeline was scraped several months before the accident, but it was acted upon by pressure cycles and failed a few months later. This is an example of a severely damaged pipeline in which a conventional inline inspection revealed the damage because it was pretty hard for the tool not to pass through that and not see it. Now, how significant is mechanical damage to pipeline safety? Well, as you've heard from others, the appropriate yardstick, of course, is to look at the incident rate based on reportable incidents for mechanical damage. And in the U.S., there are liquid accidents and gas accidents have separate reporting criteria, and I think that goes a long way towards seeing some of the differences in the numbers you'll see here. But in gas, of course, release of gas and one of the following: death or injury necessitating inpatient hospitalization, property damage of $50,000 or more, or otherwise judged by the operator to be significant. Now, those are the requirements for reporting a natural gas pipeline incident. In a liquid pipeline incident, the requirements are a release of hazardous liquid resulting in any of the following: explosion or fire not intentionally set by the operator, release of 5 gallons or more. Now, the 5 gallons is fairly recent. That has come about in the last few years. Originally, it was 5 barrels. But by raising the level to 5 gallons, and by the way, the industry themselves began to collect that data with the pipeline performance tracking system, the liquid pipeline industry. And so we're now getting more incidents reported because of the smaller spill requirement. Death of any person, personal injury necessitating hospitalization, and property damage of $50,000 or more. Now, the breakdown that I have used here result from data collected for a 19-year period, 1985 through 2003. Some of the requirements changed over that period of time, so we're mixing reporting requirements, I should say. So we're mixing apples and oranges a little bit here, but the database comes from reports on 300,000 miles of gas transmission pipelines and 160,000 miles of liquid petroleum pipelines. And you'll see in the first column the total number of incidents, 1,583 during this period on gas, 3,366 on the liquids, and The difference, of course, doesn't mean that the liquid have a worse record. It's simply that the reporting requirement differences make a lot more incidents reportable in liquid. Now, as we move over to the number of immediate failures, those incidents which cause an immediate release, we find that out of gas, 440 were immediate releases. That's 28% of the total number of incidents resulted in immediate releases. For the liquid part of the industry, 724, or about 21%, a similar percentage of incidents resulted in immediate releases. So these are incidents that would result in release, and something has to be done. The pipeline has to be repaired immediately. Now, the delayed failures, and you really have to drill down into the data to separate these two things, and sometimes it's impossible to make a distinction between an immediate or delayed failure. So there are probably some overlap or inaccuracies in these data, but there are a far smaller number that are reportable incidents resulting from delayed failures. 49, for example, in gas, only about 4% of the total were delayed failures in this period of time. And you'll notice that there's a 9-to-1 ratio of immediate to delayed failures. And in the liquid industry, 153 delayed failure incidents, about 5% of the total, a similar percentage of the total incidents, but a little lower ratio of immediate to delay. And one of the things that it's my personal opinion, and we have some experience, I think, that would support this, is that there are more ways, pressure cycles, for example, or more severe on liquid, that will cause them a delayed, a mechanical damage that is not at a state of failure when it occurs to grow more significantly than it would in a gas pipe, for example. So I think that accounts a little bit for the higher ratio of gas pipeline immediate failures to delayed failures than the liquids. Now, if you're talking about immediate failures, inline inspection doesn't help. The preventative measures are limited to the things that we're all familiar with. One call programs, permanent marking and right-of-way maintenance, public education, surveillance and patrolling of the right-of-way, physical barriers in some cases, which would include heavier wall pipe. And in the future, we probably will see various forms of real-time monitoring of pipelines to prevent people from approaching one. As far as delayed failures, the preventative methods include all of the preventative measurements for immediate failures. Those work to prevent delayed failures as well. But you can bring in, of course, integrity assessment into the picture when it comes to delayed failures. And it's not a panacea because damage is a random event. It's not something that occurs at specific times. It can occur any time, and it may or may not degrade with time. So it's a little difficult to figure out a time constant if you're going to use integrity assessment. Every pipeline has a unique exposure to damage, and that it depends on its age, its geometry, its location, and its operational parameters. So there's no common thread there to say this is how and when you do integrity assessment. The operator should consider each situation and emphasize preventative alternatives that are most appropriate to that situation. Now, as far as inline inspection and delayed failures, with the GRI study, which was, there's a report associated with it, GRI 99/0050, as you'll see. In order to get a better picture on what you could do about delayed failures, we took as many incidents as we could get details on and drilled down farther to establish would it have done any good to do an inline inspection? Would an incident have been prevented? And the incident data, of course, are hampered by the fact that there is, at least for a long time, there's been no real standard on how people respond to the forms, and there's a narrative section. And if people take the time to do a detailed narrative of the incident, you can sometimes get enough information to do the kind of analysis we did here. And it turns out that out of 183 delayed failures that we had at the time period you see there, this didn't go through 2003, it was done quite a while back. Out of 183 delayed failure incidents, we were able to identify 68 of those where there was enough information to drill down and find out things like the age of the damage in some cases, whether the damage failed because it corroded, or whether stress corrosion cracking developed in the damage. So we had 68 cases to look at out of the database. And out of those, we tried to classify them into 5 types, and it's kind of arbitrary in some cases. And we found that there were a few which we would call short delayed periods, where the damage was created, but in fact it failed within a few days, or even a few hours. And those, we only learned that because people told us that in the narratives. Then we looked at another type, which we call type 2, which clearly occurred after there had been an increase in pressure. In other words, the damage was created at some point in time at a lower pressure rate, and the damage failed when the pressure went back to more or less a normal MOP level. And that was well enough documented in 5 cases. We could see that that was a factor. And then we came up with a couple of other types which are pretty indistinct here, type 2 and type 4, type 3 and type 4. And the only difference between these, I guess, is that in the type 3 incidents, there was enough information to tell that some other factor had caused the damage to fail, either corrosion, pressure cycle fatigue, or stress corrosion cracking at an existing damaged location. Then there were other old damage incidents where we call type 4, where the narrative didn't really tell us how it failed. But they were able to distinguish when it occurred. And many of these were because the operator knew that the damage was done during construction. And we looked at then rock dents as a separate category where you could identify rock dents. And those have a peculiar characteristic. They typically result in leaks because the failure mechanism is a shear stress failure through the pipe wall, and you usually get a transverse or angled crack, not one along the longitudinal axis, so it tends to be a leak. Now, the type 4 incidents, which were where we could characterize an age to the incident, we tried to plot those in terms cumulatively with increasing time before failure. So you see some that failed very early in the game, within a year or so. And it turns out that we have 29 incidents to look at here. And it turns out that about 12 of them failed in the first 5 years. And for reasons that we couldn't really document. It could have been because corrosion occurred. It could have been because a pressure increase occurred. So we really don't know the reason. And if you go out to 10 years, it turns out that about 17 of these had failed within the first 10 years. And then the rest of them, of course, failed. It looks like more or less a linear relationship, going out from 10 years out to nearly 50 years in age before the damage failed. And in many cases, the age was documented in terms of when the pipeline was constructed, because it was pretty clearly construction-related damage that caused the failure. And something that I guess you can infer from this is that if you're going to have to do pigging on a fixed interval, and the pigs are capable of finding damage, a fair amount of these would have been found by the 5 or 7 year reinspection intervals that are used in high consequence areas. Some of them not. 12 or so of these would not have been found within a 5-year inspection unless you just happen to get lucky. So the difficulty here is some damage will be found by inline inspection because it's there and the tools can see it. But it's a little hard to figure out when you would set a schedule for doing inline inspection for mechanical damage. I think we're going to find that if inline inspection is the tool of choice here, it's going to be because you have to do it for other reasons, and incidentally to that, you find the damage. So I think that was kind of the conclusion we came to in the GRI study, which is now getting near 10 years old, so things may change, but still, at that time we felt that the inline inspection, of course, was of no value in preventing an event that's going to occur within a few days. That's the type 1 incident. If you are going to raise the operating pressure on a pipeline and you have reason to believe that there may be damage, it might make sense to do an inspection before you make a significant increase in your operating pressure. Or it may not. It may depend on the circumstances of your pipeline. The type 3 failures where clearly something like corrosion or SCC was going on, it seems that as pipeline operators use inline inspection, these kinds of things can be found and weeded out. The type 4 incidents where they seem to be time dependent, but nobody really knows why because the data were not given to us in the reports, it's a little hard to say what kind of schedule of inspection would be good for those kind of incidents. Rock dents, I don't think justify inspection just for rock dents alone. There are a lot of them out there. Most of them will never cause a problem. In fact, I should point out that in the database we looked at, some 2,000 incidents, there were only 13 rock dent failures, or at least those that people attributed to rock dents. There may have been more, but that's all that we could identify, and they almost invariably are leaks. So I think the thing that I wanted to convey mostly was that there are two types of incidents: the immediate failures, which dominate in terms of numbers, and the delayed failures, which are fewer, but that doesn't mean there isn't a lot of damage out there. We can probably suspect that there's a lot of damage out there that will never fail, and some of it you will find by inline inspection. And I think that probably summarizes everything I wanted to say. Thank you.
Thank you very much, John. And I know while the analysis, covered primarily the transmission side, I guess I'd be remiss if I didn't point out here. Let's see if I can. Here's Chris's. Chris, I'll put yours on in 2 seconds. I'm going to just a couple of quick comments, if I can, just to set it up. We also know if we look at consequence in particular, John's presentation was covering the transmission sector for the most part, but I know he's looking at the distribution side. The statistics on the distribution side, with all due respect to our friends from that sector, the consequences are substantially higher there for logical reasons. It's important for me to follow those two things for logical reasons. We know there's a lot more mileage there. All the distribution network is sitting in urban, congested areas. So it's logical there, but it's why we welcome the distribution side to sit at the table with us and work on this problem. I think there's a lot to be gained in that. So our thanks to them for being in with us study. And just as an introduction and welcoming Chris here to talk with us, I would say that the National Energy Board of Canada and PHMSA recently signed a memorandum of understanding, and I believe it was signed in January, although to be honest with you, the dates escape me. But it really just formalizes something that we've been doing for the past few years. We've had really good working relationships with the NEB. We've been actually beginning to cooperate on transboundary inspections, particularly in the integrity management area. I think you'll see a really growing relationship between the NEB and ourselves. I know the NEB is coming down in May for kind of an annual coordination meeting with Ted and Stacy and others in our organization. So we have been, for a while we were very much focused on getting our own act together, but I know that there's a lot to learn by engaging people from other countries who have different experiences for very logical reasons. So we welcome our international colleagues here today and look forward to listening to them. Thanks, Chris. Click on that if you want, or just hit the space bar.
Great, thanks a lot, Jeff. Coincidentally, we're also I believe we're doing a joint integrity audit with PHMSA later on this year. Just before I get started, I wanted to introduce myself and understand this is primarily an American audience, tell you who the National Energy Board is and what I'm doing here, and talk about how big the problem is in Canada, or how big the problem of mechanical damage is that we perceive in Canada. I also have a couple of case studies on a couple of mechanical damage failures that I'd like to talk about just at the end of my presentation. There, I can get it to work. The National Energy Board's role is to promote safety, environmental protection, and economic efficiency in the regulation of pipelines, energy development, and trade. We regulate about 27,000 miles of transmission pipelines that cross interprovincial international borders, so about a order of magnitude smaller than the pipelines that are regulated in the States. We regulate the design, construction, and operation of these pipelines, the ones that cross international or interprovincial borders, so much like the FERC and the Office of Pipeline Safety, or PHMSA, combined. It's just a little slide showing the oil pipelines that we regulate. About 10,000 miles, primarily Enbridge, Terrace, now Kinder Morgan, and Trans Mountain pipelines are among the largest pipelines that we regulate. With respect to the gas side, about 17,000 miles that we regulate. TransCanada, Alliance, and Duke Energy are among the larger pipeline companies that we regulate. The interesting point here is that most of these lines also run into the United States and are operated on both sides of the border by the same company. So how big is the problem of mechanical damage in Canada? I can't really say this categorically for all Canadian pipelines since I don't have all of the data, but with respect to federally regulated pipelines and pipelines in the province of Alberta, which is where most of the pipelines are, it's really not considered to be an issue, and I know most people find that to be a little bit of a surprise. Between 1991 and 2004, mechanical damage, or shown on this slide as external interference, was responsible for only about 3% of the ruptures on NEB-regulated pipelines. Excuse me. It's actually our lowest rupture category. Conversely, cracking and corrosion have accounted for almost 2/3 of the pipeline ruptures over the past 15 years. This slide compares our Whoa! Now I need to figure out how to go up. There. I shouldn't put my paper down there. This chart compares our rupture rates to other jurisdictions. You can see that we're really leading the pack when it comes to corrosion. National Energy Board is the blue bar. But mechanical damage barely shows up. Just want to put my water for. Conversely, in the province of Alberta, the Energy and Utilities Board reports that mechanical damage is their largest cause of ruptures, and they're the yellow bar, and corrosion is their largest cause of incidents or leaks. The Alberta Energy and Utilities Board doesn't actually consider mechanical damage to be a significant issue, though, because ruptures are primarily caused by producers doing tie-ins and they're hitting their own lines. And we've heard Jeff speak about that just a few moments ago. So the awareness is really there, but the pipeline companies have become complacent about properly locating their own lines. They think that they know where their lines are. The Alberta regulator just deals with these from an enforcement perspective for the non-compliant companies. In Europe, which is the red bar, mechanical damage is actually the leading cause of pipeline ruptures, and it's the second leading cause, according to our data, in the United States. So why isn't mechanical damage a problem in Canada? Well, the main reason is likely one of geography. Most of Canada is actually pretty much empty. About 98% of It's the Great White North, as we like to say. Apologies, I'm just starting to get a cold today. About 98% of federally regulated pipelines are in Class 1 areas, versus about 90% in the United States. So we have a reduced probability of contact, just primarily through environmental factors. The other reason is that we've had regulations in place for close to 20 years now that specify how the public should work near federally regulated pipelines. And this is specifically with respect to doing excavations or crossing pipelines. So we have reduced probability of contact due to prevention strategies. In 1988, the National Energy Board pipeline crossing regulations were implemented as a result of a big spectacular accident a drainage tile plow accident that ruptured the Trans-Canada main line and killed one person. Excuse me. Before that time, ruptures as a direct cause of mechanical damage were a fairly common occurrence. And you can see from this slide that they were happening pretty much on an annual or more than annual basis. Since then, there's only been one rupture as a direct result of third-party damage, and that was about 15 years ago. The ruptures highlighted in blue were delayed ruptures caused by third-party contact at an undetermined previous time. So the same concept that John was just speaking about with respect to immediate ruptures and delayed ruptures. Now, I'd like to talk about the 3 delayed ruptures in just a few minutes, but first I'd briefly like to talk about our crossing regulations. The crossing regulations that we have in Canada on federally regulated pipelines have 2 parts. The first part specifies the requirements for third parties or the public that wants to work in or near pipelines. It is that the regulations establish the permission that the crosser or the third party has to get from the pipeline company, sets out some guidelines that they have to follow with respect to providing notice ahead of time, not being able to do any ground disturbance within 3 meters of the pipeline unless the pipe has actually been physically located, and importantly, notifying the pipeline company if there has been a contact with the pipe. The second part of our regulations specify the obligations of the pipeline company. Pipeline companies are required to have public awareness programs, sets out the guidelines for how these crossing approvals are done, some requirements for pipeline locating and doing inspections of work on your pipeline. An important thing to note about these regulations is that the control is not just on the pipeline right-of-way, but it also covers what we call the safety zone, which is 30 meters on each side of the pipeline right-of-way. Violations to the crossing regulations are reportable to the National Energy Board, and they're generally reported by the pipeline company when they've discovered that there's been a violation that's happened. Violations are investigated by our staff to see if appropriate corrective actions were taken out. Now, we recognize that crossing violations are showing an increasing trend, primarily, as John and Jeff both mentioned again, due to increasing encroachment, urban development on the older pipelines. Most of the pipeline infrastructure in Canada is greater than 35 years old. Also, companies are becoming more vigilant with respect to patrolling their lines, particularly in the high-risk areas, the urban areas. Now, we think that reported crossing violations are actually a good leading indicator for mechanical damage. Of the violations that are reported each year, only about 4% of them actually resulted in contact with the pipe. So that indicates to us that pipeline companies are doing a good job of patrolling their lines and catching these violations before mechanical damage actually occurs. I just have a little slide here about some normalized statistics regarding pipeline contacts and mechanical damage. An important thing to note is that most of the crossing violations that are reported to us are of the ground disturbance type, so people actually doing excavation on the right-of-way. Again, you can see from the numbers here that cascading or leading indicator effect. If we get about 25 violations per year per 10,000 miles, and about 4% of them actually come in contact with, or there actually is a contact with the pipeline, then you can see from the numbers that the ratio between mechanical damage ruptures and contacts is about 15%. So there is sort of a cascading effect. I'm going to cough all the way through this presentation. The interesting thing about these numbers is not so much that the provincial statistics are an order of magnitude higher than the federal ones, and there's just a lot more activity on the provincial ones because that's where all the producing is, but that the causes are quite different. With respect to causes of contact on federally regulated pipelines, it's primarily the landowners and contractors, so public awareness is the key issue there. With respect to the contact on the provincial or Alberta lines, like I mentioned, it's the producers doing tie-ins, so it's complacency that's the issue. So there's really 2 very different causes that require different approaches with respect to mitigating the risk, public awareness versus enforcement. So where are we going in the future with respect to reducing mechanical damage? This is my chance to put in a fast plug for our new damage prevention regulations that will replace the crossing regulations this summer. The new damage prevention regulations are going to be more goal-oriented, so companies will have more flexibility in how they manage their crossing approvals and the damage prevention programs that they have. Companies will be required to have damage prevention programs. and the National Energy Board will audit these programs for effectiveness. Other things that we're doing up in Canada is, again, providing very strong support for the development of provincial and national one-call systems. And in the damage prevention regs, it's going to be mandatory for companies to belong to a one-call system if one actually exists in that province. And they do exist in most provinces now. And we're going to continue to have our public awareness focus. So even though it's not, mechanical damage is not a big problem for us, we're not ignoring it. And we recognize that with increasing urban development, it may become a larger issue in the future. Now, I did want to talk about a couple of very brief case studies on some mechanical damage failures that we've had in the past. This one is actually the more interesting of the two that I'm going to talk about. In 2002, there was a rupture on a liquids line. This rupture was actually investigated by the Transportation Safety Board, which is pretty much the same as the National Transportation Safety Board in the U.S., so there is a public report on this rupture. Now, the rupture occurred in 2002. There was actually an inline tool run, an MFL tool run in the line in 1998, and the anomaly, or this defect, was detected during that tool run. Unfortunately, the defect was misdiagnosed as a field bend, and that diagnosis wasn't confirmed using any other data. For example, comparing it to the route alignment, doing a field excavation, or doing some engineering calculations. Doing an engineering calculation would have shown that this anomaly was actually quite a bit longer than what would have been allowable for a field bend. The Transportation Safety report suggested that the people doing the data analysis may not have had adequate training or experience to be able to do this type of analysis, and it's worth noting that the analysis was done in-house by pipeline company personnel. With respect to linking this to the proper risk identification that Jeff was talking about, there was a history of unauthorized excavations on this specific piece of property, ditch cleaning and drainage tile installations in recent years, in the past, I should say. The other example that I wanted to talk about was a gas pipeline that had two ruptures on the same line, in the same location. The line was constructed in 1952, and then there were dents that were repaired in 1998. Now, during the repair of those dents, there were some backhoe gouges that were introduced into the line. Visual inspection caught most of the gouges, but not all of them. There was a rupture in 1989, so a year after, from mechanical damage. And then there was a second rupture in 1993, same location, essentially the same location, again from mechanical damage. In between the first rupture and the second rupture, there was actually an inline tool run, an MFL tool run, but the results of that tool run didn't arrive until after the second rupture happened, so it was a little bit of bad timing. So just to close my presentation, I want to summarize what we in Canada have learned about mechanical damage so far. We know that it's not really a major problem in Canada. Corrosion and cracking are our biggest integrity issues. And we're pretty sure that one of the reasons why it's not a problem for us is because we've had an effective damage prevention program in place for close to 20 years that increased awareness. And you can show, in the rupture slides that this has resulted in a reduction of ruptures due to mechanical damage. Now, we also recognize that this may change due to increasing urban encroachment on our pipelines. Our future directions are the introduction of better damage prevention regulations, which will be more goal-oriented, and companies will actually be required to have damage prevention programs. Thanks a lot for your time.
Thank you very much, Chris, and also thanks for making my point on an integrated risk assessment with your example from that liquid line. Clearly, we would look to operators for what other indicators do you have that would correspond in your assessments in that geophysical location. A lot of operators in the U.S., I know, track confirmed digs along their line. So as they start doing that kind of integrated risk assessment, it should help drive that. Continuing on, now assuming again, Bob, that I beautifully find and locate. Learning, from experiences in, let's see if I can find that, Muris. And Muris, I hope you'll forgive me if I mispronounce it, correct me. It's Zorea? Yeah, Zorea, to talk to us about a European experience with mechanical damage. Thank you.
Thank you, Jeff. So I'll try to give a European perspective to the same question, how big is the problem? And I'll take some risks when I speak about the EGIC database, because it is going to be a little bit more detailed than the previous presentations. So I'll touch out of the numerous groups that are active in that area in Europe, only the two most prominent who publish most contributions, which are EGIC and EPIG. So EGIC about incident databases, then some words about EPIG R&D contributions to handling this threat, and finishing with a case study which occurred recently in Belgium. So what are the ways, the metrics that incident database can give us to evaluate such a threat? You all know that, and Jeff, among others, mentioned it, that you need to have in mind both consequences and failure frequencies. But as you know, that consequence scale with the amount of released hydrocarbons, you get quite some information on that. But there's a real difficulty to evaluate the failure frequency or occurrence of rare events. So we need a sufficiently large pipeline exposure, and therefore we need to pull data to come up with some reliable figures. And also you need to have some consistent basis that operator practice and environment should be quite similar, so that the conclusions would apply to the whole range. So we saw about the USDOT database, and I'll speak about EGIC and give you one slide about CONCAR, about oil pipelines in Europe. So EGIC means European Gas Pipeline Incident Group. It started in '82 with 6 gas transmission operators. Now it boasts 12 major gas transmission operators in Europe. And what these operators feed to the database is unintentional gas release. So that picture with the hole shot in the pipeline wouldn't appear reporting in EGIC database. And the pipelines are onshore steel, design pressure above 15 bar, and all the failures are reported which occurred outside the fences of installations. And of course, as usual, relevant pipeline data is indicated, and concerning incident data, you get 3 categories of leak size, and that's a significant link to consequences. Either the pinhole crack, which is less than about 80.8 inch, the hole which is between these 2 centimeters and the pipeline diameter, and the rupture where the equivalent diameter is higher than the pipeline diameter. And between the causes, we distinguish 6 of them, and of course one is external interference, and we check whether ignition occurred or not. Some data is gathered about consequences, and also about how the incident was detected. And also for external interference, we checked what activity caused the incident, what type of equipment was involved, and if any protective measurements were there. So now about exposure. This database lies between the other 2 that you heard about, with 122,000 kilometers, which is roughly 76,000 miles, and an exposure length, because we produce the failure frequency as the ratio of number of incidents to system exposure. So the system exposure is almost 3 million kilometer years, which is about less than 2 million miles years. And of course, you need to distinguish between the overall failure frequencies and those calculated with a moving average over the last 5 years, in order to capture more precisely recent changes. And of course, 4 times in the history we got new members, so there were step changes in the system length. So you'll see now a series of this type of graphs. They all look the same, you get on the abscissa, you get the years and the relevant parameter on the ordinate. So the network I'm speaking about is mainly composed of about half of the pipelines are in the less than 16-inch, and today roughly half of them are larger than 18-inch. But of course, this has evolved from a past where larger than 18-inch at the beginning was only 1/3. And therefore, if in this population of pipelines, you will get quite a lot of thin-walled pipelines, and the most commonly used is this clear color, which is the class of 5 to 10 millimeters, so 0.2 to 0.4 inches, and they all increase linearly, with exception of the thinnest pipelines, which just stopped growing starting in 2001. And in the end, you find that this is how the annual incident reports look, and as was mentioned previously, this is highly variable, and you need to find out trends, and therefore we use the averaging. So you see in the table on the bottom, then on the whole period of 34 years, we had a number of incidents of 1,123, and which yields a primary failure frequency of about 4 10,000ths per kilometer years, or 0.4 to the 1,000 kilometer years, which is about 0.1 per 1,000 miles a year. And if we care about the 5-year, the figures for the 5 last year for 100 incidents, we get 0.17 failures per 1,000 kilometer years, and that's less than the half of the overall figure, and for the year 2004 it's a similar figure. So that is clearly illustrated here. There is a decreasing trend, which is quite encouraging, both and you can also see that with the time passing, also the scatter band, or confidence interval, 95% confidence interval, is narrowing, and this gives you an idea of this confidence interval or scatter band is 0.02 and 0.03 for the moving average. Now, when we get to the place of external interference in this picture, as mentioned earlier by Chris, this is 50% on the overall failure frequency in Europe, and you have then 2 other causes as corrosion and construction defects and material failure, which range between 15 and 17%, and ground movement, hot up by error and other and unknown, are around and below 7%. So definitely in Europe, although all the causes, the failure frequency decreased, the prominent place of external interference remained, and you can see it here that there are 3 periods more or less. A first decrease until 77, then stabilization, and then a new decrease after 92. Now, if you take the 5-year moving averages, you find that there were once again a sharp decrease, then a stabilization for a decade, and another decade of decrease, and again stabilization, but this stabilization occurs at a level which is 1/3 of the previous plateau. So that means that there were significant efforts done, and that results were found at the end. So Now, something which links us to the to consequences is how you can relate the leak size to the different causes. Of course, the largest leaks, which are the holes and the ruptures, are mainly due to external interference, as you can see here. And external interference is by far the cause of the highest number of ruptures, and second cause is ground movement. And the activities which cause these incidents is mainly 40% excavators digging, and then drainage works, public works, and agricultural activities account each for about 8%. And now if you relate the same type of leaks to the different pipeline parameters, and that means that population has its important population characteristics. As you see that, of course, the smallest pipeline are the most vulnerable ones because they are thinner wall and they can be easily hooked. And now if you have a look at the depth of cover, of course you can gain about 20% in going deeper than 1 meter. And of course thickness plays an important role because you see that the smallest thickness, less than 5 millimeters, is the most prone to, the most vulnerable, whereas the class of thickness which is most used, between 5 and 10 millimeters, that is less vulnerable. Therefore, thicker pipe is of course a good protection against external interference. And concerning incident detection, as you know, public is always there, so they're the best detectors with almost 40% of the cases, but patrols who do their job reach almost about half of that detection rate, so that means they're very efficient, knowing that they're only on purpose, and also contractors are good at reporting what they should report. Well, in the end, concerning consequences, an important point is ignition probabilities, because, of course, not all the leaks unhappily turn into a fire, which produces the highest consequences, and only on average 4% of the release is ignited. And you can see here that once again the size of the leak plays a very strong role on the ignition probability, because it's only large rupture that would get high ignition probabilities. So much about gas pipelines. Now one slide about oil pipelines. ONCAW issues a similar report which is based on 22,000 miles of onshore oil pipeline, and their reports is about 0.53 spills per 1,000 kilometer year overall, and less than about half of it just in the year 2003. And you can see from the graph that the mechanical damage has a big part in this picture. And well, unlike the gas, its part is increasing. Now, a few words about EPRG and what they do for helping harness the threat. The European Pipeline Research Group is an organization which since 35 years combines 10 European gas transmission operators and 10 European pipeline manufacturers. And of course it performs R&D in the area of steel transmission pipelines in order to improve their safety and quality. It has 3 committees: materials, corrosion, and design. I'm a current chairman of the last one. And it organizes, together with PRCI and APIA from Australia, a joint technical meeting every 2 years in order to foster information exchange and help progress in the area. And the policy of EPRG is to publish the results of their work. Typically, you get recommendations for fracture arrest, well defects, mechanical damage, and so on. Now, on the specific topic of mechanical damage, there was a publication which summarized the efforts which were done for more than a decade, and it was published in 1999. And all the underlying models are based on mechanics or semi-empirical models, and they're all validated by experimental results, and their application range is explicitly indicated. And it is consists in two parts. One which is assess the remaining burst and fatigue strength of part wall mechanical damage defects in terms of gouges, dents, and dent and gouge combinations. And so this is mainly for operational use, but in terms of design use, you need to know what your pipeline is exposed to, so you need also to assess its resistance to mechanical damage. So therefore, in this part, the puncture resistance and dent resistance was quantified, as well the aggression capacities of excavator, and ourselves and also other colleague operators in Europe use this result and these criteria in everyday operation practice. So since that time, work went on in the mechanical damage area. So, for instance, we worked on hooking of pipelines, also on behavior of gouges in low toughness pipes, in a complementary effort to the PRCI work on corrosion defects on low toughness pipes. And currently we're planning to update the burst strength model for dent and gouge combination. This is very relevant to our discussion, in order to incorporate recent improved knowledge of this very complex problem. That's why it sort of lagged behind, one of the gaps that we were asked to identify, and therefore discrete the scatter of the current model. Of course, there's an opportunity to coordinate with similar PRCI efforts on the subject, and just to show that there's good opportunity to work together, as EPIG contractors work also for PRCI, like Advantica, GSM, and Cluster France R&D division, as well as PRCI contractors who work also for EPIG. I would just quote CIFER, for instance. And also 5 operator companies are members of both associations, so they can help forward collaboration. So now I'll finish with the case study, which is a quite serious accident on a high-pressure gas transmission pipeline that occurred on 30th of July 2004 in Villangien in Belgium. And I'll give you a view, quite graphic views of what appeared mainly from published document in the internet. So that happened, started with a leak, and this leak constituted the gas plume that you see. It could be seen from 10 kilometers away due to the condensation in the atmosphere, either from the north or the south. Then eventually the leak became a rupture and generated a very huge flame that you could see from all around the site. And now it's dying out. You'll get a better view now of what the local conditions. So this is an area of recent development where during the year 2004 this diamond board had this factory erected, and the road with the parking lot, and 2 pipelines were running here. And here occurred, the accident occurred at this place. So here you have a view of the crater, with the line that ruptured, the 40-inch line, and a parallel line, a 36-inch line that was not damaged during the process. So here you see the diamond board factory that in the immediate vicinity was destroyed and then burned further away. And you can see here that the depth of cover was quite low. And here you have an overall view of the area, looking from the south side with the two factories that were affected and the parking lot. And a nearby passing highway. So this is GS packaging and diamond board that were most damaged. So several views that will give you an idea of the area where vegetation was burned and the pipeline where the pipeline was located. This is GS packaging that totally collapsed. Here you can see on the east side of the diamond board how vegetation was burnt. Also some fatalities on the far east side. Also the entrance. Here an aerial view where you can see quite clearly, these are overpressure effects, and these are mainly thermal effects. We'll come back to that later. A construction crane that failed. GS packaging, also GS packaging seen from the west. This is a deformation of a structure about 150 meters south to the east of the crater. So burnt down vehicles. Localization is not clear. This car had molten plastics and blister paint at 524 feet towards the northeast. Molten plastics at around 1,300 feet towards the west. The same molten plastic at about the same distance, and burnt vegetation all around. So how all this came about? It's as you saw, there was some road construction work, and for that the ground had to be flattened. So the initial depth of coverage, which was 1 meter, was decreased to about a half of it. And some defects were left in the pipeline, and the operator, Fluxys, was not that. Fluxys had done the normal procedure, had informed the contractors of the pipeline and the risks, but the subcontractor who did the stabilizing work apparently was not aware of the risk. So this was a 40-inch pipeline, 12.7 millimeter thick, half an inch, and this piece, about 11 meters, was found away from the pipeline, and you'll see the defects now. On defect number 2 and number 3 lie on the two opposed open sides of the line, and then defect number 1, you can see it here, and you'll see the close-ups. So this is definitely not an excavator tooth which does this. And when you look at defect number 2, it looks even less like excavator tooth damage. At this level, the thickness went down to 4 millimeters, and well, the models that we set up in EPRG could predict the failure with this data. Here you have the other part of the same damage. So what this damage is something that all operators do not have are not used to think of, which is a soil stabilizing equipment, which spins the soil and and mixes it with some chemicals that are provided. And this can range as deep as 40 to 50 millimeters, and you can see all these hard teeth that create that effects that you could see. And there are lots of them on a very wide cylinder that is carried by this machine. So now you get a better idea of what caused the damage. Now to see the impact in terms of consequences. This was the first stage, and the presence, actually the delayed rupture was one of the causes of the numerous victims. Here are the injured persons that were attended immediately at the site. And when you look back and try to see what you can learn from that is effects of overpressure. 3 persons were projected at 200 meters away to the east of the crater. On the buildings, I mentioned that damaged concrete structure of diamond board factory, and several objects were projected at several hundred meters, and the pipe segment shown was found 150 meters away. And 2 types of overpressure phenomena were in play here. One was the overpressure due to pipeline rupture, just the pneumatic effect, which yielded several bars within meters close to the rupture, but quickly attenuates with distance. And also the overpressure due to gas ignition, but this is quite small. With our risk assessment package, we evaluated about 33 millibar maximum, half a pound per square inch, so this is really not big consequences. So the first phenomenon dominated. Now, thermal radiation effects were those the worst, because 22 people present at the site within about 200 meter died, and out of those 22, 3 were projected, as already mentioned, and 6 passed away later due to their injuries. And about 130 people were victims of severe burns. And the effects on structures, as you could see, 2 factories burned, and the metallic structure deformed on a nearby building, and several cars burned also within about 500 feet, and the vehicle plastics experienced meltdown in 400 meters, and the vegetation was burned within 250 meters. So just a few other slides to show that, well, this was regularly indicated. It was provided with a closed valve station. Well, then the pipeline was, the nearby pipeline was inspected, and here is a view of the diamond board factory, the works of which produced this problem. So now, the last slide to conclude. So what you could see is that the metrics provided by existing database on high-pressure pipelines, although they're perfectible, are already of great practical value to assess the different dimensions of such a complex problem. And it was said before that it's not easy to grasp all the aspects, definitely. And, well, the good news are that high-pressure pipelines are globally safe, and their failure frequency has steadily decreased in the 70s, but of course further progress can be achieved. And while mechanical damage is in Europe the most important single cause of leaks in high-pressure pipelines, it has also consistently and significantly decreased, more than the others, in the last 3 decades. And this fact shows a continuous and effective commitment from gas operators to deal with this subject. And we definitely need a thorough understanding of the wide and complex nature of this subject to go on improving even further the current status, and that's a mix of structured field feedback with both statistics and case studies, R&D, which means new technology, but also improved communication towards the environment, and all these are complementary to means to achieve the goal. Thank you for your attention.
So
So welcome back to Mechanical Damage Technology Workshop. Just to avoid confusion, I am not Dr. Alush. I'm Christina Sames from the American Gas Association. And this is a lesson learned. Don't go to dinner with PHMSA. They'll talk you into doing things, such as moderating the session.
It's our job.
As the title indicates, the session is focused on mechanical damage prevention technologies, what currently exists out there for pipeline operators and others to use to prevent mechanical damage from actually occurring. We heard a lot of good discussion this morning of mechanical damage being the leading cause for many people in the United States, at least in New York, and maybe not in Canada. So what's out there that we can help prevent it? Now, we're not here to discuss some of the other activities that are going on, such as the communications and educational components, the Common Ground Alliance, the Transportation Research Board Project, the 811, the initiatives of the National Association of State Fire Marshals. This is really focused on the technology component. And with that, we have a great variety of speakers that will help walk us through the technologies that are out there. But before we begin with those, if you look in your package, you should have a matrix. That matrix was created by the people that pulled together this workshop, plus some other outside interested parties. It helps to identify what's currently out there and our confidence level in those technologies. I understand that we are still taking comments on that matrix, so please take a look at it. If you disagree or see things that are missing, please contact either Bob Smith or Jim Merritt or Jeff Weiss to provide those comments. With that, let's get started. Our first presenter is Gwyneth Broussard of Shell Pipeline. And with that, I'll turn it over to Gwyneth.
Good morning. I hate to disagree with my great friend, Christina Sames, but I will. My talk today is going to really encompass all different types of methodologies as well as technologies in preventing damage to our pipeline systems. I am, as well as I think some of my colleagues, are going to cross the line over and talk about other things that we as pipeline operators do in order to prevent human error. Because when you come down to it, if you talk about the definition of mechanical damage being damage created by an operator of a piece of machinery, and I'll leave it like that, we will then find that mechanical damage can be prevented by other things than technology. So let's start. How do pipeline operators prevent mechanical damage? Well, before you start trying to figure out how to stop it, you have to first figure out what are you going to try to stop. So who do you have to stop? Well, we all know the answer to this. We've got homeowners, excavators, contractors who work for us, contractors who work for private entities, contractors who work for the government entities. And then we've got agriculture. The farming community is a tremendous soil disturber in the United States. And then we have ourselves, as we heard earlier today, other underground operators, whether it's telephone, electric, cable, or ourselves as pipeline operators, do damage. So now that you know sort of who the universe is, the next question you have to ask yourself in trying to figure out how do you prevent damage is, well, how is it occurring? Well, we heard earlier sometimes there's failure to contact the pipeline operator to learn of the location of the pipe itself. We all have probably historical evidence of where someone failed to use a one call, or did use a one call, said they'd call you back, and then didn't call you back to meet you on site in order to learn more about the site. Or you saw them on the site, they were a quarter mile away, they said they weren't going to get anywhere near your location, but if they were, they'd call you back within the next couple of days. And again, they never called you back. And then, of course, the other type of damage that's occurring is when the excavator changes the scope, the type, the location, or even the methodology of the excavation being conducted. And so we have to understand much more fully about those things as to what is their scope, what type of operation are they conducting, where is it going to be, and are they using the same equipment? Are they changing equipment? And we all know that in construction, depending on what's happening on the ground and what you've got planned, may change at any moment. The other leading cause that we have found is that excavation occurs without having anybody present, even though you've requested to be present. I can remember way back when, in my early days at Shell, one of the major incidents that we had in the Austin, Texas area was at 6 o'clock in the afternoon. The contractor excavator had left for the day, said he wasn't going to come back until tomorrow morning at 8 o'clock. And sure enough, he decided to swing back and do one more pass so he didn't have to get up quite so early the next morning. And that one pass at 8 o'clock that night ended up being the one that hit the system and caused a major leak in the Austin area. And then, of course, failing to pass on vital information to machinery operator. I think what we heard from the last presentation is that a subcontractor didn't understand the location, didn't understand the hazard, didn't understand the consequences of hitting a 40-inch natural gas pipeline system. And we find also that that is another leading cause of why damage is occurring, is that you may be meeting with a foreman, you may be meeting with a director of operations, but when you come down to it, it's the guy on the backhoe, the guy who is actually performing the operation that we have to try to prevent from damaging our systems. And now what we're talking about is information transfer exchange. So we come back to our question, how do we do this? What can we do? Well, one of the thoughts right now, and I think every one of us is actually accomplishing, is using existing methodologies and technologies and trying to get creative with them and trying to integrate them with all the various other types of programs that we have and the arsenal that we use to prevent damage to the system. So here are some of the things that I'm going to briefly talk with you about. Anyone who knows me knows that given 15 minutes, I can talk for hours. So I'm going to just touch the surface of a lot of these. Some of them I will not go into depth. But a few things I do just want to make you start thinking about and seeing how you apply your technologies and your methodologies. I'm going to talk a little bit about public education and awareness campaign. However, my colleague is going to talk a little bit further about how public awareness and education really can impact preventing damage. A little bit about mapping, surveillance, one-call systems, which we all know is a vital part of our arsenal, locating and marking, and also excavation monitoring. We've had education, public education, for a long time. It's nothing new. We've done it in a variety of different ways. We have targeted mail-outs, we have public service announcements, advertising, and all the different media. In addition to that, we also have what we call, and I call them group meetings or conferences. All of us have representatives, or we hire third parties to represent us, to meet with a variety of different excavators, general public, local officials, and emergency responders. In addition to public education, the one thing that we as operators have done ever since we've been operating pipelines is basically having pre-design and pre-construction meetings. And we establish that early on, whether it's our own construction that's going on or major construction that's impacting our systems themselves. It's a part and parcel of every engineering group, every construction group in our companies. It's a vital part of it because that is where we find early on in the process whether or not a particular project may have potential to impact our facilities. And then every operator also develops strategic relationships. We know those who are leading causes to damage, and we start trying to develop working relationships with those people in order to try to emphasize to them the location of our pipe, the consequences of impacting our pipe, and then to work towards a partnership and trying to establish some methodology, some process where we both win, where we both prevent damage both to them as well as to our pipe. I think the industry, which began the recommended practice 1162, which deals with public education and awareness, has taken really, in my view, a giant leap towards better educating and making the 4 stakeholder groups much more aware of what we do and why what we do is so vital to the United States, and what they can do to prevent any sort of damage to the systems. We will, in this year coming up, now that we have a regulation which basically mandates implementation of 1162, we'll be having both baseline and supplemental programs. This involves more stakeholders than ever before. We will have more messages directed specifically at those stakeholders. Those messages will vary with regard to the type of message, the frequency of the message, and then we're going to evaluate whether or not we're going to be effective. And then the last loop is that we will continuously improve. Again, public education and public awareness is a methodology which helps prevent damage. If we can educate those about our pipeline systems, educate them about how to prevent damage to those systems, and then educate them as to what to do should they strike them, we will be a long way. The next tool or methodology that we utilize is mapping. One of the great things I think occurred early on in the last few years is the fact that the Office of Pipeline Safety has put together the National Pipeline Mapping System. It is a great tool which hopefully will be up and operational for everyone to see in the near future. But it also has brought home to us as operators all the variety of different things that we need to be aware of, high consequence areas being obviously the most important to our integrity management program. But it also highlights for us the fact that the public as well as others need to understand, need to have a tool to understand where our pipeline facilities are located. And let's face it, we are in the internet age. I was talking with someone yesterday. If I want to know anything about a topic, the very first thing I do is, hate to use Google something. But we do rely on the internet to provide information. And so with that, of course, we have geographic information systems, which we are using much more robustly than we ever have before, in providing links to other data systems so that we can, at a touch of a button, understand much more fully not only the information about our systems as it relates to other underground facilities and other structures, but also about giving us an understanding of risk and associated with our IMP program together with our public awareness program. Another new thing that's been coming out, although I have to say it is going to be interesting to see, is whether global positioning systems, where you actually have pieces of construction equipment where you can tell at a touch of a button where they are at every moment of time, can actually take off in the United States. If that does, that may help us tremendously in trying to reduce the number of accidents by heavy equipment. I know there's been a lot of work in this area, and you know, it would be great if we can continue to do so. But again, we're talking about thousands of constructors, as well as those hundreds of pieces, or I guess millions of pieces of equipment that are used by the average person every day. I'm not going to get into satellite and digital orthographic imagery or in too much detail, just to suffice it to say that it's an added layer to our geographic information systems, which can assist us in assessing and understanding what is the potential Video mapping systems have been tried out, at least in my view, for some of the liquid systems. It is a methodology that can be used, I think, pretty much in my view, more appropriately with aerial patrol. I have seen some mounted systems on trucks and overland vehicles. There is a time sensitivity to those systems, so again, you have to have human intervention with them. But it is a system for us to utilize. Now, the one that, of course, we utilize besides our geographic information systems is the ever-present alignment sheets and other sheets of mapping information that over the years we have utilized traditionally in our companies. Taken all together, one of the things that you have to look for is how do we integrate this into our public awareness program. And as we go through each of these topics, I'd like you to think about that. So here we have a public awareness program that's kicking off. How do you integrate that with mapping? Or how do you integrate that with surveillance methodologies? And we have several surveillance methodologies that we utilize. The ones that I think that we're most familiar with as liquid operators is satellite, aerial, and ground patrol. And I'm going to talk a little bit in detail about that in a second. Acoustic is being used as, it's categorized as a surveillance methodology, and again, this is my personal view. I think of acoustic more so as a detection methodology, although it can be used if you catch it early enough as a possible surveillance technology. I think for liquids it's probably not as advanced, and hopefully it will be in the future, as it is for the natural gas industry. Fiber optics, of course, is another methodology and technology which is coming online, which I believe has promise. Again, I think part of the issue is basically cost at this point for existing systems. But again, I think it holds a lot of promise for us. And then, of course, impress alternating cycle currents. Let's talk a little bit about really the ones that we as operators use most frequently in preventing damage, and that is either satellite, aerial patrol, or ground patrol. A lot of companies have looked into and invested in satellite visual surveillance. These are usually commercial satellites. Usually, and when you utilize this technology, you're usually looking at high-risk areas which have been pre-identified. It does require continuous monitoring, so you have to have a human continuously monitoring, looking at those locations. There are some automated systems which are being tested and run right now. There's some success, some not. But again, I think it's a technology which has a lot of promise, especially as we continue to grow. I think one of the things that a lot of people learn through the hurricane experience, and I know that my 80-year-old father learned, is that he can go on the internet, tap in some information, and get a satellite image of his house in order to determine whether or not Hurricane Rita had actually had damage on it. A lot of folks now are utilizing satellite imagery for a variety of different things, and we as operators can continue to look at, can we utilize this technology together with our mapping and our public awareness again to see if we can identify specific criteria to really look at locations which pose substantial risk. And there are places that we all know have a higher frequency and prevalence of risk than others. Real-time monitoring is, of course, somewhat limited by the satellite visual surveillance, and also currently it is affected by weather conditions, although they are looking into some multispectral operations which may eliminate that so that you can do it at night and you can do it in cloud cover. I think the one that most liquid operators are probably most familiar with is aerial patrol. This is usually conducted by either fixed wing and or helicopter. And it was interesting, I was reading a paper just recently that stated that helicopter aerial patrol is actually much more a deterrent simply because it can land almost immediately, and simply by circling the area it causes an operator to think that it's under investigation. So I guess it's sort of like the police, you know, that circles you if you're a bank robber, you know, coming and getting you. But basically, it was an interesting analysis that helicopter patrol was a much more effective deterrent than fixed wing. But in fixed wing and aerial patrol, we do have the ability now to do GIS mapping overlay, which is directly tapped into the aerial company's route. We have laser imagery with video, as I mentioned earlier. Satellite phones so that we can immediately contact either control centers or investigators in order to quickly have a response should we see someone encroaching on the pipe. And then one other thing is the Blue Sky network, which a lot of people are familiar with which basically allows you to have a positioning of a particular, for instance, an encroachment. It's relayed directly over satellite to your control center. You can tap in the location and basically GPS coordinates. It tells exactly what is occurring. It's either, you know, you can send it off by email. And in addition to that, it also allows communication between the pilot as well as the control center and or whoever is monitoring the operation. Holds a lot of promise. A lot of aerial patrol companies are now utilizing it. It's helped us tremendously, I think, in preventing someone suspicious of excavating who has not done a one-call. Another visual surveillance methodology that we utilize, again, is surface video survey. Again, this is somewhat limited because obviously it's intense as far as human resources concerned, although you can get quite a lot of coverage as far as the area that you're looking at. And then, of course, walk-by. Another patrol methodology, again, for maybe highly sensitive areas where you're concerned about the potential of damage. So now we've got public awareness, we've got mapping, we have visual surveillance, and then we get to the one-call systems, which again is a critical part of how we prevent damage. We've notified everybody about where our pipes are located, and now what we have to do is we have to provide them with the methodology to call whenever they decide to excavate. One-call systems are improving every year. You know, I can remember when I first started in the pipeline business, grids were really the only thing that you could get out of a one-call system, and some of the grids were pretty big. And so we were looking at a lot of calls every day. We are now getting that refined to specific polygon areas, and you can designate the locations and width of what you need. We're also seeing a lot more electronic applications in one-call systems, and the advent of positive response has been a vast improvement in making sure that there is two-way communication between the potential excavator and the operator of underground facilities. In addition to that, we're seeing a lot of one-call systems use automated communication with updates that they will provide both to the excavator as well as to the operator. These come by both voice, email, and fax. But bottom line, the one-call center really is information transfer, which is the key to prevention. Communication and information transfer. When you have that going, you're going to prevent damage, hopefully. But again, you have to get to the operator of the machinery. And so again, one of the challenges I think that we will be facing is to make sure that we can do that. After we've got, of course, the one call, then it becomes incumbent upon the operator to locate his facility. And I'm not going to get into a whole lot of detail about all the different ways that you can locate. We're all familiar with them. But again, it's something that we need to integrate directly into how we are preventing damage and assume whether or not these systems are really relevant for the type of damage that might be caused on our system. As far as marking is concerned, I think we all know that marking is critical as we have operators. We've got permanent marking as well as temporary marking. I think for permanent marking, there's a variety of things that we can do, everything from tri-view marking to line of sight marking. where you can actually see within a certain yardage between signs. Of course, all of this has trade-offs associated with it because we all have to deal with landowners who don't necessarily like our markers. Warning mesh is another advent of how we can prevent damage together with some of our maintenance. As far as temporary markings are concerned, there's a whole wealth of things that we are using today in order to prevent damage. Everything from pre-marking for various geographic and environmental conditions to warning fence, and of course associated barriers. I've seen actually concrete barriers erected. And then of course photographs. I think the API recommended practice 1166 will basically push us over into excavation monitoring to again do much better in what we do as far as preventing damage. We not only now have to continue with evaluating and determining what needs to be monitored and observed, but when we do monitor, we will have to be within 25 feet of the outside wall of the pipe, and we have to conduct site visits on predetermined frequencies. And then in observation, of course, we have to be there if it's less than 5 feet or has the potential to impact in less than 5 feet. And again, report out for daily observation of what we see. I cannot close my presentation without doing a plug, and my plug is we need enforcement. I really do think that you have to use both tools. You have to show someone the advantages, and then you also have to say, but if you don't take advantage, there's going to be enforcement. So again, I think all of us in this room know that we have to improve on state one-call laws, both in criminal as well as civil. We have to improve as far as the federal law. We have a criminal law in the books right now, but we certainly hope to have a civil law as well that will also add another factor in trying to prevent damage. And of course, we as pipeline operators can always litigate. But again, that's something that sometimes we're very hesitant to do for a variety of different reasons. But the one thing on enforcement that I think we all have to be cognizant of is that we have to give all the tools and laws in order to enforce, but if no one steps up to the plate to actually do it, it doesn't matter what laws are on the books. We actually have to take the step to enforce. Thank you very much.
Thank you, Gwinnett. Good presentation on showing how the public education, awareness, and enforcement links with the technology. And it's hard to believe we'd ever disagree on anything. With that, our next presenter is Jerry Rao from Panhandle Energy. Jerry?
Good morning. First of all, I want to say happy Mardi Gras, and to Dave Katz in particular. Throw me something, mister. I can't believe he came in here with 3 beads. He didn't bring enough for everybody. Anyway, Dave will be out in the hallway afterwards passing out beads and doubloons. Here's the obligatory slide on the pipeline system. I'm surprised I'm the only one that has this on the operator side, but I have to throw it up there just because I have to. I think what Gwinnett talked about is a good introduction and a good segue into what I'm going to talk about. I'm going to talk specifically about public awareness and how to manage the processes that are involved in public awareness, and some of the new technologies and new things that we could be doing on the public awareness side. We've been at it a long time, and I think I'm finally going to retire this slide after this presentation. Probably 90% of the people in this room have seen this at one time or another from various presentations I've given, but for the people that haven't, no, that's not me. But we have been at it a long time. But recently, because of the things we talked about all morning, the issues about damage prevention, public awareness are becoming more critical. We got to make sure that we can talk to all the stakeholders, because if we do, and we can do a good job about it, we're going to prevent the damage from occurring in the first place, and that's what our primary goals needs to be. So we're going to talk about basically 4 things today. We're going to talk about managing public awareness programs, basically the same way as you would your integrity management program. And we'll talk some detail about how we do this at Panhandle Energy. We'll talk a little bit about the role of technology in that regard. We'll talk about how we've communicated with public officials and emergency responders. how we manage encroachments, that Gwinnett talked about. And we're also talking about some new things that we're thinking about as far as communicating with the affected public. As you all are aware, from the new regulations in the API 1162, there's 4 groups of stakeholders that we need to be in communication with. And each one should have a different message or maybe a different technology or a different process to deal with. So we'll talk in context with these stakeholders, at least from a high level. We also understand that we will be, as operators, audited on our processes, and we need to have a very precise, consistent, and continuous process for dealing with the way we are going to manage our public awareness and damage prevention programs. So we'll talk a little bit about how we're going to manage that here in just a second. As in any process that we will do, in any activity, we need to make sure that we are consistently applying our processes, we have well-developed processes, and can document the activities that are required or that we do in a routine fashion as the processes are utilized by our people. We intend to use a software program called Integrity Compliance Activity Manager that does precisely that. I'm going to show just a couple of quick slides to show how it's worked. But basically, not only is our integrity management program going to be documented in this program that allows us to define the process, the areas, the process, and the specific tasks that are applied as we gather the information and as we need to document the activities that are required. It is customizable, so we will put not generic processes in here, but we will actually put the processes that we will be using in managing both integrity management and public awareness into this program. Next, I want to talk a little bit about communication with public officials and emergency responders. I'm going to talk about a process that we went through not too long ago to do precisely that. The integrity rule requires us, in fact, to engage those 2 particular stakeholders. So we're going to talk about what we thought when we did this, what we did, what we saw, what we learned, and how this is going to move forward into what we're going to do next. Going in, we presumed that we'd make the effort. The rule says we're going to have to talk to these folks. By God, we're going to talk to them. And really the results were inconsequential. We didn't really believe that doing this process was really going to gather any good or useful information. So we spread a large net with minimal expectations that we'd get any results at all. We looked at mail-outs, ads, flyers, all those kinds of things, and realized that was a big effort with the expectation that we thought the results were going to be inconsequential. So cost was a big driver in that effort. Well, we determined, at least from the front end, that maybe a website might be the way to go. People are, as Gwinnett talked about, people are used to using the internet. We figured here's an opportunity to utilize that new technology to maybe get the message out on what we were trying to accomplish. We figured that the response to that website may be better than just throwing out a large number of flyers and hoping people would read them and maybe respond to them. We sent 6,500 letters out to basically an unscrubbed list, but along our pipeline right-of-ways. And we tried to scrub it a little bit to say we think the people that we're contacting from a large degree are public officials and emergency responders. So here's the next couple of slides will show the website. So we sent a letter out that gave the users a username and a password that they could get on the internet, go to the URL, log into this site. They were already given a letter that described in detail how this website would be utilized, what kind of information we were looking for, specifically any knowledge they may have on identified sites. They could give us some information as shown on this slide so that we could be able to better determine what their roles are as either a public official or emergency responder and how they relate to activities along the pipeline. It gave them details on how to use the site, and as I'll be showing here in a few slides, the details of what they would do, how to navigate around the site. It also included in the website, this is the copy of the letter that we sent to them that described what it is we were trying to accomplish. In essence, we were trying to contact emergency officials, emergency responders and public officials to determine if they knew of any locations that might meet the definitions of identified sites, to help us in that regard. Once they logged into the website, they were able to pick where they were in the world by state and by county, and with a few simple clicks of the mouse be able to drag an icon into the location that said, we think there may be people that meet the identified site criteria or a building that might meet the identified site criteria. We found out, in reality, that they liked the website a lot. We got, of the 6,500 mailouts, we've got over 500 responses. Still getting some more. This went out just before the holidays, last Christmas. We also gave them an 800 number, and they used that a lot. They called my number incessantly, it seemed like, for a long time. And we got mostly positive feedback, which was also very encouraging. We really didn't know what kind of feedback we might get, but it was very positive. There were no hysterical calls. There were no threats or bashing. It was, we want to be engaged in the process. So what do we learn about all this? That the emergency responders, in fact, do care and want to be heavily involved. As we know, we do engage those types of people every day out in the field, but they also want to be involved in the integrity management process as well. I got a lot of phone calls that said, this is the best thing I've ever seen. I'm glad you guys are engaged. This is kind of information, and now we know who to talk to. We also learned that maybe this web tool may be a better way to engage other groups as well. Maybe we can use this tool and expand it to talk not to just the emergency responders, but the affected public and our excavators as well. So what are we going to do next with this technology? Well, number one, we also found out that we didn't do a very good job in-house collaborating between our integrity management group, our right-of-way department, and our media relations. We all were going a little bit different tact on how we were doing this communication. So we're most assuredly do the first step is get those three groups together and make sure that we're doing it right. And then we're going to try to develop how to engage the affected public, not just talk to them, but engage them. We've talked about web-based education programs. We've talked about referral programs. We want them to be the eyes and ears along our right-of-way. We know they're out there, and we know they're concerned about pipelines, so I think we can get them engaged. And we want to target more specific groups, and maybe that's homeowners associations, not just the general public, but organizations as a whole that are there and are looking at what's happening as things are developed. Next, I want to talk a little bit about how we manage encroachments. The specific application that Panhandle Energy is using is the Earth system. Talked about one-call programs. This is a piece of software that's commercially available, and not only that, it's also used by a lot of the one-call systems that we deal with on a daily basis along our pipelines. It allows us to focus our efforts to the excavators, provide positive response. Also does save us a little bit in time and effort because we can shrink the number of the footprint of the pipeline as compared to a large swath along the pipeline. The people in the field are tied into this on a daily basis so they can see and react to all of their one-call activities. So the benefits we see so far is that it provides a great audit trail. I think the biggest part is it gets that engagement with the excavator. It provides that positive response. We know they're there. They know we reacted to it. It does some other things as well. Now we've got a great database that we can utilize on the types of excavators, who they are, where they work, and all those kinds of things. And we talked earlier about threat assessment and risk assessment. This will be a great tool for us to utilize this information on fine-tuning that process as well. Too much data, sorry. Lastly, I want to talk a little bit about where we think about going when we communicate with the affected public. We are looking at, again, some new technology in the software side of the business. I'm sure I'm going to get this acronym wrong, but I think it's spatially oriented public awareness management, maybe? I don't know. But anyway, it is a database that will allow us to track the communications that we have with those group of people. It is GIS and map-based, so we can specifically see not only names and addresses, but where they are in relationship to the pipeline. It allows you to do all kinds of searches and things like that along the pipeline so you can look at people. The biggest advantage that we see is it'll record not only the kinds of communication, but the communications themselves that we're having with these focused groups. So if we send out mail-outs, it'll specifically say these are the people that had a mail-out. If a pipeliner's out on the right-of-way and he talks to somebody along the right-of-way about some activity that's going on either on the pipeline or he's performing, we can record that as well and look at the kind of response and kind of feedback that we get through all kinds of different communications venues. So again, this is something we're looking at, and hopefully we'll have this implemented very shortly. So again, from our perspective, the biggest part about damage prevention is the public awareness. And it's not just the kinds of technology that we can apply in public awareness activities, but again, how we manage the processes to ensure that we've got a good, consistent, and continual approach. So I appreciate it. Thank you.
Thank you, Jerry. It sounds like PNO has a great path forward on how to use technologies to better address the issue of mechanical damage. I'll be interested to hear the next steps and the results of those next steps. With that, let's turn it over to Daphne DeZerka of NISearch.
Good morning. I'm here representing the distribution sector. I work for an organization called NISearch, a voluntary R&D organization. So most of my comments, even though we're talking about existing technology, relate to sort of, instead of best practices, sort of hardware-type technologies. But since I think I'm the first person up here this morning representing distribution, the distribution sector, as someone said earlier, has a lot of challenges, and I'll go through them. But based on recent information from Underground Construction, January 06 publication, the miles of main that the distribution sector has on record is 1.5 million miles. And the amount of new miles put in each year is about 12,000 miles of main each year. And then there are 80 million services in the distribution sector that our companies manage, and there's about 11,000 new services to the customer's home each year. And as many of you know, while in historical past we focused on cast iron, ductile iron, and steel, a large part of what's put in the ground today is plastic. So when we talk about damage prevention becomes a little different story when you're going to lighter weight materials. And as I think John or someone else put up earlier, certainly third-party damage represents, in our case, about 30% of the total incidents that happen in the distribution sector, and probably a lot more for unreported incidents. In addition, we have a group in New York that collects statistics on this, and we know we have about 2,500 reported hits per year. Now, I work for NISearch. The NY implies New York. We actually represent the LDCs in New York, New England, the mid-Atlantic states, down as far south as Washington, D.C., and now Utah and California. So in terms of the challenges for damage prevention, from my perspective working for the LDCs, obviously damage prevention in the distribution sector means sensing in dense areas, also very noisy areas, which can, for sensing technologies, be quite a problem, and of course highly populated environments. The New York City street is not only populated above the ground, but highly populated underground, and there are many cities, high consequent areas that have that type of environment. I'd like to say that many of the members that I work for, their entire service territory is a high consequence area. Any approach that we address in terms of technology needs to minimize excavation frequency and size. Obviously, there's a lot of cost and customer disruption, and so whenever a technology developer is contacted or solicited by our organization, one of the key challenges is to minimize excavation. Economic feasibility is a must, and many times we have some real interesting ideas, but they're simply not economically feasible. Obviously, this is something that has to be done on a continuous basis, so if we're doing monitoring and prevention, we really need things that act on 24/7. And turning towards some of the more specifics, there are some great technologies out there that can hear or feel or sense encroachment, but can they avoid the false positive? Can they give people the confidence that they need to address in terms of that implementation of a technology. Adding on to the challenges, there's many, and I tried to pick some of the key ones that we've focused on. The technology should have no negative impact on gas operations. Speaking for the natural gas industry, there are some technologies that can do wondrous things, but if they interfere with, for example, other systems such as the cathodic protection system, then we have a problem in that sense. Communications, if we're using wireless or over-the-line communications, because we do have an encroachment, we need that to be reliable. We also need it to be secure. In this age, we really have to worry about security as well. More on that in terms of benign conditions. There are a lot of benign activities, but if they are sensed and an operator has to respond to every incident or every activity, then there is going to be no confidence in that sensing system. Also from, actually years of technology development, we know that construction equipment can generate a very wide variety of frequency signatures. And so that wide variety has to be characterized, and those signals are further complicated by varying soil conditions and mechanisms of wave propagation. So we already have sort of a good sense of the level of difficulty and the range of variability, and I guess my point is that it's listed under a challenge because there is quite a range of variability. And then if you think about transmission versus distribution, for example, our LDCs own transmission mains, but they also own distribution mains. We start out with looking sometimes at transmission because you have straight runs of pipeline. And if you're looking at something that's economically feasible, the straighter the run, the longer the footage, sometimes that makes it more economical. So I know there's probably more transmission folks in the audience than distribution, but I'd like to say that in some sense we feel that the transmission application for damage prevention is a little bit simpler than the distribution side of it. In terms of relevant technologies and practices, I'm not really trying to cover everything in the distribution sector. I want to just represent some things that we're familiar with in a sampling. Certainly maps have come a long way. Some of the LDC's maps come from decades ago, but there's a push on to go to electronic mapping, geographic information systems that are linked to the maps, and even global positioning systems. I was caught by a commercial the other day, and as a result, I guess I'm going to plagiarize. There was a woman from the Bank of America saying that online banking is now at a point where it's being taken for granted, meaning that people are now comfortable enough to use it fully with confidence. And I'd like to say that where we are with electronic mapping is it's on the verge of being taken for granted. Maybe 60 or 70% of our companies are using it. Not everyone's there, but it's getting much more widely used. Can't have a discussion today without talking about one-call procedures. This is very important for the LDCs. All of our LDCs are active with one-call, both state and federal, and that, of course, is relied on, by many. I guess I'd also like to say before going further that when I thought of mechanical damage and preparing for this presentation, I thought in terms of intrusion or actual mechanical damage other than that by natural processes. So I did not put up here anything to do with corrosion being a natural process, but of course the LDC is doing a number of things for corrosion prevention. Our folks also use standby observers for any activity in the area of pipes. And part of my talk is going to focus on pipe location technologies because our companies have spent a lot of money in that area. Certainly ground penetrating radar, particularly focused on plastic pipes, electromagnetic technologies that work well with metal pipes. We have our acoustic PE locator that does still require a connection to the pipe. There's conductive locators like the E-line conductive locator. And then more and more frequently there are folks using vacuum excavation crews to actually serve as a locating technology, and certainly they use for test holing as well. And while I know a lot of the talk today has been very general, I'd like to get down to something specific that we've developed that is near commercial, so I put it on this presentation as opposed to the one after lunch, which is going forward with technology research, and that's a system called GasNet, which I'll describe. So just getting to some commercially available GPR systems. I didn't capture everybody on the list, but we've been involved with this for many years, and I think the requirements of GPR are well known, and folks around this country as well as around the world have brought different systems to the LDCs for pipe locating. Several of them are shown here. See the little mouse arrow there. This is the MALA system. This is the Sensors and Software system. These are cart-mounted systems. There are others, US Radar, GSSI. And there's been various efforts since actually the late 80s, early 90s to really push GPR into our LDCs and to develop these systems. Ourselves, GRI, folks from all over the world have worked on developing GPR systems. This system is a WheatonTech system. Whoops, go back. A WheatonTech system that EPRI developed, and now there's a company working on that that's sort of large intersection mapping. And GPR offers a range of antennas, a range of frequencies, but the things that we see with GPR is that you really need sort of a specialized, dedicated crew to use these effectively, or our operating companies don't implement them across the board because of expense or complexity of use. So I'm going to talk later about some things that are advancing in this area, but my point is if your companies can focus on using GPR and dedicate crews, these systems do work. In our industry and maybe in other industries, there has been for a long time the hope for a quote-unquote magic bullet, and certainly locating systems like these are not the magic bullet, but they are making progress, and it's not like we're at the drawing board. We are well along the path in terms of making GPR effective and economical. In terms of limitations of some of the commercially available GPR systems, and you guys have probably been down this road before, certainly a lot of the technologies that are available use GPR, produce hyperboles, produce images that you need a skilled operator to use. And so we've spent a lot of money in the past, and with signal processing today it helps, but there's still difficulties in getting sort of simple displays that a user can interpret. And funny, you can have some really advanced technology come a long way, and then you get out there on a really bright sunny day, and all that money goes to waste because you don't even have like a transflective screen that'll give you an image that you can see in a sunny day. So even that can be a problem, and of course that's coming along. For companies that are have O&M budgets that are constrained, certainly the price to purchase some of these advanced GPR systems has been a limiting factor. Also, many people are aware that some GPR systems have been limited at soil type. I've been involved with GPR for many years, and I think there's a philosophical debate about whether there really is a fundamental physical limitation in soil. Many of the scientists that I've encountered will argue that there is not. There is data out there that shows there are limitations in clays, but it hasn't been convincingly proven that that's the case. In recent years, the FCC put bandwidth restrictions. This is your classic case where you have a very fledgling sort of industry that's working in a very small area, ground penetrating radar, that's competing with the cell phone companies and the massive companies. So because of the cell phone bandwidths and other bandwidths that are needed, it's very difficult for GPR, for example, to work in bandwidths between 1.2 and 1.6 gigahertz. Now, the GPR companies have overcome this by showing that emissions are quite low and that we can meet the FCC regulations, but these restrictions have prevented innovation in the area of GPR, and we're working on some of the ways to overcome that. Certainly user acceptance, I said this before, the magic bullet. The other thing is that many of the systems you saw on my past slide are cart-mounted systems, are large systems, so weight's a problem. I've worked with many users over the years on this, and they basically want a tool that they can toss in the truck, it can take a beating, and it's not something that needs two men to lift and carefully put into a truck. Portability is key. Turning to this GasNet system that I mentioned, back in 2000, we got our operators together for a strategic planning session. And our basic question is, what would you like this business to look like in 10 years? How are we going to manage technology in 10 years? And that was in 2000. It seems like we're not quite at the 2010 mark for where they want us to be. But they said they wanted to have a real-time sensing network that would basically tell them at any point what's going on underground, which would sort of totally change their way of thinking. So one of the things that we got going on, which actually is near done, and that's why I put it in the existing technology category, is a sensing system that can capture in real time things like pressure, flow, vibration, and moisture content. And the concept is, as I've shown in this thing here, that we'd have basically little wands that we call nodes that we put in through a plug hole, a very small excavation, and that there are slave nodes and then a master. And through wireless communication that we've developed, basically those slaves can communicate in real time to the master and to a control system in someone's desktop that says what's going on at any point in that sensor network. So we've gone through this project working on this. We can monitor flow speed from 0 to 15 foot per second, pressure from 0 to 30 inches water column for cast iron pipe, and 0 to 124 pounds for steel and plastic. We can monitor temperature up to 100 degrees, moisture content up to 15% water by volume, vibration up to 2G, and then we have externally connectable capabilities for external sensors. So this system isn't something envisioned. This system is something that's in the field right now in the third round of testing. And here's another sort of illustration of the plug type sensor. This is going to be installed. It is installed in valve boxes. Goes through, and we have a wand. And whoops, I did that again. And the wand is basically containing both sensors and a PC board. And we submit these at various points. The economics of this system is such that we're not envisioning putting this everywhere in a distribution network, but what we call in the hotspot areas. And so GasNet is installed in various areas of critical areas where we want to monitor, and we are, with a small battery pack that's installed inside that valve box, having these slaves communicate wirelessly to a master. And the master is at a point of hardwire connection or at a solar cell. And our folks are excited for this, not just for distribution. Our first phase, we worked on distribution, and we're implementing that now. That was the alpha module. We did beta prototype testing last year, and right now we have 100 units in the field for some distribution and actually some transmission pressures. Our batteries have to be replaced on 6-month intervals, but they're off-the-shelf batteries, and they're placed inside the valve box. So right now I put this on the existing technology list because we are going to commercialization. Our field people are excited about this, and it can be used in areas of need for monitoring. So what is the confidence in using technologies? As we said earlier, the electronic interfaces are gaining momentum and will soon be taken for granted. I think over the years, part of the reason why we've been going after location technologies is because maps simply aren't as up-to-date as it's impossible to have a map of everything with 100% confidence. The other thing is plastic pipe is usually located with the electromagnetic location devices with using the tracer wire. Well, over time, the tracer wire deteriorates, so that can also make a problem in terms of what your maps show and what's really down there. Commercially available GPR, it's available not only as a product that you can buy, but as a service. Certainly in Europe, the service market has taken off, and I think less so in the United States, mainly because people are looking for a product, and the product needs time and training, which limits the confidence. Also, I'm familiar with the companies that are using GPR. They usually focus it on what they call difficult locate jobs, and they succeed when they persist in terms of training and gaining confidence. The GasNet system, for example, is pre-commercial. It is generating excitement. Confidence is not just will it work, but how economical is it. And right now the economics are sort of based on the application and are not set for total confidence. In terms of application, traditional pipe location methods are used broadly. I focus on GPR in this discussion. One of the best benefits is for finding what we call a clear lane in a substructure with multiple utilities underground. Right now, the main alternative that people use is test holing, the trial and error digging, and the cost can be minimized using vacuum excavation. But if you had a reliable locator that could find a clear lane, there's quite a benefit, and that's quite an application for GPR. We know that traditional locating technologies, your M-scopes, your E-line locators, those things are used extensively for marking and locating lateral positions of pipes. Vertical positions aren't as critical because they're not necessarily required, but vertical positioning is also important, and we don't always get that with all traditional technologies. So using, I think Bob Smith put out a template of the things he wanted addressed in this presentation. I verbatim plagiarized what technology needs, if addressed, could provide significant advancement. Well, I think we still have to go after reliable, user-friendly, and affordable pipe location. I think real-time warning of threatening activities is important. We've done a lot of work on real-time sensing, some of which applies only to transmission. The problem with real-time is, are you going to really get it before the construction activity is a problem? And we're working on several systems we'll talk about later that get at that. And then one of the areas that I know others have focused on that we haven't yet, but we're starting to, is somehow finding automated warning systems that are integrated into the construction equipment themselves or the other sources of damage. And that's where I think now with the increased intensity on damage prevention, that's where I think we really need to turn, and that's going to be dealing with a lot of other people besides those in this room and those that we work with every day. So in summary, our gas industry technology developers have spent a lot of time, and they are very familiar with the challenges, and there are several, but they have identified those challenges. The existing technologies have some application, and basically the confidence wasn't immediate. Confidence is built with some of these existing technologies, including GPR, over time, and if your company invests in them, they will find that they work. Things like GasNet or other sensing systems are possible because of miniaturization, because of wireless communication, and now real-time sensing is a reality rather than a vision. And then finally, there are still several technology needs that are evident, particularly for what I focused on today here is pipe location, but in other areas of real-time sensing as well. So that's what I have for this group. Okay.
Thank you, Daphne, and thank you for also providing some of the statistics for the distribution industry. I know I recently looked through some of PHMSA's incident reports, and for like 2000 on, it ranges anywhere from 35 to 50% of the incidents are a cause of excavation damage. Even and of that, first and second party damage is just a very small percent following that other outside force, such as vehicles and fires and explosions as a primary cause, seem to be next in line, as opposed to some of the differences with liquid and transmission where corrosion may be next in line. With that, our last presenter before lunch is Jeff Weiss, who's not new to the podium, and we'll see if we can keep him to less than 30 minutes.
I'll have to think about that one, Christina. So let's see here. And since I noticed that you loaded everyone else's presentations, she ate up 5 minutes of my time just making me try to find my presentation.
Do you need help?
Probably yes, but I don't know about for this particular exercise. Okay. There we go. And by the way, to Herb Wilhite, if he's watching, I didn't notice this little moniker on the bottom. I've got to figure out what his little insignia was there. But maybe it was that Brigham McCowan, if he's watching, came out of Federal Motor Carrier Safety Administration. I'm looking for the connection. Well, thanks again, and thank you, Christina. I've been asked, actually today I wouldn't have been up here, but one of our good colleagues, Masood Tantami, many of you may know him, he's with the Virginia State Corporation Commission, is running a pilot project that he wasn't able to be here today, and I've been involved with him in this project, and he asked me if I would be glad to cover it, and I said I didn't know if I'd be glad, but I would certainly take a shot at it. Before I start this, I would, of course, be remiss if I didn't have a couple of comments about other things we've been listening to. I have been involved heavily in public education as well over the past 3 years in building that standard, and I agree with Gwinnett and Jerry that great things are going on in public ed. And that clearly, as you fit into that triumvirate I was talking about earlier about people, process, and technology, collectively the industry is doing great things, I think, in reaching out to others that you need to influence their behaviors to protect the pipeline. They're also doing a much better job about training their own people and communicating internally. So I think there's a lot going on in the communications front, as well as qualifications front to address the people side of it. I know we've talked about process and procedures, and really we'll focus a little bit in this one on the one-call process. But the rest of the day and tomorrow are really focusing heavily on the technology end. And so anyway, without further ado, I'll kind of go on. I'll make these. We decided some time ago, I think it was Bill Scott at Colonial in our Research and Development Forum last March, if I'm not mistaken. After we had done a lot of good work at the R&D Forum, Bill Scott got up in his inimitable style and basically said, well, yeah, that's all good, but what are you going to do for me? You know, and I've got a heck of a lot of over-notification going on. Now, I think it was an interesting problem, and it's not just over-notification that's really the issue, although there's a lot of money being wasted due to over-notification. I think we saw a broader application of Bill's challenge, but we took it seriously, and Bob Kipp and I were both at that forum, and we started talking. Bob, as the executive director of Common Ground Alliance, said, you know, how are we going to take a swing at that challenge? And both of us almost at the same time came up and said, you know, we've got to find a way to push the technology in the one-call process. Where would you like to do it? Virginia was a logical candidate. I would quickly hasten to add that there are a lot of other states who are doing great things in their one-call systems. For example, state of Minnesota and state of Georgia have been doing great things. Our distribution integrity teams have identified what they characterize as 9 elements of an effective damage prevention program, and most of those states are addressing all of those. Being a Virginian, I happen to have a little bit of familiarity with his system. Bob and I approached Masood and asked if the Virginia State Corporation Commission would like to join in and help us pilot this, and Masood was right there, as we knew he would be. I will say some things that I think qualified them for this is that Virginia has been working for more than 10 years to build an incredibly robust database, you know, better than most of them I've seen elsewhere, and in many ways much better than what we have at a federal level. He also has a unique stakeholder-driven process, and I mean that in every way. It's taken 10 years to get to where they are, but the stakeholders are even involved in enforcement, and as Gwinnett said, enforcement is critical, you know, component in an effective damage prevention program. I don't think anyone wants to lead with enforcement, but you have to have it, and you need to be able to use it, and there are a lot of states who actually have enforcement rules and laws on the books and don't use them. So Virginia was willing to do it, but their stakeholders were engaged in that. They were reviewing monthly enforcements that were coming up. Masood has always been a great state partner, has been involved in our programs forever, so enough plugs for Masood. But that said, just really quickly, what the pilot is about is how do we figure out a way of using technology to drive improvements in this communication loop. We all know these are sort of truisms by now, and you've heard enough of this. We've got to have the programs. It clearly is a shared responsibility that came out of the Common Ground study in '99, another stakeholder-driven exercise. But it depends heavily, and the underscore here, on accurate and timely communication about planned excavation and effective facilities. You know, we've got to have a really robust communication between excavators and operators and back. Operators need to use their locators to determine exact locations or facilities. Excavators must take care not to damage those. This is just a graphic that basically talks about that loop. What the Virginia pilot is about, in essence, is trying to find ways of improving the use of technology to accelerate and improve the accuracy of that communications loop. We really are just in the process right now of forming up a small business plan for that, and we're going to be looking to attract people to the pilot to see how it can work. But in essence, what we want to do is use GPS to sort of drive more accurate reporting. Masood has great presentations. If he was here, he could go on all day about talking about one-call tickets that come in and they just want to replace one pole, you know, one pole. And they get a call that covers something like 10,000, you know, square feet. The grid system wasn't precise enough. You know, there are a lot of disincentives for the excavators to very narrowly constrain the area that they're going to excavate in. So, you know, to be safe, they over-notify, and because the grid system is not very granular, that amplifies the over-notify. So you have operators constantly sending out locate crews on jobs that don't need to be done. So that said, sort of a view of what we can do to drive down the number of tickets that really aren't needed. You know, let's make sure we have tickets that are needed. I don't think this presentation characterizes it that way, but one of the great descriptions I heard was if eventually, we get to a tablet PC-based system where an excavator can walk to a job site or maybe even remotely using the internet and a really good mapping application, electronically white line the area of their interest and where they're going to be excavating wirelessly or even through a landline, transmit that back to the one call center who, it records all the data elements and immediately whips it out to the operator who can either say potential conflict or no conflict, and very quick feedback to the excavator that said, hey, you're clear to go. So that's a win-win for an excavator. I mean, they want to move fast. They're sitting around waiting on this stuff. Time is money. Let's find a way to make it win for them. But at the same time, it works for the operator because it's far more granular, and they can tell with, which ones do I really need to mount a locator. We think it works for the locators in many regards because they'll be able to use really their best resources on these. I mean, a lot of locators are stretched thin. There are thousands of locates that are being done that are probably not needed. So again, just another sort of graphical depiction of this whole process. We're hoping to use the GPS coordinates through the one call center back to the operator locator. Eventually, and kind of, if you think about this process now and all the places in which technology is employed and how can we advance the level of technology in that particular step, that's fundamentally what it's about. We haven't identified all of the technologies. We sort of have a vision on where it could go. So we're firming up a business plan now to figure out all the portions of this loop where we can improve technology. The locators, for example, it would be good to have that working wirelessly. When they go out, they get better data on what's there, and they transmit that back to the one call center. The excavator would like to know that information, and it's good to have it recorded there as well. Things that we hope to get out of this, we do expect fewer tickets to be issued per request because there are a lot of them that are issued now that don't need to be issued. They're nowhere near the utility owner. We hope to get fewer inaccurate locate requests because we'll be able to better allocate the locator resources there that maybe spend more time. Interesting kind of conversation about thinking about what's in this for locators. You have to have a win-win for everyone for this to work. I think that really, to be honest with you, the cost of locates could go up. But think about it, if you're really doing far fewer locates and you're only really doing the ones that work, I think the overall costs go down to the operator. And most importantly, of course, facility damages we hope would drop dramatically. Obviously, facility locate accuracy. So just really quickly, the people who are the lead for this is the Virginia State Corporation Commission. PHMSA is there in a supportive role, but we're both Blaine Keener, who's in the back, and myself have been attending all of the meetings. We intend to stay engaged. Mechanical damage, excavation, damage prevention is one of our primary goals. I'm pleased to announce that really about effective last week, Pipeline Research Council International decided to join in. They had a very similar project plan that was driven by their members, and I suspect that Bill Scott might be behind that one as well. But be that as it may, George Tenley at PRCI had already identified this as one of his priorities. So he stepped up to the plate and said he wanted to participate, both financially and in terms of staff resources. So Common Ground Alliance is there so that we can draw the knowledge from other people in the country that are going on. We have a very good one-call system in Virginia. Rick Pavarsky, for those of you who might know him, is very good, very flexible, willing. He's already making changes at his system to accommodate this pilot, and he's pretty well plugged into the one-call network. A lot of good operators, including Colonial and Plantation and Columbia and others in Virginia, pipeline operators. But interestingly, and I think a missed opportunity, or at least one we need to take greater advantage of, is our partnering with our, I don't know what you want to call them, our partners in the underground. Verizon creates more damage in Virginia than anyone else, and we need to get them at the table, and Verizon's been willing to step up. So the telecom sector really needs to get engaged in this. The electrical sector, driving in areas where I live in Reston, there are no overheads. Everything's underground. We need to have those people engaged in this. The locators have stepped up. There are several national locate groups, and the excavators have stepped up, both with state chapters as well as the national organizations to participate. So we're in the process right now, as I said, of putting together a business plan. We're going to pick 3 areas within the state of Virginia, probably Fairfax County. For those of you who are familiar with Virginia at all, Fairfax is one of the densest populated counties in Virginia. But we want to pick a couple of others that are dissimilar from Fairfax. A little coordination. We're going to try to identify equipment that would help us solve this problem and get out in the field, run and pilot it, gather the data. We'll generate a report over the next 12 to 18 months. We're trying to do this as much as we can like a business to identify the technologies. At the end of the day, say which ones worked, which ones didn't, do a cost benefit on that. We have been talking about a lot of alternatives, and I think with your help we could probably improve that pilot. I would welcome Blaine's in the back of the room, and I'm going to be around for the next couple of days. And you probably know how to get a hold of Virginia State Corporation, or we can help with that. If you have ideas on how to improve that, we'd love to hear it. But with that, that's the end of mine, and I was considerably under my time limit, Christine, I'd like to point out.
Thank you, Jeff. And if we could, just one more final round of applause for all of our panelists.
Okay, thank you very much. See, some of you people started Mardi Gras just a little early, we think. So, just a couple of quick notes, if I can, and then I'll turn it over to Christina, who, again, had the misfortune of going out to dinner with us last night when we found out that one of our panel moderators was unavoidably kept from attending today. And so we quickly conscripted her into filling in, and we want to thank her for that. And we'd like to ask her to keep her comments very brief today. So that was 3. Okay. Just a couple, sorry about that. A couple of quick comments, if I can. Apparently, on the webcast, there was a technical issue with being able to see some of the slides, and we apologize for that. I think it was Mira's slides that were the problem. We're posting, and they were great slides. So we'll have everything posted to our R&D website. I think you can go to the spot where you registered, and it will take you there. But you can also get to it from a website address, which the only one I can ever remember is ops.dot.gov, and that will allow you to get into our research and development program, and you'll see them posted there. We'll work, Bob promised me he would, as long as we paid for a high-speed connect, he'd get online tonight, try to upload those to our web people and get them posted in the next couple of days. So at least by next Monday, we should have everything posted there for the whole thing. I'd also like to just take a second to ask, is Chris Pollard here? Chris Pollard, he's not here? Oh, that's interesting. Yes, I'm sorry. Oh, there you are. It's right underneath that light, and from here you can see almost nothing on this side of the room. Chris, I wanted to thank you publicly. Chris came up to me afterwards after my usual sort of we're poor and can't afford to feed the public routine to say that he and Baker Hughes would be glad to put on coffee this afternoon. So when we do a coffee break, thank you very much. Okay, with that I'll turn it over to Christina. Yeah.
So this morning we heard sort of what's going on, why this is an issue. We heard some great discussions on the existing technologies, and now we're going into what research is out there that will help us in the future. To start off that, I'm going to turn it over to Jim Merritt of PHMSA.
Thank you, Christine. Thank you, Jeff, for the lead-in that you've given us. I want to give a short discussion on what PHMSA Research and Development Program sees are the technology gaps or the needs for prevention technologies. Let's see if I can't master this. Oh, that turned it off. There we go. First, I want to talk about what are the gaps and where are the gaps that we see PHMSA Research and Development Program. And like Jeff was talking this morning, the vision's kind of blurred because when you're talking to the operators, you get one aspect. When you're talking to the support contractors, you get another aspect. When you talk to AGA or the other federal agencies, you get a completely different view. So it's kind of blurry, and we're trying to clear up these issues with having workshops like this. and understanding, what do we need to do as far as fostering new technologies. We're basically looking for three things: fostering new technologies, requirements related to consensus standards, standards and regulations, and then the third thing is the knowledge for decision makers to help us go forward, where are the gaps and so forth. The R&D program has 8 program elements, and you'll probably hear more about this as the time goes on. The first one's damage prevention. You've got assessment. You've got design, construction materials. You've got the mapping industry, mapping program that you heard about this morning. And then you have the operators controls, human factors, risk management, and safety issues. Coordinating the various research efforts has been a major concern within the office over the past, when we're talking with what's industry doing, what's AGA doing, what's Northeast Gas Association, what PRCI is doing, what's the folks up north in Canada is doing, what's the people over in Europe doing. So we're trying to get a hands around all the various types of research and then take a look at the different gaps in those research. And again, that's what this meeting's all about, to try and identify those gaps. What's a development order? Well, we all know what accidents and disasters bring. It's thou shalt do it. The regulators come down and say, you're going to do this, or you're going to take a look at this. You're going to have accident investigations. National Transportation Safety Board comes in and puts down some regulations. Again, we need to figure out what's the right mixture. Is it technology? Is it knowledge? Is it standards? And after all that, we need to do development of live test, some test beds, some field conditions to validate this technology. Here is a list of the current R&D projects for prevention that the Office of Pipeline Safety is now working on. There's 5 programs that we've identified as far as preventive maintenance. The first one's basically a study by C4 Technologies. You've got an underwater unmanned vehicle, and then you've got an air-mounted unmanned air vehicle, and then you've got some with ITT Industries, a fixed-wing platform that they've been working on for a couple of years, and they're into the commercialization path with that. As far as encroachment monitoring, it's been talked about this morning. We've got a program that we're working with Northeast Gas, and Daphne's going to talk some more about it a little bit about encroachment monitoring. All these programs, you can see there the dollar that PHMSA is submitting into it and the cost share, and where the program is. You can see the top program is 100% complete, and the bottom program is 32% complete. Here is a map of all the different states that the Office of Pipeline Safety is doing research and development on. Too many times the government's being penalized for having favorite sons or favorite companies they're working with, and we try to emphasize in this map that it's not just focused in one area. This map is available at the website you can see below, and there are 60-some different research projects that have gone on in our office in the last 2.5 years. Some of them are now complete. Some of them are held with universities. Some of them are held with members in this audience. And I just want to remind the folks that there's a lot of research going on here, a lot of different programs, and that this map will show and share the information on these different research programs. What kinds of technologies does PHMSA expect? First we need to take a look at the lessons learned from past accidents, and I call this data mining. And then the next, and the data mining will, as we heard this morning, will help us understand what we haven't already looked at as far as where the technology's been, what it's going to do for the industry, and where do we need to go forward. One of the main other drivers is the effectiveness of the program. It's low cost, high reliability, it's automated approach. How do we get it for less money, and how we show it as a benefit to the industry. Another issue is a quick turnaround time on defect notification. One of the things I heard with the ILI Association and industry and the operators is you run the pig down the line, and it takes a long time for that data to come back before we know where the defects are. we heard this morning about that scenario exactly in disaster where it was pigged, but the information wasn't available before the default happened. The other issue that we're seeing in preventive maintenance is what I consider is not invented here. A lot of times the pipeline community, pipeline operators, aren't looking outside of the areas that they're working with and familiarized with. One of the examples is the automotive industry, like I was telling somebody else. A tailpipe emission sensor in the automotive industry, which costs pennies, is a much more hostile environment than a sensor suite on the pipeline, and yet the pipeline industry are not using them, and there's a disconnect there. Another example is remote monitoring issues. We talked about it this morning on monitoring the encroachment and so forth. And there's a technology being developed right now. It's called M2M, or machine-to-machine technology. For example, Coca-Cola has now in all their soda machines that you get, the little vending machines, it's machine-to-machine language in there, so that the Coca-Cola distributor knows when the equipment is becoming empty, when they need to be refilled, what's the temperature of the soda. And these are consumer-friendly devices that are all around us nowadays that could be that application could be used in a pipeline monitoring system. I know it's kind of far-fetched. We don't want to have Coca-Cola as one of our third-party support vendors, but the technology needs to be transitioned over into the pipeline community. Another one is John Deere tractor with their equipment that they have. They now have a satellite link in all the new tractors they're selling and backhoes and everything, whereas it's just in time for service. That they're monitoring the life and the well-being of the pipeline, of the equipment, and that information could also be fed back into the pipeline one-call notification center. If we put the sensors on the pipeline and they're tied in with the John Deere service network, as the tractor approaches the pipeline, they can notify the one-call systems, or they can actually shut it down. What kinds of results of FIM are we expecting? Universal understanding of root cause failure analysis. We heard that this morning, that nobody can really come up with a solid answer on what is mechanical damage. Nobody can really understand. Everybody has a hard time explaining. Is it corrosion? Is it not corrosion? Is it a dent? Whatever. We're trying to set a goal to reduce or eliminate the unnecessary digs. All the operators here say the digs are very expensive. Hopefully, from the mechanical damage research that we want to do, we can set that as a long-term goal in reducing those digs. Continued support for hosting deployment of technologies. Currently, we've just completed a program at Patel Corporation on demonstrating different IOI technologies. We're working with Northeast Gas on doing some encroachment monitoring technologies. These demonstrations help us to take these technologies out of the research community and demonstrate with the operators how they're going to help reduce the mechanical damage. I think that's it. The last slide is the contacts information. Jeff, myself, Bob Smith, and our website.
Thank you, Jim, for the good overview of what PHMSA is doing. Just as a bit of context, I'm not sure how many of you follow the government research funding for pipelines, but DOT is PHMSA is probably the lead in this particular area. Minerals Management Service is also involved in pipeline research, primarily offshore, along with the National Institute of Standards and Technology. DOE hopefully will get some additional funding in the future. Our next presenter is Harvey Haynes from PRCI.
Thank you, Christina. As Christina says, I'm at the Pipeline Research Council International. I first arrived there and took over Christina's office, so it's a regular revolving door around here. At PRCI, we look at mechanical damage in all aspects. We look at both the damage prevention and the damage detection area. Today, I'm going to be talking about the damage prevention area, but tomorrow, one of my colleagues, David Batt, will be talking about damage detection. And I think you'll see some of the projects that we're working on in several other presentations because we partner with others, such as DOT and the Northeast Gas Association in some instances, and GTI. Anyway, if we look at damage prevention, we look at it in terms of three areas. In terms of research, we try to make improvements to the one-call system. We try to look at encroachment monitoring. In other words, are people in the right-of-way? And once they start excavating, are we trying to determine if they're actually contacting the pipe or actually gouging or hitting the pipe? In some of the previous research we've done with Kiefner & Associates, we've had them analyze data, and this is one of the slides that John didn't get in his talk this morning, but we actually had them look at if there was some way to show that one call has shown an effect in the incident statistics. And as you know, one call got implemented on a state-by-state basis. So if you look at the year that one call legislation got put into effect for various states, like this is where it got put into effect in Kansas, you can see that there's a drop-off in the number of incidents in that state that is roughly related to the year that the one-call legislation got put into that state. And so we saw that relationship here in Kansas and Kentucky, and it's not as clear in Louisiana, but you do see it in Louisiana. In other states like Oklahoma and California, which implemented one call before 1985, you don't see a drop-off in the incidence statistics. So we know that one call has been one of the best things that the industry has done in terms of reducing these immediate damage. So the question, I guess, going back is, now that one call has reduced the number of immediate damaged incidents, what can we do to keep this number low, or what can we do to lower the number of incidents even further? So we can look at this in terms of technologies, practices, and human factors. And this is nothing newer than what other people have talked about this morning, and we look at all three of these. And these are just some of the programs I'm going to talk about today. They're not everything that PRCI has done in the past, but this is our research program for 2006 and these three programs, and I was asked to talk about them today. And then we'll also talk a little bit about satellite airborne monitoring that's been done in the past through GRI and PRCI, and also real-time acoustic monitoring. This project DP1-1 is a project to look at practices. So we're going to survey our members to look at their good practices and procedures, and we're going to look at all aspects. These are just some of the aspects we're going to look at, like markers, surveys, one call. I'm sure some of the things that Jerry talked about this morning are some of the good practices that we will include in our survey. And of course, we'll look at how one call is implemented by the various members. And we don't want to limit our surveys just to our members, but we'll also look at practices from other industries, other non-GRI operators, and even some of our contractors. And of course, these will put into some sort of guideline about what works well. And of course, something that works for one operator may not work for another operator. So good practices are not necessarily good for all, but they're good for certain situations. The second project I'm going to talk about here is this GPS project. This is the complementary project that DOT talked about just before lunch, that Jeff Weiss talked about. This is our side of it. Colonial brought this project for PRCI, and our project manager within Colonial is going to be leading this going forward. Dan Ayers is in the audience if you'd like to talk to him about it. But our part of this is to try to bring the technology to bring GPS to the one-call system. So this is a step in shifting one call from an address location or this grid type of locations to GPS coordinates. So this will provide greater accuracy of location, reduce number of unnecessary locates, and this is a big problem. Colonial tells us that the number of unnecessary locates is several times the number of locates that are actually in the right-of-way. So this should allow them to focus more of their time on preventing incidents where actual digs take place on the pipeline right-of-way. And the next step on this will be to try to relate this device or bring it into the databases for the one-call systems. So Dan has done a good job in finding what will work, and it turns out a simple cell phone will work in terms of providing GPS location coordinates. And he's tracked down the Nextel Sprint, as a company that has systems already in place that can take the cell phone and you can develop a menu for a cell phone that would provide all the information that's needed on a one-call ticket, and then this could be sent off to the one-call centers. So this is sort of how we envision it taking place. Nextel has a partner, it's called Exora, who developed this system. And Dan tells me how many people actually use this already outside of the pipeline industry, but it's in the tens of thousands of people. So you take your cell phone, it records the GPS information from where you're recording the data, you send it off to the Nextel Sprint server, and then we need to develop software which would allow these tickets to go to the one-call servers in the appropriate states. And this looks like it's going to be fairly easy to do. There was no cost in finding the fact that cell phones work. Cell phones right now have an uncertainty of somewhere between 5 and 200 feet. We expect that to get better as newer GPS chips get incorporated into cell phones, and this should make an impact on reducing the number of mislocates and greater emphasis on getting in the right place when we use the one-call systems. So Jeff, this morning you were saying that we need to develop the device. The device is here. Another project is Right-of-Way 1, and this is the project that actually will look at technologies. So we've looked at sort of human factors and we've looked at practices, and this is a project that will look at technologies. We've looked at a lot of technologies over the years at PRCI and at GRI, and they go way back. This is just one of the reports that we'll be incorporating in our current study, and we'll be trying to take these and look at cost performance targets. An example of something that's not cost effective is we could develop a complete satellite network exclusively for the pipeline system, and I'm sure it would monitor the right-of-way very well, but it's obviously cost prohibitive for our industry. So we need to work in a context where things exist already and are cost effective for the industry. And of course, once we identify some front-running technologies, we'll try to put these out and push them in research and eventually go to proof of concept. This is an example of previous programs that were managed by my colleague in the front row over there with the red hair, Keith Lavis. This is an example where they take data from different time periods. This is 1984 data. And over here we have 1994 data. That data can be combined and you can look for differences. We can also look at different frequency bands. We can look at visual spectrum, infrared spectrum, and a promising spectrum is ground, or I guess would be radar. Airborne or satellite radar. And this is an example where multiple spectrums have been incorporated. In particular, radar has identified that there is an object in the right-of-way. It provides, I guess, a nice bright reflector. I'm not quite sure exactly how to interpret this. Keith is nodding his head. That's good. And so something like a vehicle which has lots of metal on it, which would provide a good reflector, could be seen. And just before lunch, I was talking to Manez Friscala, and he's saying that you can now get radar patrolling of your pipeline 3 times a week. And the great thing about radar is it goes through clouds. So this is something that may be incorporated soon. Another project that's been going on for a long time that I personally have had a lot of history in is real-time acoustic monitoring. This is a project that GRI started back in 94 or 95. And has continued for over a decade, and it actually goes back before that because GRI borrowed the technology from the Japanese. So this is something that everybody's familiar with as a child. If you go to a playground, you'll find a pipe in the playground where someone can talk into one end of the pipe, and on the other end of the playground you can listen. Your pipeline does the same thing. It causes acoustic signals to go down a pipe and transmits them very, very well. You can see this in old movies, old submarine movies, where they talk to the guy in the engine room. They're often speaking into some sort of a cone, and before electronics, they did it all with pipes. The pipeline does the same thing, and we've gone through various stages of research here. And we were actually into the pre-commercialization phase with our researchers, GTI and Battelle, and we found out that somebody is starting to deploy this. This is General Electric, so we stopped our research project and are planning to go into deployment with GE here in the next year. Just in the middle here, I have a slide of just some of the data that was collected. I can't remember if it was back in 99 or 2000, but this shows actually someone hitting a pipeline. They're removing the coating, and you can see 7 hits here in this particular graph. And you can actually hear this stuff if you want to listen to the signals. And this is something I've shown before over the years, but I just thought I'd play it for you because everybody likes to hear someone hitting a pipeline, and it especially wakes people up after lunch. So we'll just listen to this. I guess the sound is not turned up here, so maybe this won't work. So maybe that's not going to work. But you can actually hear somebody hitting the pipeline, bang, bang, bang. And the first little one, you can hear him tapping it just to make sure he's got his hammer in the right position. And by the end, he finally has the coating off, so he's not hitting it quite as hard. So he's able to get that coating off in about 7 minutes. This is just some pictures of the GE system. GE has gone and taken a lot of pieces from their big corporation and implemented them to something that would be useful for pipelines. You get out on the pipeline, you have to have power. It turns out GE has a solar power company. They need communications. Cell phones don't work in all of the pipeline right away because a lot of it's remote, so they've gone to satellite communications. GE has a satellite communication company. And in addition, they've gone to hydrophones because there are blow-off valves on pipelines where you can just stick the hydrophone in and you don't have to do an excavation and attach an accelerometer to the pipe. We expect to be doing some demonstrations or deployment tests this year, pending approval by our committees, where we actually go out with a backhoe and do some scraping on pipes that are filled with water for hydro tests. In summary, these are the 3 projects I tried to show. One is Right-of-Way 1, which is looking at technologies for monitoring pipeline right-of-ways. DP1-1 is for looking at practices, and then DP1-4 is to try to improve the one-call systems. And if we go and look for the future, these are some of the areas that we need to look at. One is data capture. There are other industries working in the data capture area. An example is the defense and aerospace industries. That's where most of the satellite technology comes from. GPS. GPS is getting more and more accurate and cheaper. And hopefully in the future, maybe we can attach GPS to these backhoe equipment or excavation equipment in the right-of-way. Some have envisioned a future where every backhoe has a GPS unit and you can track it as it goes wherever it goes, and so you know where it's been. In the visualization, as we collect more and more data, we're going to learn how to visualize that, and we need to borrow from other industries such as the medical imaging industry and the gaming industry. What better than to make a game out of the imaging to make it more easy to do. And then in response, a lot of times you don't have a lot of time for response. So the best response people we know of in terms of automation is the battlefield logistics. If you have a missile coming at you, you have to make a split-second decision about whether to shoot that down, or if it's a passenger jet that you don't want to shoot it down. And in communications, of course, we're looking at advances right now in cell phones and satellites. As more bandwidth becomes available, we expect to use that to transmit more data. And that's it.
Thank you, Harvey. I would encourage anyone who has questions on any of the particular projects that Harvey mentioned to please grab them afterwards, or if you have questions on PRCI in general, he's a good person to speak to. Our next presenter is not new to this podium, Daphne DeZerko, if I can find her presentation. There you go. Daphne will be speaking about the research going on at NYSERC.
Okay, so at the risk of not being redundant, I'm shifting gears a little, talking more about technology research. And just to start with a little light story here, the picture you see on the screen is from a field test at one of our member companies for damage prevention technology that we've been sponsoring out here in Sandy, Utah. And, one of the things that in my years of R&D is that a lot of times, in order to have the optimism that you need and the funding that you need for research, you have to expect that, you have to promote that you're going to get the successful outcome of research. And many times we do, but there's a lot of risk in research, and many times we fail. Well, here we have a hard-working group and a good technology. It's a fiber optic technology that's a distributed sensor. And one of the advantages of this technology was that you didn't have to sever the line to actually know that you had a party in the area and encroaching. And so the good thing was that you could have proactive monitoring, and it is a good proactive monitoring technology. But in this particular field test out there in Utah, we had so much construction, and this is a distribution area, believe it or not, so much construction that we severed the line several times, and it put us out of business several times during our field test. So it's just an example of how R&D, where we're trying to make steps forward, can sometimes take steps backwards because of real situations. So just wanted to give that example. So this is the same slide as my previous talk. I guess I was figuring I might have a few different folks around. I guess my point is that there are several challenges for damage prevention, whether it's existing or new technology. And the distribution sector has really seen these challenges. And I would suggest that if we're looking for new projects or products in the area of R&D, that any RFP or any solicitation that solicits technologies or ideas from other areas should list these challenges, particularly the need to minimize excavation, to have coverage in 24/7, and to minimize false positives. The benign conditions, we need to be able to filter them out, and we need to realize that some technologies aren't going to work the same in varying soil conditions. So, these are real challenges. Sometimes they counteract each other, but it makes for, basically not going through the same lessons learned as with previous efforts. So, as I said earlier, NYSERC represents a voluntary research organization of many utilities around the country. Voluntary in that we don't have a budget. We build budget up from project need. And in the area of damage prevention, we've had a strategy that's been evolving. We did an RFP back in the 2001-2002 timeframe, and that RFP was generated as a result of direct feedback from a user group in the Northeast that focuses on damages and why we have damages. And while that user group was primarily distribution folks, it was felt that we really should develop a program with multiple projects, both transmission and distribution, and actually focus first on transmission. And the impetus for that was that basically, as we heard this morning, you have many fewer damages that are what we'd call that incipient damage, the damage that goes undetected, but it's those damages, and particularly the ones that have high visibility, that cost the most in terms of safety and cost to the customer and to the operator. So our initial focus was on transmission, thinking that if we found some technologies for transmission, then in the more dense substructures and environments, some of those could flow down to distribution. We also initially targeted the idea of proactive warning before encroachment, and we focused mainly on our own utilities rather than on the sources of damage. And right now, as we evolve, while we've looked at things like fiber optics, which is pictured here, and real-time monitoring, they do serve a real niche, particularly for transmission applications. We have ongoing projects, but we're also going to be expanding our search to not just prevention by warning both in the ground, but we think we have to get technologies for warning at the source of damage. Relevant research projects, I'm going to talk a little bit more about GPR because we have some research technologies that are not commercial but are very promising for better location. One of them is a handheld or a portable pipe locator. Another one is a combination pipe and cast iron joint locator. And you may ask, well, why does that fall into damage prevention? Well, the pipe location does. But one of the things about cast iron joints, we have lots of cast iron pipes still left in the distribution sector. Therefore, there's still joint replacement and joint identification. And our companies need a joint detector, but they really don't have an economic case for just a joint detector with the diminishing inventory of cast iron pipe. But if you can combine it with a pipe detector, then you have a business case. So many times we have to, look at how we're going to make an economic case to a commercializer, and that's another way that we're going to get more pipe location. In the area of damage prevention sensing, one of the ones that we're co-funding with PHMSA and OPS is a development of a seismic sensor. Harvey just talked about the acoustic approach that both Battelle, GTI, and even GE now are looking at. We've been active in some of that, but I won't go into that. The fiber optic is our distributed sensor as opposed to point sensor. There are some companies doing that. We worked with a company out of Australia known as FFT, Future Fiber Technologies. We were one of the first U.S. field tests of that technology. They worked on a technology for 8 years before they brought it to the U.S. When we looked at it, we thought it was technology deployment. And typically, when you take it from one industry to another, it may not necessarily be technology deployment. In this case, we've had good success, but it's been more a development than a deployment. Other relevant research projects, some of you may be familiar with reinforced thermoplastic pipe. We've analyzed that pipe, that composite pipe, for possible use because of higher resistance to third-party damage. And then also another research project that's starting up with one of our members relates to peelable pipe. Some of you may be familiar with the Uponor Profuse product. So in terms of the handheld pipe locator, this is one of our projects. It was generated from a worldwide RFP that we issued in 2001. At that time, we started 2 or 3 projects in this area. We had a very definitive sense of what we needed because our users have been involved since the mid-'80s in development of pipe location, and we'd evolved from sort of the mapping system with 3D imagery to an idea that we really wanted a low-end tool, a construction crew check tool that is both portable and used for strictly on-site markout, that we weren't going to try to wrap in data capture and CAD capability back at the office, but rather that we were going to have something that was widely distributed, not expensive, but something that construction companies and other users in the subsurface engineering sector could use on a widely used basis and get volumes up and costs down. So we did go with a GPR type of product. The innovation in it is that instead of the CARTS type systems that I showed in my earlier presentation, those are called ground coupled antennas. Rather, we'd go with an air coupled antenna, meaning that your system is off the ground, is portable, and does not need to go across a grid as many conventional GPR systems do. We wanted a shoulder mounted battery pack and display. Our other vision was that while we wanted lateral location as the primary markout point, that there are many uses for a vertical prediction of location, so that in addition to this focus, which would be on the air-coupled antenna, that we develop an optional ground-coupled antenna. Our users called it what we call a Bissell sweeper, like your old Bissell sweeper thing for your household. We would have this drop-down unit that would give us, with the ground-coupled approach, the depth prediction. And as I said, there would be no off-site processing. We have other specifications like being able to mark out facilities from 1/2 inch to 30 inches in diameter, penetration depths down to 10 feet, although our nominal depth for distribution pipes is 3 feet. That the product should not require connection to any facility, and that's, of course, portability and use across a variety of uses. And then, of course, the easy interpretation of data. That was important. So we have been involved in a development with both a developer and a commercializer now for a few years. We have developed an air-coupled antenna. We initially had what we call a bistatic antenna. That's a 2-headed antenna for 2 reasons, both for FCC reasons and for portability reasons. We've crunched that down into a single-headed air-coupled antenna that we call the monostatic. We did extensive field tests in 2003, and in my experience, I've never had users excited with what I call a bench scale prototype. We had a great antenna, but we had done no engineering. We had our antenna on a shower curtain pole, and we had our control pack hanging off that shower curtain pole. And usually the operators that I work with in the field want to see a hardened tool that they can go at from a commercial standpoint from the get-go. And it's rather surprisingly, because the images that they saw were accurate and were easy to read, they didn't care about how sensitive this tool was and how early stage it was. So we had quite a good response. We had good accuracy. And since 2003, we've been focusing on boiling that 2-headed system, the bistatic system that had a total weight of 17 pounds, down to the monostatic system with a total weight of 10 to 12 pounds. We have had success in that area. We are in the process of negotiating a partnership with a commercializer, and we realize that we have to get out of the mode of cantilevered control pack off a shower pole and have some ergonomic design and advanced engineering. So we're now at the stage, and this is always a critical stage, when to get the commercializer in, how to get them in, with the market saying they need something but the product isn't done, and we are working on that now. So we expect that we'll be done here in 2007, and it's not necessarily a future need, but it's something that's not quite finished. The pictures you see are something that we emphasize strongly with our research consortium, which is lots of field testing. The upper picture there is in Queens. And the last thing a new scientist wants to do is go to Queens and try to be put to the test by gas operators in real sites on real streets in noisy conditions. But we do start out with that, with the knowledge that you're not always going to get everything in the first sets of tests. But we did actually a decent job there at Con Edison. And the lower one is the monostatic antenna being tested in New Jersey in a highly graveled area, which traditionally gives a problem with ground-penetrating radar. So I guess I just wanted to show those illustrations to say that, you know, the talk is cheap, but the products we're developing, although they're sometimes not in field or not in commercially hardened format, they are being put to real tests by users who are giving us the feedback and the incentive to invest further in these technologies. Here's another one that we've been funding for a year or so now. It's the Harris Technologies ultra-low frequency pipe and joint imaging system. This is the one that is intended to do both pipe location and location of cast iron joints. It is intended to be a cart-based system but lightweight, and the developer there has a future vision of being a handheld system. Managing research for many years now, I also try to manage expectations. It may be a handheld system, but it may remain a cart system. It really depends on the trade-offs, and if we want to get accuracy in all the ways we want to get accuracy, including all soils, I'm not sure this particular system will end up handheld, but I could be proven wrong. Anyway, this is a very unique approach. The organization that's working with us is working at very low frequencies, feels that it typically, when you're working low frequency in GPR, you get good depth penetration, but you need to work at higher frequency to get good resolution. And the claim here that we've seen proven to some extent is that you can still get good resolution, very good resolution, in a number of different soils at the low frequencies. So it's a very intriguing system. It also has a unique approach for automatic calculation of dielectric constant, and certainly if you know your soil dielectric constant, you can get better predictions of what they call soil propagation velocities and therefore better depth predictions. So we're pretty excited about this technology. We just submitted it to PHMSA and OPS for co-funding, and we expect that they will be joining us in co-funding this going forward. The status of this program, as you can see in this previous picture, when we first started looking at this technology, and this was in Philadelphia area with PICO, one of our members, we had a very large cart. We had a slow process that he could get all the same predictions as some of the commercial devices and do even better, but it was a very slow process and there were limitations in terms of the density of the substructure. Now we're down to this, it's almost like the Bissell sweeper concept I talked about, a very lightweight cart, and they've done a lot of work to refine this antenna and to get us both pipes and joints in fairly confined areas, and an activity that we worked on called focusing. We did quite a bit of work in focusing, and that stuff is done, and now we're moving into the development pre-commercialization phase. We also had some testing at Baltimore Gas and Electric on joints, ahead of some other testing that we're doing actually this month with both the folks in the urban areas as well as in suburban Philadelphia again. So this is going forward. We're anxious and happy that PHMSA is joining us in co-funding this. And the one thing I would say is that when you work with, sometimes when you work with innovators that are from small entrepreneurial firms, the trick for a manager like myself is to get them married with a distributor. And one of my focuses in this project is to create the marriage that will result in commercial accessibility to a broad market, and that's one of the things we'll be focusing on. So this is one of the projects that Jim Merritt mentioned that we're working on with OPS, and that's the seismic sensing system. It's also low frequency. It came from a defense application, and it's from Physical Sciences in Andover, Mass. This is a point sensor similar to the GasNet system I described before, where you have sensors distributed around at different small holes within the area, maybe a particularly sensitive area. It uses an infrasonic frequency range. It's using triangulation to pinpoint accuracy. We've been working on algorithms for identifying different types of equipment that might be in the area, and we want to provide a warning ahead of time. We've done, in a research type of methodology, we've done proof of concept. After proof of concept, we were able to get OPS involved, so we're now in development phase. We've done 2 or 3 stages of field testing OPS is also adding some additional funds to this to accelerate the commercialization of it. And we're looking this year for commercial partners. Last year we did tests at a test bed that NiSearch has developed, and we were able to show that the alpha prototypes worked. We're still sort of optimizing what we call the beta system. We have some concerns about location accuracy, and certainly different soils create different sort of complexity in terms of time lags and pinpoint accuracy of location. So we're focusing now with some geophysical experts on the differences in soil propagation velocities and how this particular sensor will get real good location accuracy. So SBIR money is available thanks to Jim Merritt and the folks at OPS, so that's helping the situation. And jointly we're going to work on a commercial partner for this system. The other thought I had in bringing, there's a lot of different ways you can address damage prevention. Some of the stuff we've done relates to resistant materials. And for those of you who are looking at the picture and going, oh, there's a captured them pulling out a pipe, that was actually a test that we purposely did, because when we got looking at this reinforced thermoplastic pipe, which is European pipe material that's, well, it's not European, but it's being used by companies both in Europe and Asia for high temperature applications and for some gas and liquids applications. We wanted to look at it not just as a possible pipe in the gas industry for maybe upgrading pressures, but we wanted to look at it to determine its resistance to third-party damage. So our folks got started with a sort of a combination of paper assessment as well as field test assessment, and we did 12 different types of scenarios in the field in New Jersey where we really tried to get at this pipe and try to penetrate it. And so what you see in that picture is some of the results of those tests. But this, if you haven't heard of RTP, it stands for Reinforced Thermoplastic. It has a pressure rating of up to 600 psi. It is European, so it's kind of an odd, for us it's odd sizes, availability in 4 and 5 inch, and it has 200 and 400 foot length cables. So we did third-party impact tests on this pipe. As you can see in the lower right, it has a composite makeup. It's a high-density PE for the inner sleeve, polyester reinforcement in the middle, and then an outer sleeve that's also high-density PE. So we did 20 tests. 10 were with the RTP and 8 were with steel. And what we found, and we did some with plastic as well, what we found was that the RTP didn't stand up as well as steel, but it would do much better than plastic. So this was the kind of thing that we looked at. The one thing, though, is that we found that the RTP still required special installation procedures as well as special fittings. So this, like some other sort of composite pipes, are very intriguing for the future, but not all the issues have been addressed, and there's still some potential work to be done on materials like RTP. Some other resistant pipe materials, I mentioned the peelable pipe. This is a product that has basically a polypropylene outer layer that's about half to 1.5 millimeters thick or 0.06 hundredths of an inch thick. And the nice part about this is that you can use traditional electrofusion joining techniques, but this outer layer does a couple things. It provides scratch resistance. You still have your high-density PE or your PE 100 as your inner core. So you have all the workings of a traditional PE pipe, but you have this hard outer core that can be peeled off for fusing. In addition, not necessarily third-party damage, but first-party construction. I heard this morning some statistics about first-party damage that may have gone unaddressed or overlooked. And when you have this peelable material, it makes the installation nicks and damages very visible, and you can identify that and address that at installation. So one of our members is working on a pilot project for this material. We're just getting into this ourselves, so our strategy isn't fully developed. But I thought coming to a research and technologies type of discussion, we should be thinking about modern materials. Similarly, there's a combination pipes, they're PE as well as cross-link PE, which gives sort of a prevention, again, from scratches, but another source of third-party damage is rock impingement. So, some of these composite pipes can be protected against rock impingement. There's another product called Eduplast. I think there's another one called FlexCore. So I don't want to sort of overlook any vendors or any materials, but I guess my point is that some of these newer pipes that are available in Europe and other areas should be brought to our country, and we should be doing these types of work to find out if they are in fact going to work for our industry in terms of resistance to scratches and gouges and impingement. So, I wanted to bring that to the discussion. So what are we doing? Well, as I said, in the past, our strategy is to look at proactive monitoring systems. We have looked at both distributed sensors and point sensors, and as you saw earlier, our real-time sensing system, and they are going to be applied in primarily transmission applications and maybe some distribution applications. But given the importance of this, and being that we're a research organization, I think our group wants us to continue looking for even more. And I think one area that we've kind of stayed away from that we want to get into is what kind of sensors can be placed right on the construction equipment, and how can we help with that type of process. Also, another area that some of our members are keen in looking at is more effective digging practices. Whether it's soft digging tools or innovative excavation technologies, can we in the gas industry help create technologies that is going to make it safer near our pipes? The other thing I wanted to bring up was, I know that working with DOE, there have been development of pipe materials in the past. I know that Idaho did one, Idaho National Energy and Environmental Lab did one, for having microsensors implanted right in the pipe. And when that technology was brought to our user groups in Northeast Gas Association and NYSERC, we saw that it had great technical potential, but economically it was orders of magnitudes off in terms of something our people would buy. So I guess I would challenge research agencies like ours and OPS and others to look at innovation in integrating microsensors right in pipe material and trying to get something more economic to the table. So again, the question that I saw in one of the workshop charges was, what technology needs, if addressed, can provide significant advancement? I think we need to have more innovation and economical approaches, and sometimes those two approaches don't necessarily agree. For damage prevention, some of the challenges that I've presented in terms of what the distribution sector has, we have to keep after them, and we're going to try to go full speed ahead in finding some more. And then I think not only do we have to have prevention sort of focus, but so do the construction companies and the small diggers. And if we have proactive systems and sensors on tools, or even, like I said, a lightweight, low-cost pipe locator, then we can bring in other people that are the sources, or other organizations that are a source of damage, and get them involved to help us with these technology needs. So, in summary, I don't think we're starting at scratch here. I think several of the damage prevention challenges are being addressed. I know we're addressing many. You'll hear from GTI and others that are addressing many. But there is more R&D needed in this area. In my opinion, I don't think we have to start over with GPR, and I know many have sort of given up on GPR. But my message is that there is some really promising technologies that are either for sale, if you want to be trained and use cart-mounted systems, or that are coming down the line that are going to be portable systems. And what they need are engineering and technology transfer, and sort of, an outlet that allows widespread use and low cost. And I think we're getting much closer than we were, say, a decade ago in using advanced pipe location technologies. As far as proactive warning systems, we think that there are some that are available, not necessarily many for distribution because of the dense environments and the bends and all the different things that create or prevent long, straight runs of pipe. But we think that we have to keep after this in sort of a multi-pronged approach. So I think this is, in a research organization, this is a big area for looking for more innovation and going forward and finding new projects in this area. So, thank you.
Thank you, Daphne. I must say I will be looking at shower curtain rods in a whole new light now. Once again, I would encourage anyone with questions of any of the projects NYSERC is currently underway to see Daphne, along with any questions you may have on NYSERC. And our next presenter is Maureen Dressler, and I apologize if I mispronounce her name, who will be discussing OTD.
Thanks, Christina. Which is the, oh, okay. Did you make it bigger?
Yeah, right there, sorry.
Okay. I'm representing Operations Technology Development today, which is otherwise known as OTD. And we are very pleased to have this chance to talk about the research that we're doing in the prevention area today. OTD, because most of you are not familiar with us, is a standalone, not-for-profit, member-controlled company where the gas utilities work together to develop common solutions to common operations issues. And currently there are 17 members of the company, and our 2006 dues were approximately $7.4 million for research. Our research is funded in 4 areas for OTD, and because they're distribution companies, they are very interested in these particular objectives: enhancing system safety, improving the operating efficiencies, reducing operating costs, and maintaining the system reliability and integrity. There are 6 program areas which we divide our research into, and those include pipe and leak detection, pipe materials, repair and rehabilitation, excavation and restoration, pipeline integrity management and automation, operations infrastructure support, and environmental science and forensic chemistry. We've started 17 new projects this year in 2006. I will echo and support all of the technology needs that everybody has presented today, and let me just highlight some that we think are particular challenges that we're interested in finding solutions to. And many people have mentioned this first one, and that's monitoring and characterizing the unauthorized activity near pipelines. We still think this is a very critical issue and needs to be addressed. And we suggest that we'd like to consider both internal and external monitoring sensors. Also developing tougher materials, and Daphne talked about that too. We're very interested in looking at pipe materials as well as coatings that might resist damage, and that way prevent the damage from happening. And then also the general topic of improving locators. Again, we've got to address accuracy, depth, smaller diameter pipes or smaller objects that the locators can find, the types of materials that can be detected, and the soils that we've been talking about, the need to lower the cost as well as increase the ease of use for the operator. And then let me go through some of the projects that we're funding in OTD. And the first few have to do with subsurface mapping and location. And we've been looking at underground facility pinpointing, and we've conducted an independent comparative technical evaluation and field evaluation of emerging locator technologies. These locator technologies included electromagnetic, ground-penetrating radar, magnetic, acoustic, and ultrasonic. And in 2006, we are focusing those efforts on the non-electromagnetic locator technologies. We previously have completed a report that does detail and gives you a comparison of electromagnetic locators, and if anyone's interested, that report is available. We're also looking at a handheld acoustic pipe locator, and it's using sonic technology to provide accurate location information on buried metal, plastic, or concrete pipes. And the goal is to consistently and accurately detect pipe as small as 2 inches in diameter at depths from 6 inches to 8 feet. And the status for that project is that the prototype detector has been built and evaluated in the field, and the work in 2006 includes testing in some difficult terrains and improving the speed of the data collection and the analysis. And we are also in the midst of commercialization discussions. The next technology for mapping and locating is buried pipe imaging by capacitive tomography. And you're going to hear more about this next with some photos. And this is developing a compact and inexpensive capacitive tomography imaging prototype in the form of a flat plate or a flexible mat that can be placed on the ground to quickly and accurately provide an image of the buried object in the soil below the sensor. And the objective is to locate facilities to a depth of 6 feet. And this has had some successful laboratory testing in 2005, and in 2006 we're looking at the electronic simplification, hardening of the overall device, and field testing. and we'll also be working on software development and the system integration. Now I'm going to talk about a few technologies that are used with boring equipment and horizontal drilling. And this one is the integration of electromagnetic and acoustic obstacle detection systems for horizontal directional drilling. And what this does is combine the advantages of the two technologies into a single wireless mobile obstacle detection concept for use in horizontal directional drilling operations. And the objective is to design, build, and test a system that will provide real-time detection of underground objects near the drill head. And the current status involves the integration of the detection and communication systems with the HDD machine. And a prototype system will be tested this year in the field. Also looking at boring equipment, in this case, the obstacle detection system is using ground-penetrating radar. And we are adapting and integrating the radar system with the horizontal drilling machine and evaluating the pre-prototype system in the field. The objective is to sense the obstacles when they're at least 6 feet in front of the drill head so that the system would have time to stop and the operator would be able to maneuver the drill head to miss the obstacles. And in 2006, the electronics for this system are being ruggedized and the software is integrated, and a pre-prototype will be tested in the field. I wanted to also bring up micro-excavation, and this has to do with the overall topic of locating the pipe. This can address daylighting the buried pipe for a more precise location, and it's appropriate for all types of pipe. What we're doing is developing tools that make a micro-size excavation, and those are 4 to 6 inches, so that you can access the buried facilities through a smaller and much less expensive opening than a larger excavation. And this year, the prototype tools are being developed and tried and commercialized for the actual excavation tool, and we are also developing other tools that can be used down that hole to actually characterize the pipe itself. And then talking about improved materials, this is a project where we're looking at maintenance-free pipeline coatings for critical locations. And what we're doing here is we're evaluating thermal spray systems and coating materials for application on different pipe that would be in critical locations or difficult to access areas to ensure corrosion-free life of 50 to 70 years. And the objective is to take the relatively mature technology of metallic coatings, which have been used in other industries, and use their superior corrosion and mechanical damage protection and apply it to above and below ground pipeline locations. We're conducting laboratory tests using the ASTM codes and protocols, and we're looking at various aspects, including adhesive and adhesive strength, impact resistance, abrasion, disbondment, effects of salt and UV radiation, substrate corrosion, and blistering. And field testing of the top 4 systems will be completed this year. And with that, I just want to thank you very much for the opportunity to present our research here today. Thank you.
Thank you, Maureen. While I know that you said that the emphasis is on distribution pipeline research, I think most of the audience would agree that some of this technology, once it comes to fruition, will greatly benefit the transmission and the hazardous liquid industry. With that, our final speaker before break, don't you hate that, Chris, is Chris Yokowski from GTI. And let's see if we can get your presentation up here. There you go.
Thank you, Christina. It's actually a much better spot being the first one right after break because there tends to be some audience attrition. I'm Chris Yolkowski. I'm going to talk to you about a number of technologies that we've worked on at GTI in collaboration with many of the people right here at this table. And I'm going to do a little bit of an in-depth coverage of one technology in particular that is applicable to horizontal directional drilling. And I'll point out immediately that Max Kiba, who's out there in the audience, wrote the majority of the slides for the differential impedance obstacle detection, so if you have any really hard technical questions, you go ask him about it. Okay? causes of mechanical damage, and I'm going to be a little bit redundant with the speakers before me. Obviously, third-party construction activities are a big driver of this. Impacts during horizontal directional drilling can be third-party, first-party, second-party, depending on who your operator is. And one that we've also dealt with is overstress of the product pipe during pulling operations, and we've actually done some technology to address that issue as well. What are the challenges? You got to locate these things through a good blanket of soil. Also, there's a lot of art and science that's already been applied to the location of metallic substructures, but the newer plastic materials are a little bit harder to find, especially if your tracer wire has been compromised. And cement ducts and clay pipes have always been a challenge, and there's maybe not as much art applied to those as there should be. And the last one, which everybody's alluded to a little bit, is you have to give the user an easily interpreted interface. Many a good technological idea has fallen down on the user interface, where you get it out there and the people say, this may be good technology, but it's too hard for me to use. There's also been a lot said already about proactive versus reactive. That we would prefer not to have any contact between the pipe and any kind of drilling and digging equipment that's out there. You can use 24/7 monitoring to detect the impact, but you'd really like to see it ahead of time. And there are some varieties of 24/7 monitoring that actually do give you a little bit of lead time over knowing actually I've been struck. Okay, you all know what the consequences are. There's a lot of economic dislocation and injury and fatality that can occur if you actually breach a pipeline carrying a hazardous substance. So detection is good, but prevention is always better. The areas that we've worked in are detections of activities in the right-of-way, monitoring plastic pipe during the installation process. We're doing some work in the detection and imaging of plastic pipe from above ground. And as I said, the subject I'll speak the longest on is the detection of obstacles ahead of the horizontal directional drill. Okay, this is the acoustic impact detection on pipelines, which I believe everybody at this table has worked on at some point or another. This is a multiple sponsored project with multiple contractors working on it. What you see there are some acoustic impact detectors that are actually applied directly to the pipe wall. That hardware was developed by Battelle. And where GTI put their technical oar in the water on this one is we worked on some of the signal processing on the back end of that to be able to extract the impacts from background noise. So again, it kind of speaks to that user interface thing. You have so many false positives that the people shut the alarm system off because it's telling them to go out and get in the truck and go look every 5 minutes. We've also done some work in the optical fiber in the right-of-way for monitoring. This is the one that we worked on is a little bit different principle than the FFT one, but the end result is the same. What you're doing is you're burying a fiber in the right-of-way above your pipeline. So what you ideally, the way the system works is you will see the vehicle come into the right-of-way, and you'll see them start to dig. So you've at least got half an hour or 20 minutes of lead time before you might have an actual contact with the pipe. Some of the issues that you run into with this kind of system, though, that we did is, the sensitivity. You'd like the sensitivity to be high, which means you would like the fiber to be well coupled to the soil, but you would also like the fiber to be rugged, which gets to be a little bit of a contradictory goal after a while. You want that good exposure to the soil so the vibration transmits into it easily, but you want a fiber that won't break at the least provocation. So there's this one is currently as far as it's going to go, and we've stopped work on it for the meantime. What would need to be done is the sensitivity brought up a bit in a catalog of the different types of enroachment made so that you could signal process out a horse running across the right-of-way from somebody actually starting to dig. This one is a toe tension monitor, and where this is put is in the between the back reamer and the product pipe. When you've done your boring, and now you're pulling the product pipe back in. And what this does is it actually monitors the tension going into your product pipe right at the point of application. So you've eliminated the stresses on the drill string and the back reamer, and you're seeing the actual tension that you're applying to the plastic. And this We have a working prototype of this, and one of the claims to fame of this apparatus is we actually developed a system to send the data back along the drill string all the way back to the operator, so that the fellow operating the rig can actually see the tension on the plastic pipe, and you don't have a surface sensor sitting out in the right of the way, and you don't have the fellow walking along with a box. And again, working electronics, we need to harden up the mechanics on this a little bit. We've had a couple of, this is done in collaboration between GRI and Keyspan. We had a couple of successful tests out at Keyspan, but there's still more work to do. This one is the capacitive tomography, or if you want to use a more general term, impedance tomography for looking down into the soil. This is the one that Maureen said a few words about being sponsored by the OTD. And what happens with this is, and this is, if you will, also a first cousin of the horizontal directional drilling obstacle detection I'm going to talk about. It injects a low-frequency electrical signal into the ground, so we get the depth of penetration issues circumvented that way by going to low frequencies. And it looks at the current, you see 16 plates on the bottom of that plot. And current rev is up to 64 of those sensors. You put it down and we measure the impedance under each one of those plates. So if there's a void in the soil and a gas carrying pipe qualifies as a void, we see that discontinuity in the soil properties and we can image it out with this device. Okay, main part of what I'm going to deal with here is more and more people are using HDD. You got to worry about, are you going to run into something when you're doing this operation? Well, do we need it? That's sort of a rhetorical question, if we need obstacle detection or not. Okay, I'm not going to bore this audience too long on what HDD is. You're all familiar with the process. You can push the drill right through, pull the product back. So what are our objectives with this technology? Well, we want it to be sensitive to all the materials that are down there. And again, plastic being a special challenge because there's not been a lot of technology devoted to the detection of buried plastics before now. We wanted to address some of the issues that you see with GPR in that if you have a really wet or a mineralized soil, you can have some depth of penetration issues associated with that. And again, that user interface issue. It has to be easy to use. If you make your life more complicated for your crew, they're not going to use it. This is originally, the phase one was funded by DOE and FERC, and these are actually some of the original drawings that were in that first proposal to DOE. And what we're looking at is what was the least that we could modify the existing drill head. And what we're looking at was being able to actually laminate a sensor onto the outside of that existing drill head and use the drill tip without any real modification to it. And the principle being you inject a low-frequency signal into the soil ahead and around the drill tip. And if the soil is undisturbed, you get one pattern of returns, and if there's a disturbance in it, you get a different pattern of returns. Technical advantages, well, we're using the existing drill tip, the blade on the front leading edge of that drill, to carry the signal into the soil. So you don't need to replace it with a carbon fiber blade or some exotic material that the manufacturers are going to look at and say, no way are we doing that. Also, by injecting current ahead of the drill, you kind of eliminated having a blind spot dead ahead, which can be an issue with some of the other technologies. Lower frequency of penetration, we can get a little bit further ahead than you could with the GPR. And again, self-contained, all the sensing apparatus is right there. You don't need a surface sensor. You don't need a walker with a box. So again, in principle, and this also refers to the capacitive tomography cart that we're talking about, you're injecting something in the low 50 to 100 kilohertz range into the soil, and if there is a void or an obstacle in the soil, it disturbs the return currents, and you can see that stand out from the background. Disadvantages, okay, the low frequency gives you the depth of penetration, but doesn't give you the fine resolution images. And I'll stop and say a few words about what we're looking for the horizontal directional tool. With the CT, the cart, we're actually going to get an image of what's down there. With this, the ultimate display will be something like the old-fashioned radar vector scope, where as the drill turns, you'll get a sweep, and you'll be able to say, okay, there's an obstacle there, but we're not looking to get an actual picture of what is ahead, saying there is something over here, and we should swerve the drill to avoid it. And you'll maybe see, for a pipeline that's in your path, you'll see a distributed object across that display. But I don't want to misle anybody that we're going for super high resolution imaging with this. This is purely avoidance. Okay, first prototype more or less followed the initial drawing. The coupling of the sensors was capacitive. Part of the drive current went in at the front end, and the sensitivity wasn't as good as we would have liked. And then we started looking at actually what happens when you add now a couple hundred feet of drill pipe behind that, and decided that maybe a slightly different means of injecting the signal into the soil than what we originally planned was better. So the second approach, now what you're seeing here is, do I have an active pointer on here? What you're seeing is the leading edge of the drill is the same unmodified drill that you always have. It's a metallic tip, so you can shoot current in that end, and then the pipe will serve as a return. But there's a little insulated zone between the two where the sensors reside, and that is where our pickups are. So here are a couple of different versions of that we tested. On the one to your left, you can kind of see its point contacts, where there are actually a couple of metallic screws that stuck out at the side that were the sensors. And this one, the current is traveling from the tip to the shaft. And then in order to try to improve the sensitivity to that, we actually increased the surface area of those pickups, and that's what the lower right there is. Okay. And the problem with this version of it was contact potential. Yes, everybody knows you put a metal in contact with a wet soil, you're going to get some kind of contact potential. Our thinking was that it would be consistent enough from one side of the tool to the other side of the tool that the differential signal would back it back out again, but in fact it was not nearly that repeatable. Okay, so then the hybrid version, and the one that we're working on now, is we kept the metallic drive, so the current drive, again, is from the tip of the tool back to the shaft, but we're actually back to capacitive coupling on the sensors, and this is sort of the best of the two earlier versions combined, if you will. And we also did improve the electronics and the shielding on this, and got more of the amplifiers down inside of the body of the tool, close to where the sensors are. So an electrical diagram, it looks something like this. You can see we're injecting the signal between the tip and the shaft and doing a pickup just after that. Better, it's easier to balance. We've gotten away from the soil contact issues. The sensitivity is up a bit, and what we're doing now is moving more and more of the electronics into our test pod there to eliminate some of the problems that we know we have are cable capacitance and noise pickup that can be eliminated by moving the electronics closer to the sensor head itself. And I just said that. Okay. Then we did some bench tests where we put metallic and plastic targets near it in air, and the scale here is that the 0 point, if you will, is in the low millivolts. But if you bring a metallic target near it, you see it unbalance on one side, return to 0, and unbalance in the opposite direction, which is what you would expect. If the obstacle is to one side, the signal swings negative. If the obstacle is to the other side, the signal swings positive. And in air, which is where this particular test is done, and I'll move on to some soil tests, you expect the metallic target to have a bigger return than plastic. And when you go into a soil which is conductive, you expect the result to be the opposite, and that is indeed the case. And this is some instrument outputs that generated the numeric data from the previous slide. Okay, during our wonderful Chicago winters, this is where we do a lot of the testing before the weather breaks. We have an indoor soils lab where we have about 8 feet of soil, starting at the floor level there and going down, and some plastic targets buried in there where we can test these things. So the soil test here is we have the probe is driven alongside a plastic pipe that we have in that soil spit, and then we rotate it to see what the returns are as the tool is spun around by hand. And you see, and again, realize that that frighteningly large-looking number is actually millivolts and not volts, and the other are volts. So that you see a 0, and then you actually see the pickup as one sensor plate faces it, and then it drops off again, and as each of those 4 sensor plates faces the target in turn, it picks up and drops out, and it does indeed return to 0 as you get back to your initial position. So what we learned in the first phase of this project is that the contact between the soil and the sensor has to be carefully managed. Our sensitivity in front is lower than we'd like, and we're going to have to do some things to improve that in the phase 2 that we're working on now. and that the soil impeded the field lines a little bit, penetrating into it a little bit more than we'd anticipated. So we've entered phase 2 now. We're currently working with the American Water Works Association as one of our funders, because they're folks who have plastic water mains have exactly the same issues that we do. That, people doing HDD run into the water mains, and it's just as disruptive for them as it is for us. We are also under consideration for some DOT co-funding on this one. Phase 2, we're going to do a lot more, and the picture on the previous slide was exactly that. We're going to spend a little bit more time doing electromagnetic finite element modeling of our sensor before we go cut metal and make a new one, because it's getting to the point now where we would rather tweak it a little bit in the model before we actually go through the expense of building a prototype and shoving it through the soil. We're also looking at the Trenchless Technology Center at Louisiana Tech may be assisting us in the modeling effort. And again, as I alluded to, we need to make some improvements in that forward sensitivity. Right now, we can see better to the sides than we can see right at front, and that's not acceptable. And we've got a couple of technical tricks up our sleeve that I feel can improve that. So in the near term, as I've alluded to also, we're going to push some more of the electronics inside of the pod, because there's a lot of noise pickup and capacitance issues that we can circumvent that way that'll bring the sensitivity up. Conclusions: there are advantages and disadvantages both to the impedance obstacle detection. And this is a very harsh environment to be working on, so you want a very simple sensor that's very cheap to apply. And we also have some modifications to the sense elements that we're going to be trying in the near future that we feel can bring the sensitivity up. And if you want to see the in-depth version of this, Max is going to be presenting it at the No Dig Show down in Nashville this year. Thank you.
Thank you, Chris. I know that obstacle detection, mechanical damage, obstacle detection for horizontal drilling has been on many people's priority lists, so we'll hopefully hear some great results out of this one. With that, we're going to take a break. What I will ask is that the prevention panel from this morning come back up after break, and this panel gets stuck up here for a little bit longer for the Q&A session.
All right, well, thank you. It's a thinning crowd, but the real dedicated crowd remained. So our hats off to you, and in about another hour or so, you can start celebrating Fat Tuesday. And don't forget to celebrate. Where's our friend with the beads when we need him? Yeah. Huh? All right. He is handing out beads. Good. Jerry got him set up for that one. All right. Well, it's been an interesting discussion so far this morning. I've been talking with a lot of people in the hallway and believe that they were finding a lot of value. We decided to create, instead of doing this and peppering the meeting with it as we went along, we're experimenting with trying to consolidate the question and answer session to really pretty much the next hour. But the way I'd like to do this, if you'll work with us on this, is we'll take your questions as we can. But I know, Daphne, you have a... Oh, you're okay?
Yeah.
Oh, okay, good. Somebody just told me you need to leave in 20 minutes. Well, forget that. All right. So out of respect for those on the webcast, and I think there were something like 45 or 50 people on the webcast, we're trying to keep it on schedule and marching forward. So that said, we're in the Q&A time. We're happy to handle Q&As any way that you'd like. As I mentioned before, we had 3x5 cards. To my knowledge, there have been none left. Right, Bob? They're out there, but to my knowledge, no one has submitted a 3x5 card. That means we have a lot of bold people with burning questions. They want to stand at the mic. And to my knowledge, there are no questions over the Internet either at this point, correct? Okay, that's correct. Thank you very much. Mike was sleeping back there, but okay. All right, thank you, Mike. All right, so it's mic time. And so the other rules that we had up front, if you would, just try to keep it brief, but identify yourself and who you're with, and identify, if you would, who you'd like to direct your question to. We'd love to have some time to talk now. We tried to allocate the time, so it's your time. Don't be shy. Huh? It could be a fast session. No, we'll come up with tough questions for the distribution crowd at this point. So, oops, I'm already past 3 strikes.
Yeah.
All right.
Kick it off.
My name's Kevin Carr with Public Service Electric and Gas Company, more of a distribution end. We have some transmission facilities. I guess one of my concerns is we place a lot now on technology, and we can get really ahead there. But at the same time, excavators have other concerns. I'll give an example, excess flow valves. They can prevent damages. On the other hand, from the excavator side, they can think, hey, you know, if I cut these, I can dig and break them and keep going ahead. So I think we also need to put some of that technology focus on the human factor side, especially from social. What areas are you addressing there, especially from the excavator point of view?
Well, I'll take the first pass at it. That part obviously really critical is the public education part, to get to those excavators, to make sure they understand the inherent dangers of working around live loaded pipelines, those kinds of things. Historically, we've had and I would ask any operator to stand up if I'm wrong, but historically we've had very little success in that regard. When you have meetings, you get the ones that care, and they show up and participate. So our challenge, obviously, is to get to the much greater population of the ones that are out there that don't care. Again, like some of the things that I showed in my presentation, we're going to use those kinds of things to try to get them engaged by doing things as silly as doing lotteries and doing websites to get them engaged. Say, win a fabulous prize if you come here and answer some questions. Those kinds of things to at least get them to understand. We understand by sending them letters. It's too easy that you put it on your desk and throw it away. But if you give them a website, we found out they can come back to it. They say, well, I don't want to do it now, but I'll go there some other day. So we think that may be an effective way of doing it.
I'll just add a quick comment. Our focus in this workshop has been exceedingly narrow, really trying to focus on technology. We do address those elements in a lot of other ways. As many of the presenters, I know Gwinnett was talking about that, and Jerry too. RP 1162 is designed to enhance communications with those people. But I will tell you that we've had a pretty long partnership with their national and many of their state chapters, whether it's the Association of General Contractors, NUCA, which are the National Underground Contractor Association. And there are a lot of tricks and techniques. We were actually talking about one earlier, how you get people's attention, tell them it's an important issue. And when we were talking with emergency responders, we talked about this clip where you see the emergency responders know there's a confirmed gas leak of some size in the area, and the guy drives right into it. They had a film clip. Somebody actually saw this, and you see the flame come from underneath the engine. And that guy was with your company, right? No, he's with PG&E, right? Okay. He says, I show that at the beginning of every meeting with emergency responders, and he goes, from that moment on, they're all paying attention. The point of that being is somehow they got to show them that's relevant to them. Who are the people who are getting hurt in these incidents? More often than not, these are industrial accidents, ones we should take just as seriously as we take public accidents. But one thing that we are doing in our communications efforts, and then I'll bring it back to technology, is we are trying to start, and it's a slippery slope. We're starting to differentiate between public and fundamentally industrial issues. Because I think it'll show very quickly that a lot of the consequences coming out in the industrial end. And that should say something to those communities that this is an important issue that they need to focus on. But that said, money always commands the bottom line. Unless you can get a message to them, tell them they're at risk. They're the ones who are really at risk if they don't follow the process. I'm not entirely sure. But okay. Other questions? Chris.
Hi, I'm Chris Foley. I had a question for Chris Von Egmond. Is she? Oh, great. Say, concerning the Canadian pipeline crossing regulations, I was wondering if you could talk to several questions. One, do your regulations have any exemptions for parties who aren't covered by the law? And were your enforcements severe enough that people took notice, and were the enforcements used? And you mentioned you are coming out with some new regulations, and is that going to change at all in there? And if you could answer for the provincial regulation too, if you know.
I'll just turn this around maybe. There. I'm going to have to ask you to repeat the questions because I lost the first one actually. It's late in the day and there's only so much going in.
Here, from state to state, different third parties could be exempt from the one call regulations. Is the Canadian law like that at all?
No. Everybody that's, to the extent that I'm aware, everybody that's going to do work on federally regulated pipelines, and most of the provincial regulations work the same way. Everyone that's doing work within the right-of-way, and in some cases, within 30 meters on either side, has to have a crossing agreement, has to get that permission from the pipeline company to do that work. There aren't any exemptions that I'm aware of. With the, I was talking about the new damage prevention regulations, and under those regulations, pipeline companies will have the ability to give blanket approvals to certain third parties if that's what they choose to do. So they may have a contractor that they have a really good working relationship with. They know all the work that the contractor is going to be doing, and they can, give them a blanket approval for a whole year's worth of excavation or something like that. So the new regulations will be more flexible in that way, but there's no hard and fast rules in that area.
How about enforcement if people don't follow the law?
You know what? We're again one of those people that have some enforcement, not actually in those regulations, but in the National Energy Board Act, which is the act that we operate under. There are some enforcement provisions, up to $1 million per day fines and jail terms and that sort of thing. We would have to turn the case over to Justice Canada, who would have to choose to prosecute. And to be honest, we don't do it. We haven't done it as far as I can recall. What's our compliance approach is really to work cooperatively with the violator to gain compliance. Sometimes that means making them do things that is going to cost them money, and that's sort of how we get around it. Sometimes we make them do a lot of training or a lot of extra work. It's going to cost them money. They get in compliance. It's not really a fine system, but there is a business cost.
But there's a consequence.
Yeah.
Can I just add one thing, Chris, from working with your agency? I think they're different than we are in that they're sort of a combined FERC and OPS, so they do have the sort of the ultimate hammer. If you decide you don't want to play ball with them, the NEB can basically, they have permit authority. Yeah.
Oh, yeah. And under the National Energy Board, we can shut down.
That's the kind of authority you want.
Oh, absolutely.
Okay. Other questions? Please.
Just to expand on that a little bit, there is federal authority that says if you damage a pipeline, you haven't made the call, the federal government can in fact come after you and make life very difficult for you. And if you want the sites, I think it's 49 USC 60122 and 60123, and then there's some other areas. And there are no exemptions in the U.S. federal law, but like the Canadians, we've not really exercised that an awful lot. And my name is John Jacoby. I'm the Community Assistance and Technical Services person for PHMSA here in Houston.
Thank you, John. Yeah, that's criminal authority, and it's what we've been talking about. I know it's very much in play, just to feed on John's, is civil, and other people had asked for that this morning, civil authority that either flows through to a state preferably, so the state's enforcing its own one-call laws, or, I would tell you one other thing. If I can take a moment since it's slowed down, I know we've got one question I'll come back to. I apologize for the delay. We have it. Most of the cats are here. Can I ask them just to stand up for a second? These people, the community assistance and technical services people, come on, don't be shy, including you, Mike. I think you're a cat, aren't you? Okay. Their full-time job is to work with operators and communities and states, and one of their primary functions is in the area of damage prevention. Those people are resources to you that you ought to think about. They're fairly knowledgeable in everything that's going on in the area of damage prevention, so it's something that OPS is trying to offer to people. But that said, there are a lot of states who already have civil enforcement authority and they don't use it. And the CATs have been very instrumental in helping form regional common ground alliances where I'm hoping more localized interests will be able to shake free some changes at state levels that need to be made too. Okay, he's done handing out beads and he's back. Thank you. All right, good. All right, I'm sorry, sir. Yeah, I know you had a question.
Don Versus, Pipeline Safety, Rhode Island, representing NAPS. I don't think anyone else is here from NAPS, is there?
I think there's one other person. He's not a manager, though.
That's a big showing. Anyway, my question is for Daphne. You mentioned GasNet and the sensor system, and you said there was a vibration monitor in that system.
Yeah.
Do you know if that can monitor cast iron vibration?
What type of vibration?
In other words, we have a lot of cast iron main breaks. Third-party damage in Rhode Island is cast iron main breaks due to frost.
Oh, yeah.
We've had 3 reportable incidences in the last 3 years, and got over 1,000 miles of pipe, cast iron.
Yeah, it's intended to measure vibration from external sources near the pipe.
All right, have you gone down that road to try to see if you could use it or hook it up some way to identify a cast iron situation where you may have a problem, where you could monitor and maybe get a heads up that this area, could be more prone to cast iron main break?
I think it could be extended in that area. I don't know if we've tried that yet. No.
Is there somewhere I can get some information on that?
Yeah, we if you pass the card, we'll get you some more information on it.
And the second question, you made a statement that the equipment was very expensive on GPR, that some companies in their own end budget, they couldn't afford to buy one of those.
Yeah.
Yeah, I think what you got to do is, if the company doesn't have the money in their own end budget, they're more than happy to go to the PUC, who I know a lot of people think they're like the Capital One commercial, and everything's no, no, no. But if you go there with the intent of public safety, I mean, it's very hard for them to say, no, don't buy the equipment. And it's certainly something somebody could buy, and you don't use it that much. You could, share it amongst companies, but there's a lot of business people out there would buy one and get into the marketing business just like they do that today.
Yeah, it's an interesting point. I mean, several companies are spending money, but the point has been that it's a combination of kind of high price and difficulty in user interpretation that has limited that market. Now, the existing technologies sell for anywhere from $8,000 to $35,000 in terms of buying one of those GPR locating cards. But when you get down to, $5,000 to $10,000, then you have more parties willing to buy product. But the discussion in all these years has not really come up to go and petition the PUCs to get money to buy them. So that's an interesting approach. But our goal right now is to get, as I mentioned in that talk on the handheld, is to get that product cost down below $10,000 to more to the order of $5,000 to $8,000. And one of those technologies that was in the first presentation is selling it. It's the low end for the cart mounted is selling at about $8,000. So that's where our folks feel we need to be, and many of them have been upwards of $20,000.
Okay, and then the last point I'd like to make is enforcement is very big. It's very popular in the state of Rhode Island. Unfortunately, my $200 first offense fine doesn't really have the poke in the eye that I'd like to have. We can get more money for speeding ticket, and we don't have any. We just put in some new legislation for pre-marking in Rhode Island, which we think is going to reduce the amount of unnecessary calls that we have today. We like that idea to reduce the expense on the rate paying everybody else. Thanks.
Great. Thank you very much. Other questions? Sir.
Yeah, my name is Dan Spangler. I'm with BP Pipelines. I'm with our office up in Tulsa, Oklahoma. I have a question around external monitoring. One of the technologies that I didn't hear much about today was UAVs, and I was wanting to know if anybody here on the panel had any experience with that technology, or maybe anybody here in the audience as well.
I'll address that one. Jim Merritt from the Office of Pipeline Safety. We have a UAV program running right now, and it's in the demonstration phase, and ElectriCorps is here as the program manager. The lady from ElectriCorps, is she still in the room? I can't see. There's a lady from ElectriCorps here that can address the discussion, and I can meet you after this meeting and give you the website address and so forth to talk about UAV technology. Basically what they're doing is ElectriCorps is working with Air Environment, and Air Environment is the ‑1 supplier to DOD for the UAV program. And what we're trying to do there is to take a DOD designed UAV and have it monitor and inspect pipelines for leakage and encroachment monitoring. And they've been very successful in running some demonstration tests on it recently, and they're looking for some pipeline operators now to interface with to run some pipelines and do some inspection tests on it. That's on a UAV program. On ITT has a fixed aircraft program that we've been running for the last year and a half now, which is a manned aircraft, and it's doing much more than just monitoring. It's looking for gas leaks and other issues. Both those programs are currently employed on one of our programs. Yeah, that's the HALOS project. UAV is unmanned aerial vehicle.
Great. Yeah, maybe we can get a chance to talk after the
yes,
after the meeting.
My name is Vance Bowen. I'm with Advanced Spatial Technologies. My question is for Daphne, Harvey, and Jeff. Living in a perfect world, like it would be if we all knew the Federal Register like John Jacoby,
he studied.
Who's going to make the spatial markings? Who's going to pay for those spatial markings? And how long is it going to take before it gets to the point to where it is actually useful for excavation contractors?
Tell us what you mean.
Yeah, what do you mean by spatial markings?
The spatial markings are the latitude and longitude of easements, corridors, devices, assets, whatever. Those are going to have to be marked before the gentleman Harvey talked about with the Nextel phone can call in to the one-call system, and the one-call system can give him either an okay or a wait a minute. So how are we going to get that into the one-call system?
I think it's going to be a gradual system. Right now, I think a lot of this data that's on an address and the one calls can be mapped into GPS, and it will just have greater uncertainties associated with it. And as people do GPS their utilities, that data will go into the system and it will have lower uncertainties. That's the way I envision it. To be honest, though, I really don't know.
I'll just comment real quickly if I can, since it's. I'll make sure I'm on target. So start shaking your head like that if I'm off target. Okay, good. Thank you. I'm on so far. You know, one of the programs that I manage is National Pipeline Mapping System. It is geospatial reference points for all the transmission pipelines, not distribution, just transmission pipelines in the country. The accuracy of that system for a lot of historical reasons is plus or minus 500 feet, so I think we know what that means. A lot of the operators, that said, actually have GPS accurate coordinates on their pipelines. I see that, as Harvey said, sort of being an iterative process and is continually getting better. The thing I would raise for you is, you know, and I know that you would know this, Ben, if you're in that field, is the security issues. You know, the whole notion of serving up the whole underground infrastructure over the internet to anybody who wants it anywhere in the world is probably not going to be highly favored by the security apparatus. So that said, the way the one-call systems have worked, and there are flaws in this too, which you may already be aware of, is that they grid, and they work with the utility operators to understand which grids their utilities are located in. So I think the theory is, as we were talking with electronic white lining, is that the excavator in one of several variety of ways comes in and says, really, I can give you a geospatial point where I'm planning to excavate, and it's up to the one call center to run the interference to say who has infrastructure in that area. And they notify the utility operator, who then goes out and locates the line and then comes back with a positive confirmation to the excavator. But, you know, I think in a perfect world, as you were starting out, that's exactly what we'd do. We'd have people having GPS accurate coordinates on all of their underground utilities, and we'd have that available to people, but we don't live in a perfect world. And I can't imagine a day when, in the near future, when we serve up the whole underground utility infrastructure to anybody who wants it anywhere. So, thank you. Okay.
There's another aspect of that, and that I mentioned pictures. I know they weren't in any of my slides, but if you can go out there with a cell phone, almost all of them have a camera on them nowadays, and you could take 4 or 5 snapshots and submit those with your record, and I think that would help people too, in addition to the GPS locations. I think it's more than just GPS locations. It's having multiple data. So if you have an address and a grid and a GPS and some pictures, then people can hopefully make sure their locate's in the right place, and will also help them narrow into exactly the correct location.
Just a quick add to that one, if I can, and I think that's absolutely right, because we see it's more complicated than it seems on the surface, like everything in the world, right? Somebody's excavating, but what they're really saying to you is, we're planning on running this excavation down this side of the street, but if we run into major problems here, we may have to switch sides of the street. So having a visual reference, so like the orthorectified photography, that lays on top, that they could access and say, look, here's the bounds of the only places we're going to, it will really narrow it. You're not going to be mobilizing a locate crew 3 blocks away. They're going to be on 1 or 2 sides of that street doing the markings there, and that will save a lot of money, hopefully. I'm sorry, can't see over there, so I've lost track of you already. Oh, okay, that was one of those. All right, so after you, sir.
Keith Levis with PPIC.
Uh-huh.
I had an observation. I noticed that in the talks that Wilkie did was a little different than yours and Dave's. And you were talking about prevention, and I think Wilkie was talking a bit more about detection and characterization. And in many cases, there's sort of a communications gap as well. If I look at all the research that's been done, then most of it's also on the detection and characterization. But then you showed a slide, Jeff, where all the deaths are on the prevention end. Maybe this is a question for the entire panel. Should we be spending more effort and time on the things that Masood's doing, on the communications aspect, because we've developed 1162, for example, 1166 lately. Should we be talking about more integration and communications, making it easier for people to know what's going on? If they cut the grass and got rid of the markings, who do you call? All that sort of stuff. Is that the sort of emphasis we should be putting on, rather than real time, which is usually too late because it's already hit, or ILI, which is really expensive, and it's only a very few. Admittedly, they do all make the paper, as we saw in the Belgian one.
And periodically kill large numbers of people when they actually go. Those are the ones that we really worry about.
Yeah, but over here, it's the prevention that's killed people. And the one in Belgium was the big one that was after the fact. But the after the fact ones have changed the legislation. So it's important to do both. But should we be taking some of the resources from detection and characterization and making it easier to prevent, to make sure that the person who's there, because there's always a person, whether they report it or not, is aware and follows up and reports and does all those other things. So that's a question for the whole panel. Should we maybe change some of the influence through things that we're going to bring up in the next day?
I'll take a swing at that, but let me let others comment on it first.
Well, I'll be glad to take a swing at that, Keith, since we used to have offices next door to each other.
You guys have argued this point before.
In fact, he's always been on that side. I used to be on the other side, so I've now joined Keith's side of the argument. But I think in terms of inline inspection and mechanical damage, you're right, there aren't many incidents in that area, but as we start to do more inline inspection, we're going to find a lot of rock dents, and there are a bunch of those out there, and those are pretty benign. So I think I'm sure we're going to talk about this some more tomorrow, but one of the things that people want to do when they do ILI and characterize mechanical damage is they want to find out what they don't have to pay attention to. If they can leave a lot of that in the ground and never have to excavate it, that will allow them to eliminate a lot of their activities in that area. I guess that's the major point I was going to make there.
I'll take a swing at Keith, too.
Keith, get up here so we can swing it.
Can you get up here? You get closer so I can swing at you.
In fact, I'll hold in. You go ahead and swing at him.
No. I'll certainly reinforce what Harvey said as well. I mean, the mantra's got to be prevent and detect, but prevent first, then detect. It is critical, as Keith and Harvey and most of the operators know, that we do have a lot of that damage out there, and we do need the tools to characterize it appropriately. We need performance-based regulations based on good, solid science so that we can do what Harvey suggests, that we can say just because it's a 2% dent on the top of the pipe with metal loss, you have to dig it up. That just does not make any sense, and I suspect there'll be a lot of discussion about that tomorrow. But again, if it were me, if it was my money, I would put the focus on the prevention side because we're not very good at that yet. And again, the statistics are very clear, both in Canada and here, that the damage that's out there, the latent damage that's out there is not critical. If you can prevent the damage from occurring, you've done most of the good.
There's one other thing I was going to bring up, Keith, and if you look at the incident statistics, what John presented this morning, John Kiefner, is he presented the total statistics. If you go in and you look at the ruptures, you'll find that although immediate damage is still the larger cause, the ratio isn't 9-to-1 and 5-to-1 anymore. It's come down quite a bit. If you look at ruptures, the previously damaged pipe comes up to like the fourth leading category of it's over 10% of the ruptures out there. So you have to look at severity in addition to just numbers.
I hope that's not just between me and the panel, because we need to get other people involved too. But I think if you look in since we got the new rules in place for reporting, we've had one corrosion one, which is the worst one we've ever had, and all the others have been third-party and media. Okay, and that's for fatalities. And so I'm just saying we need to put more emphasis. You know, this thing here, when I turn it off, they don't know where I am. When I turn it on, they triangulate. There's one of these on every backhoe. You know, so there's technology out there. We need to use that, and we need to get some of the spatial stuff. We need to talk about how we can protect information. Maps are a big problem. Should they be housed under one calls? And then who has access to it? Or should they be distributed? How come gas pays for everything in liquid and not some of the other folks as well? Those are things that most people don't think about as research, but it takes time, money, and effort in order to do those sorts of things. And the people in the room know those questions and probably have answers. Well, I just wanted to get the panel to talk about some of that.
If I can just, for a comment, I think you raise good points that ought to be part of the focus in the study when we come forward and talk about allocation of resources. So I don't want to detract from your point, but if I can, I want to build on a point I tried to make earlier. And this is a dilemma we face in a lot of areas, whether it's encroachment or whether it's integrity management. We have, as you probably know, we've gone to FERC and we've gone to NARUC and we've gone to others and say, you really ought to be considering the investments that companies are making in this infrastructure. And you ought to be finding a way to get those companies compensated for those investments in this infrastructure. And why do I say that? Because of the points I made earlier about the growing criticality of the infrastructure, the growing capacity challenges that we're facing in this country. The flexibility that used to be in the system, is diminishing. In the old, we asked FERC, point blank, the heads of their regulatory programs just a couple of weeks ago. It said, hey, and when you do your public determinations anymore, it used to be minimum build. Do the minimum build you can do and get away with, and that's it. We said, well, in the post-9/11 world, does that make sense now? Because what we're seeing in the integrity world is companies are coming back to FERC and they're saying, hey, we got a lot of issues with this pipeline. We're going to need to do a lot of repairs in this line. We just as soon go ahead and replace it, but we want to replace it with bigger diameter pipe. And I'm sorry, just as a layman in the field, that makes good sense to me. But it's tough for FERC. FERC's in a tough spot. So these are good questions to bring out. I think there are things that we should focus on. I stumble over, with apologies because I've known him for a long time and he won't take it personally, the notion of shifting resources. I think we're doing a lot and we're going to do a lot that in the public awareness area that needs to be done, so I wouldn't diminish any of that stuff. I think we need to get smarter about how we do things and find cheaper ways to do things. You know, we used to say the things about sending out 50,000 mailers every year, or the bill inserts, I think we were talking about that. How many people who are not in the business read them? You know, is it really an effective way of communication? So, you know, I don't want to detract from your point, nor do I want to stay on the soapbox any longer, but I do think that there's value in trying to focus, you know, what we know and what we are unsure of, so that when we base our integrity decisions on the things that we're unsure of, at least we're aware of it. So, all right, that's it. Anybody else? Keith's always a rabble-rouser, so and we're glad for it.
You know, I guess I would just add that, you know, in our experience in working with a working group on damage prevention, and it is prevention, not just detection, it seems to me there's been finger-pointing between industries, you know, telecom, utilities, and the thing that I thought was very useful is the development and expansion of Common Ground Alliance, because that's where everybody sits at the table from every industry, and if there could be more technology development intertwined with Common Ground Alliance or more organizations like Common Ground Alliance, then you wouldn't have the finger pointing, and then you would have more focus on prevention.
Okay, other questions? I mean, and panelists, feel free to ask questions of anyone in the audience who's, you know, been particularly troublesome or anything. So, all right, including Chris Foley. So.
This is an easy one.
Oh, okay.
On the matrix that you handed out this morning, you have the liquid industries confidence level in aerial patrol rated as low. I was curious if that's a typo, and if it's not, can anybody comment on why it got rated a low?
Gwinnett, do you know who, Bob, who completed for the liquid side? Was it Ben?
Hey, this is Bob Smith with PHMSA. It was a collaborative effort. It could be a typo, but there may be some reasoning behind that. I'd like to hear more about it, maybe with the Baker study, about duly noted.
Is there a way we could get an answer to that by tomorrow, whether it is a typo or not? If it's a typo, I don't need to go any farther. If it's not a typo,
by tomorrow may be difficult, but it should be taken as a guide as best as possible. I think the study itself would try to flesh out any differences. We're not trying to, the purpose of the workshop isn't now to discern why there's a difference in opinion. It's to raise the issue that there was noted the difference in opinion, and for further investigation we'll kind of flesh some of the issues out.
Okay. Yeah, it needs to be a typo.
It sounds like it's a typo,
yeah,
yes.
So
that's the intent,
yeah.
yes.
So I was kind of hoping maybe somebody could find out, hey, is that a typo or not, and just drop it.
Yeah, but Chris highlights a good point, you know, and if I can, I'm going to bring it back to, what are we doing here besides enjoying the opportunity to talk about subjects that we're really interested in? We're trying to inform a study, so if you think those things are off base, you know, you should provide some feedback to us. You know, it's always difficult to develop a consensus, you know, and particularly when people are busy. It's meant to be a starting point for discussion. So, you know, we've done some investment in aerial patrolling ourselves and airborne leak detection. I don't know, Jim, if you want to comment, but Chris, we can certainly do that within the context of the study.
One of the biggest drivers that we've seen in airborne surveillance of pipelines is the cost to fly the air cost. We're hearing prices anywhere from $175 to $250 or higher per mile to fly the pipeline and inspect it for leaks and encroachment and so forth. And the two programs that OPS is funding, the Helios program and with ITT and the Air Environment program with UAVs through ElectroCorps, are both driven at trying to drive those costs down and find it cost effective to look at those issues.
Recalling back when putting this matrix together, I think one of the points on why it perhaps was a lower confidence level was the idea that FAA flight restrictions in some areas, maybe it's an issue of not being able to apply fixed wing versus helicopter versus UAV in all situations. So.
I thought this was a survey of operators, but someone just explained to me that it really isn't. So. Gotcha. Good.
Yeah, Leith Watkins with Explorer Pipeline. Jeffrey, I'm trying to recall from Keith Meyer's talk this morning as far as the Michael Baker reports. We've basically spent half of the conference in the prevention side, which I personally think is great. I was wondering if the mandate or the scope of work of the report will be similar in that it will be quite focused on the prevention side of mechanical damage.
Well, Keith's going to come up in just a minute and actually kind of address the report, and we'll go into that. But that said, you know, our purpose in this one was a fairly narrow purpose. We were trying to have a technology focus that would go past prevention into detection and characterization. We're doing that on purpose because we're engaged with a lot of people in the prevention end that's not the technology aspects. And while many of us, you know, love that area and really embrace it and see that as a key to preventing damage to the infrastructure, again, the point of this one was to do a technology assessment because we had run into a lot of problems in the field with disconnects between federal regulators, state regulators, operators, you know, vendors, you know, trade associations and others, and just sort of having disparate levels of knowledge of things. Our goal in this study was to try to raise all boats, you know, and get to one point where we have that common level of understanding, and maybe, you know, as Chris was pointing out, we can spend some time firming up our collective assessment of where our confidence is. But it helps us in a lot of ways. It helps us in the integrity program. It helps us in the R&D program when we decide to go forward and say, where should we focus our investment so that we're sure that they're returning some value. But I think we'll cover both sides.
Okay, thank you.
Okay, sure. It's the disadvantage of standing up, you know, in a Q&A session. You can.
Joe O'Connell with BP Pipelines. Jeff, could you be more specific on those disconnects you referred to so that we all have a better understanding of what the driver is?
Well, sure, I'll try. I talked about it briefly this morning. In the integrity management world, for example, that's one example. We have been working with our state partners to try to define sort of a protocol-driven inspection methodology. And we run through the protocols, and many parts of the protocols get into risk identification. When we get into the risk identification and then follow up with risk assessment, and it's interesting to sit in a room with state people, federal people, operators, and sometimes their vendors, and talk about what technology they're applying and why they applied that technology. And as I said, in life there's a normal distribution. Most operators would know. They know what kind of pipe they have in the ground. They know what its susceptibilities are. They know what their operational history and failure history was. They know why they chose that tool. And the tool will help reveal something that they need for the purposes of their risk assessment. But it is interesting as you get into those debates to find out how people view something that's fairly common differently. So as we did with stress corrosion cracking, when we feel that there is a disconnect between the federal and the state people when we're talking, disparate levels of knowledge, or when we're talking with operators, as I said, in different settings, sometimes a compliance setting, for example. An operator might take a more conservative position in a compliance setting than they would in a setting where they're looking for an interpretation or a waiver. So there's a lot of different situations that lead to those disconnects. Our goal is really more to develop consensus amongst people on confidence and capabilities of the different technologies.
I'd be remiss if I didn't ask it because I told you this morning it's one of those questions we want to answer is what is mechanical damage? The two great panels today talked a lot about encroachment on the right-of-way. Do you think that the study would be overstepping if we talked about land subsidence and those kinds of things that may lead to a lowering of the ultimate state of the pipe? Sounds like we have enough information here. What's your opinion?
Well, I've never been faulted for not having an opinion.
So I think the answer to the question is yes, it would be overstating. I think you need to focus on true mechanical damage where there's impact to the pipe, dents particularly, not wrinkles, not buckles, not things like that.
If I may add to what Jerry just said, we had yesterday afternoon in a PRCI meeting that he was hosting at Panhandle, just the same discussion, how do you define mechanical damage, and with Dave Batt we turned around words like direct impact, and maybe to take into account rock dents, we eventually found out something like direct contact with the pipe wall, so that definitely excludes damage due to ground movement. And you could see that in demand, at least in Europe, the ground movement is identified as a distinct cause as compared to external interference for a very simple reason, is because you mitigate it with totally different approaches. So I don't think that one-call systems make any sense in to mitigate ground movements.
Any other questions? Sir?
David Batt, consultant to PRCI. Actually changing the subject because you've just answered the point I was about to raise, but my question actually is prompted by something that John Kiefner said this morning. I don't know if John's still here, but by default I think, Jeff, the question may fall to you. And
That's going to teach me to stand up, isn't it? So.
It concerns the incident statistics, the reportable defects. The threshold of $50,000, which is one of the criteria, is obviously a sliding scale. And John presented us data over 20 years, during which time that due to inflation, that must have changed by a factor of 2, 3, maybe 5. And it's obviously having an effect on the time-dependent trends that you might get out of that data. Have DOT or whoever owns the incident database actually tried to disentangle that? And I know Keith Levis just alluded to new criteria that have been introduced. Is there any attempt being made to take out that factor? Because when those of us who try and compare what's coming out of the US with what's coming out of Europe or elsewhere, it's a constant problem trying to actually understand what the time-dependent trends are in the U.S. data.
Well, if I can, I'd like to answer in two ways. One is, it is of great interest to me within the context of the study, to talk about the different ways that people define, whether it's in Europe, whether it's in Canada, and where it's in the U.S., and highlight how it's different. That said, it's particularly true, and I'm going to get smacked probably by the liquid people for saying this, but it's particularly true on the gas side. The cost of gas issue is very much live. Roger Little, who unfortunately is not here, who is our sort of the data guru for the Office of Pipeline Safety, has just completed a cost of gas analysis, because we've been being lobbied hard by the industry that said the $50,000 reporting threshold is being tripped far more frequently now because of the price of gas. That makes a lot of sense to all of us. Very active debate whether it shouldn't be a volumetric loss, and talking about that. So I think, while I don't have an answer for you, I tell you one of the things that we have done, and Blaine Keener, who's in the back, has been working with me on what we call our stakeholder communications website that tries to portray the statistics in a more useful way to the general public. We are differentiating now. I don't know if it's live now, Blaine, or not. No, it's not, but it should be very soon. And it is to segregate those out. So we were trying to segregate, cost of gas out. We were looking also at public versus private damage, because I think that's another aspect on this. So it's very much a live debate and a good question.
David? One of the other things that has been done is taking a look, actually taking out the monetary component and looking at what the American Gas Foundation called serious incidents, those resulting in a death or injury, and looking for trends. I know that the American Gas Foundation created a report primarily focused on distribution operators, but also looking at transmission and others. That's available on We have a link on it from the American Gas Association's website that's available to everyone.
And great minds, just proving great minds think alike. We have recently changed the performance metrics for our agency's pipeline safety program, trying to make sure I get this right every time I say it, and to be serious incidents. And really partially in reflection of the point that you just made, but also in reflection of the fact that we've geared a lot of our programs to reducing high consequence accidents. So, thank you. Other questions? All right. Keith had, I talked with Keith during a break, Keith Meyer, who is really the principal point. Tom, did you had one?
Actually, I apologize because I walked out on that. There was some look, and that's a good question that you have, David, but there had been back in mid-'80s or so when the reporting requirements changed from 5,000 to 50,000, a pretty significant change in the ratio of what was significant and what was not. For example, there were a lot more corrosion cases that might have been referred before or after that because certain things cost a lot more money. Anyway, your point is well taken, and it may not be a bad idea to go back and look a little bit harder at how that dollar threshold affects the reporting values. I'm pretty sure elsewhere in the world they don't have the same set of numbers, and so you might see things that were relatively easy to deal with not being reported here. Plus, I think a lot of times, too, things that previously would not have been reported, either because of size, 5 gallons, or because at that point people really weren't that concerned about smaller releases, so they didn't necessarily get reported, so that sort of thing.
Yeah, sure. And I would certainly say, and I echo back to what I had said earlier in the day, one of the things going forward, we need to have a more shared analysis. So while John was, John's group has done great work at mining the data, which we don't do enough of, and I had highlighted that as one of our problems. It doesn't happen all the time. It's happening for B31.4, as far as I understand. I don't think for B31.8, nor do I think that he's done anything on the distribution side for a while. And I'm not saying John ought to necessarily always do it, but what we ought to have is some sort of a shared understanding, because there are lots of quirks in the data. Once you get familiar with it, like anywhere you go, there are quirks in the data, and you have to understand the quirks in order to interpret it. But having a shared agreement on what the data say is pretty critical. So, okay. I'd ask Keith if he would come up and just sort of feel free to ask questions of the panel or the audience, but also to make a few comments about things that he's observed from today's session. Mind you, we're going to do this again tomorrow, so everybody will be bright and perky tomorrow, and we'll have all of our questions in. Thank you.
Just maybe I would like to react to what was just said, in the sense that definitely what you call serious accidents are important to be identified, so because they represent the performance or the safety record of the industry, but all the other incidents or leaks are also important to be analyzed for the industry, because they are what you would call hazardous situations, and always in safety, if this is sort of the basis of the pyramid, if you get significant cuts to the hazardous situation, then the top of the pyramid with the serious incidents will shrink a lot. So we need probably both of them.
I guess since Perez is piping in on that subject, I thought I would too. I think the IGU has just finished a study on comparing databases around the world, and they're going to publish it this year at the World Gas Conference. And one of the recommendations out of there is to actually change this in the U.S. incident database and go to the threshold that everybody else in the world has, which is any unplanned release. But in a way, we have that in the U.S. already. As of 2002, I think that all the leaks are reported, and they're now categories into 6 categories. Is that right? They're not I don't know how you count it. You can count up to 45 categories or whatever with the new database. But the thing that you don't want to require is, right now there's a 24-hour reporting requirement for all incidents. And for little leaks, you don't want to have that 24-hour reporting requirement. So if you do it on an annual basis, I think that's sufficient. It could be you just need to focus on maybe categorizing the leaks that are reported more.
Well, to wrap up, boy, what a great panel this morning. It was just great. And part of a conference is always to meet new people and talk with them like I did today. I learned a lot. I have an idea of at least these two panels' definition. I'd like you to weigh in because I believe that we might get some differing opinions from the characterization people who probably think, metal is metal wherever it came from. So we haven't actually made that conclusion of what mechanical damage will be for the study, but I hear clearly these two panels and what you feel it should be. I really like the Canadian presentation today, and I've already tried to make some plans to go over and visit and learn a little bit more about how regulations might take part in that. It sounded like the crossing example that was given, and maybe see these new regulations really are effective in Canada, even though it's not that great a problem in any case. And I'd like to learn some more about that. I take back what I said today about the one-call program. Maybe it has plateaued. No, it looks like I learned a lot today that there is marrying of the one-call program and a lot of room to expand with that with new technology, namely the Internet and maybe GPS and cell phones. What great ideas, and I think I'd like to make more of that. And one of the things I'm standing up here for right now is to ask, especially operating companies, if they have experience in that kind of Panhandle clearly, but other experience in making an Internet-enabled on-call system. I'd really appreciate some more information about that. In addition, we will probably be sending out after this, as we usually do in these seminars, some questionnaires for the operators based on information that was asked about and perhaps talked about in this workshop. However, right now I'd like to ask you, in addition, the operators to think about contacting Baker for their information about field tests on any of the new technology. Acoustics was mentioned. Those kind of detection technologies, either point source or otherwise, that were mentioned today, I'd really like to find out some case studies of some operator experience in that areas, and would be happy to come to your place to do an interview and put that into the report. And finally, I'm just looking forward to tomorrow, and I hope you're having as much fun as I am. Thank you.
I'm Bob Smith from PHMSA, and to give Jeff Weiss a break from his diligence today, I'm going to conclude the session and kind of talk about some of the summary and next steps. I thought today was a wonderful day. I thought we had some great opening presentations with the industry and government perspectives. I think we had a very good understanding of how big the problem is in the U.S., Canada, and elsewhere. It really was a good segue into the panel today on prevention. I think we really were reminded how important prevention is. Of course, we all know the saying, an ounce of prevention is something I think we really need to pay attention to when it comes to some of this stuff. I wanted to kind of just recap some of the points that was made in this general session. And really the next step for these points are how we kind of craft the prevention part of the Baker study. So we look forward to seeing how that's going to be implemented in. But some of the points that were major that I saw, and perhaps Baker, Christine Marinek, or others could illustrate if I had missed one. But definitely we need to take a look at the idea. Are we focusing too much on the idea of just developing technology without integrating in how humans are going to use the technology and apply the technology? So whether or not, when we are developing technology, do we need to put priority into the scope of developing and looking at the human's role? We heard about the spatial markings, of course, the GPS integration, the one call, and probably just a more broader aspect of just bringing as much technology as we can into the one call process, and perhaps a little bit of understanding of what kind of security challenges we may be faced with using things like the World Wide Web, for instance, with the one call process or other aspects of technology in a post-911 world. Another topic of importance was, how much should we focus on
on technology development versus communication. We talked about all the investment going into the real-time systems and inline inspection that we're going to hear about tomorrow. What's the balance there? Jeff, as well as many others, talked about making data-driven decisions. I think that's really important on how we develop technology, to know that we're developing the right technology for the right application. And once again, the idea of determining the focus on prevention versus detection and characterization and ultimately remediation. And we did hear that we need to have a strong focus to an extent in the Baker study looking at prevention. I just want to reiterate that. We talked about how much of the aspect of geoforces on pipelines play into the role of mechanical damage, once again into the broader issue of how do you define it. So I know that's going to be one major aspect of the study, that hopefully a conclusion comes out where we could have a standard reference point on how we do define mechanical damage. And a very interesting one about organizations like PHMSA and many others that collect statistics. The idea of taking out time issues, whether it be the time value of money or other political or social issues out of the stats that we know are part of them, and to see what kind of clearer picture we have to make better data-driven decisions. And that's basically what I had captured, and I think all of which should be considered as part of what we developed to be the scope, at least for the prevention aspect of the Baker study. I guess let's give a final opportunity if there was any major points that were perhaps missed. We want to be able to capture that and address it in the study, referencing back to the matrices that were in part of the handout. It was our best attempt walking in the door here to try to, as a group, as a steering committee group, to define mechanical damage as best we could and identify technologies. Confidence levels, of course, is something that I think we'll flesh out in more extent with the study. Any final comments from the floor or from the webcast attendees? Okay, with that, just a reminder that the second day of this event starts tomorrow at 8 a.m. And once again, a thank you for Baker Hughes for picking up the coffee break this afternoon. Thank you.